Guys, this video is going to be really helpful if you are planning to review the complete AP Calc AB for the upcoming 2026 exam. This video has all the units, all the 8 units. There are timestamp as well, so you can go to the chapter that you're most struggling with. You can pair this video with the worksheet, unit-wise worksheets. The link is also in the description. So feel free to make the most out of this video, and if you need private tutoring, feel free to reach out. Uh, Estimate the limit if it exists. Limit of x is approaching to 3. So of course you might be asking that which one is a filled circle and which one is an open circle. It doesn't really matter honestly, because limit x approaching to 3, if you remember, we approach limit from the left side and from the right side. So left side of the 3 is definitely right here, which is -1. So limit x approaching to 3 minus fx, I'm gonna say, is -1. And from the right side, limit x approaching to 3 plus of fx is going to be somewhere over here, which is 0. So they are unequal, so the limit does not exist. Option E makes the best sense. Okay. Use this graph to estimate the following limit or explain why they do not exist. So we have oh my goodness, 6 questions over here. The first one is limit x is approaching to -1 plus. -1 plus. So where is -1? Right here. Plus means a little more than -1. So a little more than -1 means I'm looking towards the right side. And obviously it makes sense because there is not even any graph on the left side. So just on the right of -1, we can see that the y value is 1. So the answer for A is just 1. This is 1 minus, notice carefully, 1 minus, not -1 minus. The previous question was -1. So 1 minus means 1 is right here, and minus means a little less than 1, which is of course this piece, and this piece is also approaching to 1. So this is also 1. Next is 1 plus. Yes, 1 plus will be towards obviously the right side. So right side of the 1 is this portion, and this portion is at 2. So C is 2. Then limit x approaching to 1. Obviously, this does not exist because limit x approaching to 1 minus is 1 and 1 plus is 2. So they are not equal. So the limit does not exist for this one. And for E, limit x approaching to 2. So 2, whether you approach from the left side or whether you approach from the right side, you approach the same functional value, which is 1. So the answer is 1. And then finally x approaching to 3. So okay, this is an interesting one because you might think that I mean, there is no graph on the right side, so is the limit does not exist? No, these are called one-sided limit, that if the function is only on any one side of that particular value, then you just take the value of that side. So since there is a function on the left side, we just take that point, which is obviously just approaching to 0. So in other words, what I want to say is limit x approaching to 3 fx in this case is same as limit x approaching to 3 minus fx, because there is no graph on the right side of the 3, and hence the answer is just 0 for question number F. All right, hope that makes sense. Question number 3, they are asking to find the limit of this. Of course, if you plug in 2 directly using a direct substitution, it will not work because 2 square is 4, 4 minus 4 is 0. So that will become 0 over 2 cube is 8, 8 minus 8 is also 0. So this is an indeterminate form. Obviously, we don't know what this is. Don't think that this is 0. You just don't know what that is. So this is based on factorization, where you factorize the top because top looks like x square minus 2 square, and the bottom looks like x cube minus 2 cube. So both can be factored. X square minus 2 square is x minus 2x plus 2, and x cube minus 2 cube is x minus 2 times x square plus 2 square plus 2 times x. If you do not understand what I did, I'm going to write the identity separately over here, that a square minus b square is nothing but a minus b, a plus b, a very popular difference of perfect square identity used in SAT as well. And a cube minus b cube is a minus b times a square plus b square plus ab. So this is what I used. Now, if you notice carefully, x minus 2 and x minus 2 is gone from both the sides. And now I can just sub in x as 2. So the top will become 2 plus 2, which is 4. The bottom will become 2 square plus 2 square plus 2 times 2, which will be 4 over 2 square is 4, 2 square is 4, 2 times 2 is 4. So 4 over 12, and 4 over 12 is nothing but 1 over 3. So 1 over 3 is option B. That should be our correct choice. Okay. Uh, for what values of A will this thing exist? Okay. Uh, this also, top definitely looks like the difference of perfect square, which I just explained. So, but I'm just gonna rewrite it for the moment. And the bottom can be converted as a difference of perfect square, because it will become x square square minus a square square over here. So this will be limit x approaching a, x square minus a square is x minus a, x plus a. And here also, this is these two inside the parentheses can be treated as the a and b. So a square minus b square will be a minus b and a plus b. And you know what? I'm just gonna go back. I'm just gonna revert the first step to its original expression, because I just saw that there is no need for that, as x square minus a square just appeared at the bottom, right? So these two will then just be gone, and I'll be left with limit x approaching to a 1 over x square plus a square. And I can just plug in x as a now, so it will become 1 over a square plus a square, which is 1 over 2a square. So they're asking that for what values of a will this thing exist? I think it will exist every time, just don't make a as 0. Because if a becomes 0, this will become 1 over 0, which does not exist. I don't want my limit not to exist. I want my limit to exist. So anything but 0. So a should not really be equal to 0. Otherwise, yes, for any real number except 0, it always exists. So it should be option D. Okay. Piecewise function. We need to figure out what is the limit of x approaching to 1. So in this case, you always find limit x approaching to 1 minus separately, and then 1 plus separately. For 1 minus, which is just less than 1, obviously you're looking for this function. So it will be limit x approaching to 1 minus of 3x minus 1. You're going to sub in 1 directly over here, which will be 3 minus 1, which is just 2 over here. And over for this one, you have limit x approaching to 1 plus of f of x. So this will be limit x approaching to 1 plus. What is the function that belongs to x greater than 1? Right here, 3 over 2x square. So it will be 3 over 2 times 1 square, which is just 3 over 2. Clearly, 2 and 3 over 2 are not equal, so limit does not exist for this one. Okay. This is based on simplification. So let's just simplify the denominator first. Obviously, you can try plugging in -3 directly, but it will give you a 0 over 0 form. So direct substitution will not really work. This will become x plus 3 over, let's take a common denominator here, which will be 3x, and the top will be 3 plus x. Okay, be careful here. We want to use a keep change flip scenario. I can write one more step so that it makes sense. This can be written as x plus 3 divided by 3 plus x over 3x. I've not really done anything special. Just replace this division symbol with this division symbol, because if I use keep change flip now, it will make more sense. So I keep, change, and flip. Right, this is how it's going to look. Now if you notice carefully, these two are just gone, and I can just sub in x as -3, which is 3 times -3, which is just -9. So -9 is A, option A. That should be the correct choice. Okay. Likewise, this question is similar because, yeah, simplification. Again, if you put 0 here, you will get infinity over infinity, which is indeterminate, right? So it's not really 0. We don't know what that is. So we need to simplify this. So let's simplify the denominator as the common denominator is x squared, and we will have 2 plus 105x over here. And once again, I'm going to use keep change flip. So it will be 3 over x squared divided by x squared over 2 plus 105x. So these two are gone, and I'm left with limit x approaching to 0, 3 over 2 plus 105x. And I can just replace x with 0 directly to get 3 over 2, which is definitely a finite number. So it should be option A for this one. All right, this is a standard formula, guys. I know that some schools do not really accept it as standard one, although AP does. So I'm just gonna do it the way school, I mean, I can show both the ways, of course. So the standard formula for tan and sine, for sine and tan is, uh, tan of something over something, if that something approaches to 0, and likewise sine of something over something, if that something approaches to 0, the answer is 1. I'm saying something because it's not necessarily, this will not necessarily be x always. For example, let's say I have limit x approaching to 0, tan of 10x square over 10x square. This will also be 1 because it's something over something, and this something approaches to 0 when x approaches to 0, right? So the answer is still 1. And of course, even if you take the ratio, even if you flip these two guys, the answer doesn't really change. So this will actually be also same as limit x approaching to 0 of x over tan x. That is going to be the same thing. So this is the same thing. We have tan of something over something, or something over tan of something, where something approaches to 0. So the answer is just 1, which is option C over here. Uh, but yeah, like I said, some schools do not accept this. So what they want you to do is to convert tan into sine over cos. So you can definitely do that, convert tan into sine over cos. And this cos jumps up using, again, the keep change flip scenario. I hope you understand this. So this is going to be limit x is approaching to 0, 2x times cos of 2x over sine of 2x. And now you can use this one, which is accepted, something over sine of something, something approaches to 0, answer is 1. And cos of 0 is the other thing. And cos 0, I'm not really bothered about that because cos 0 is 1 and 1 times 1 is 1. So either way, your answer is definitely 1. But yeah, if you use the first one, if you do not have to show the work and all, then yes, go with the tan formula. Okay. This is a very important question, guys, asked repeatedly in AP in multiple ways. The concept, although, remains the same. Okay, again, we need to find left and right side limit. And remember, I cannot find the limit unless I get rid of the absolute value. So I need to get rid of the absolute value first. So finding the left side limit, 2 minus x minus 2 over absolute value of x minus 2. If I put, remember, I'm not putting the limit. I'm just analyzing that where is this guy going. If you put something that is slightly less than 2, maybe 1.9. So 1.9 minus 2 is a positive number or a negative number? It's a negative number. And whenever inside thing of the absolute value is negative, it opens with a negative sign. Again, remember, I'm not putting the limit. I was just checking the behavior of the bottom so that I can get rid of the absolute value. And now you don't even have to place the limit in the first place because these two are gone. And I'm left with limit x approaching to 2 minus of 1 over minus 1. Well, there is no x to put the limit in, so answer is just negative 1, which is the left side of the limit. Left side limit, sorry. The right side limit will be limit x approaching to 2 plus of x minus 2 over absolute value of x minus 2. Likewise, if I put, let's say, 2.01 or 2.1, 2.1 minus 2 is a positive number. Positive number's absolute value is still a positive. So absolute value doesn't have any job. It will disappear. And now these two guys will just cancel each other, and answer is just 1. I mean, obviously there's a limit outside, but limit is useless because there is no x value. So yeah, these are not equal, so the limit does not exist. Uh, Here, if I plug in -1 directly, it will give me, let's see what it gives us. So -1 square plus minus 5 times -1 minus 6 over -1 plus 1. Yeah, it is giving me 0 over 0. So yeah, direct substitution will not really work. What will work in this case is factorization. The top is a very simple quadratic that can be factored as x minus 6 x plus 1, and the denominator x plus 1 remains as it is. Okay, x plus 1 is gone, and I'm left with limit x approaching to -1 x minus 6, and now I can just make a direct substitution which will give me -7. So the answer is just option B. Okay. Oh, this is based on a graph. Let's find this out. For this graph, which of the following is not true? G of -6 is undefined. Where is -6? Uh, G of -6 is undefined. Well, that's definitely not right. Really? Sorry. Oh my God. What am I even doing? This is G of 6. Never mind. G of -6. Yeah, definitely it is undefined. So that's true. We have to find which of the following is not true, or in other words, which of the following is false. Limit x approaching to infinity of gx is 3. It looks like that because this y equal to 3 looks like a horizontal asymptote, because this is like flattening over here. So yeah, that looks like true. X approaching to -6 limit does not exist. That's also true because -6 is a vertical asymptote. Obviously, the limit does not exist, so that's true. G5 is 1, really? G5, no, G5 is definitely not 1. You can see that the dot is over here. This is a hollow circle, this is a filled circle. So this is -2. This is false. And limit x approaching to 5 is 1. Yeah, that's correct. Because if you approach the limit, then you are approaching from left and right side to 1. So the last one is also true over here. So yeah, option D makes perfect sense. This is the one that is not true or false. Okay, whenever we see radicals inside the limits, the first and a very strong approach that could work is rationalization. Some students ask me that how can you rationalize the top? I mean, why not? Rationalization is just a process of converting into a rational number or getting rid of the radicals. There's no compulsion that it is only applicable for the bottom, especially in limits. You can rationalize the top as well. Just do the same thing. So limit x approaching to 9, square root of x minus 9 minus 2 over x minus 9. And the rationalization is a process where we multiply and divide by the conjugate of it. The conjugate of this is square root of x minus 5 plus 2 and over square root of x minus 5 plus 2 over here. So this will be limit x approaching to 9. A minus b and a plus b. If you remember, we just talked about this identity. Difference of perfect square, which is a square. So if you square the square root, that's gone, minus b square. And the denominator remains as it is, which is x minus 9 times square root of x minus 5 plus 2. Okay, so this will become limit x approaching to 9, x minus 5 minus 4 over x minus 9 square root of x minus 5 plus 2. Okay, so this is going to now look like limit x approaching to 9, x minus 9 over x minus 9 times square root of x minus 5 plus 2. X minus 9 is gone. And if we plug in x as 9 now directly, it will become 1 over square root of 9 minus 5 plus 2. 9 minus 5 is 4. Square root of 4 is 2. So 1 over 2 plus 2 is just 1 over 4. That should be our final answer. Is that in the options? Fortunately, yes. Option A, that is the correct choice. Okay. Of the following, the limit which exists is, okay. This definitely does not exist. That's a pretty straightforward thing. If I put x as 0, definitely 1 over 0 squared is 1 over 0, which does not exist. Guys, this is the exact same approach that I've shown earlier as well. Obviously, the absolute value earlier was in the denominator. I can go back to that question. Where was that? Yeah, this one. So in absolute value cases, which is of the form absolute, the same number of the over the absolute value of the same number, and limit x is approaching to the number that is making both of them 0, the answer is always does not exist, because the left side and the right side limits will always disagree with the sign. So I'm not going to solve this again. I hope you understand that this answer is does not exist, because the left hand limit will come out as -1 and right hand limit will come out as 1. This is also does not exist, because if I put sine x as 0, we will get 1 over sine 0. Sine 0 is just 0, and 1 over 0 again does not exist. This is definitely does not exist, because if you remember the ln function from your pre-calc classes, ln function looks like this. And when x approaches to 0, as you can see, this is 0, right? The function is approaching to -infinity, which is also does not exist. E definitely exists, because right now it is 0 over 0 form. But if I take x out from the top, x on the top and bottom cancels. And if I put x as 0, the answer will be 0 plus 2, which is 2. So yes, definitely that is the only one that exists in this list. Okay. At what value of x is this guy discontinuous? So the function is discontinuous wherever denominator is 0. Pretty straightforward. That's for the rational functions, right? So you don't really have to check for any other numbers. X squared minus x plus 2 is a pretty decently factorable quadratic. So x minus 2, x plus 1 are the factors. And like I said, for a rational function, it is discontinuous wherever the denominator is 0. So x minus 2 times x plus 1 should be equal to 0, which means that x minus 2 can be 0 or x plus 1 can be 0, which means that x can be 2 and x can be -1. So 2, -1, there you go. Option C. These are the 2 points where the function is discontinuous. All right, piecewise function, we need to find a value of x where the function is not continuous. Okay, this is a trick question. Because most of the time when we see a piecewise function, we just check at the point where the pieces are changing, which in this case is 5. So I will, the way we do this is we plug in, we find limit x approaching to 5 minus of the function. We find limit x approaching to 5 plus of the function. And we find f of 5 and see whether these three are equal. F of 5 is clearly, this is the function that belongs to x equal to 5. And if I put 5 over there, it is just 1 over 5 minus 3, which is 1 over 2. For x greater than 5, which belongs to 5 plus limit, a little more than 5, if I plug that in over here, that is going to be 1 over 2. And a little less than 5, remember this function belongs to something that is a little less than 5. So that's x approaching to 5 minus of 1 over x minus 3. So if I plug in 5 over here, a little less than 5, I'm going to get 1 over 5 minus 3, which is 1 over 2. So all are equal? Yes, so it is continuous. So we might impulsively tick option E, which is not correct. Because notice carefully that this function in itself is discontinuous at x equal to 3, because clearly that's a VA, it's making the denominator 0. And yes, x equal to 3 is something that is definitely less than 5, so it is discontinuous at x equal to 3. Not at the point where the pieces are breaking, but within a piece there is a discontinuity. Okay. We want this guy to be continuous everywhere. So what is the value of a? So of course, this is just put 1 minus here, 1 plus here, and equate both of them. That's how it works, right? So limit x approaching to 1 minus of the function should be equal to limit x approaching to 1 plus of the function, and should also be equal to f of 1. 1 minus, for 1 minus, the function is x plus 1. For 1 plus, the function is 3 plus ax squared. And for f of 1, the function is just, that is the function, which is 1 plus 1. If I put 1 here, I get 1 plus 1, which is 2. If I put 1 here, I will get 3 plus a. And if I put this here, it is just 2. So obviously 2 and 2 are equal. I just have to set 2 is equal to 3 plus a, which means that negative 1 is equal to a, which means that a should be equal to negative 1 over here, which should be option B over here. Okay. Which of the following is true about this function if fx is this? Okay. We're talking about continuity, whether fx is continuous at 1 or va at 1 or ha at 1 over 2. I know for sure that option 3 is correct. Because if you, not option 3, I mean statement 3 is correct. Because in a rational function, if you open up the top, it is x squared minus 2x plus 1. And this is 2x squared minus 5x plus 3. If you remember, for horizontal asymptote, in case of rational functions, if the degree is same, then the answer is just the ratio of the leading coefficient, right? What is the ratio of the leading coefficient here? On the top, it's 1. Clearly, if there is nothing, there is 1. And on the bottom, it's 2. So the ratio of 1 and 2 is obviously 1 over 2. So statement 3 is definitely correct. Now they're asking at x equal to 1. Okay, for that we need to factorize the denominator. So x squared minus 2x plus 1 remains as it is. And 2x squared minus 5x plus 3 can be written as 2x squared minus 6x, minus 2x minus 3x plus 3. I hope you remember how to factorize the quadratic if the leading coefficient is not 1. So you multiply 2 and 3 to get 6, and then you write minus 5 here. And then you look for two numbers that multiply to 6 and add to negative 5, which are negative 2 and negative 3. So that's x squared minus 2x plus 1. This is 2x. I'm left with x minus 1 here. This is minus 3. I'm left with x minus 1 here. So this will come out as x squared minus 2x plus 1. And here I take x minus 1 out, and I'm left with 2x minus 3. So clearly x equal to 1 is not continuous. This is definitely wrong, because x equal to 1 is going to make the denominator 0. Now the question is x equal to 1 a VA? Well, no, because if we come back to this original function, which is x minus 1 square on the top, and the denominator is now x minus 1 times 2x minus 3. So degree, look at that, it has a common factor on top and bottom, and degree on the top is more than the degree of the bottom. When that happens, it becomes a whole and not a VA. For a VA, the degree of the bottom should be either equal or more than the numerator. So x equal to 1 is not a VA, it is actually a whole. So only statement 3 is correct. It was a slightly tricky question, but I hope it makes sense. Okay, the function fx is continuous at x equal to 1. If fx is this, find k. That's the same thing that we have to do, that we need to figure out limit x approaching to 1 of fx, and that should be equal to obviously f of 1, which is k. So limit x approaching to 1, obviously I will approach 1 either from left side or the right side. So I'm never really equal to 1. I'm always something around 1. So this function is applicable, which is square root of x plus 3 minus square root of 3x plus 1 over x minus 1. Of course, I need to rationalize this. So square root of x plus 3 plus square root of 3x plus 1 on the top, and square root of x plus 3 plus square root of 3x plus 1 at the bottom. And okay, if you want to simplify this, the top will become just just a minus b, a plus b, which is a square minus b square. So first term square, make sure to put a parentheses because there is a negative outside, so it is supposed to be distributed later. And the denominator will just be as it is, which is root of x plus 3 plus root of 3x plus 1 with the x minus 1 sitting outside. Okay, cool. So what do we have over here? Limit x approaching to 1. So x plus 3 minus 3x minus 1. So x plus 3 minus 3x minus 1 over x minus 1 times, oh my goodness, I need to write that entire thing again. So square root of x plus 3 plus square root of 3x plus 1. Okay, x minus 3x is negative 2x and 3 minus 1 is 2. And I'm going to rewrite this by taking a negative 2 as a factor. So if I take negative 2 as a factor, I'm going to end up with negative 2 times x minus 1. And then I'm going to rewrite the denominator, which is x minus 1 times square root of x plus 3 plus square root of 3x plus 1. And now if we notice carefully, these two are gone, which is what I wanted. And now I put x as 1 everywhere. So square root of 3 plus 1 is 4. Square root of 3 plus 1 is 4. Root 4 is 2. 2 plus 2 is 4 again. And negative 2 over 4 is negative 1 over 2. So yeah, a slightly lengthy question, but yeah, negative 1/2. Yeah, it's a relief. It's option D. Should be option D, I think. All right. Which of the following describes the discontinuities associated with this? So what kind of discontinuity we have over here? That's what they're asking. So we need to completely factorize this thing in order to figure out what the discontinuities are. If we factorize the top, that's actually pretty straightforward. That's x minus 3x plus 1. And the bottom is x minus 3x plus 3, difference of perfect square. So if the degree of the top and bottom is same, it becomes a whole. So x minus 3 equal to 0 is going to give me a whole, which is x equal to 3. And if there is only in the denominator, or the degree of the denominator is more, then it becomes a VA over here. So a whole at x equal to 3 and a VA at x equal to negative 3. That makes absolute sense. So the answer should be option C. Okay, given the piecewise function, what is the value of a so that it is continuous? I think this is the almost the same approach. You put 1 minus here, 1 plus here, and f of 1 will also be the same thing. They all should be equal to each other. So I put x as 1 over here, so it will be 4a times 1 cube plus 7 times 1. This should be equal to a plus 2 times 1 raised to 4 is just 1 minus 4. So this will become 4a plus 7 will be equal to a plus 2 minus 4. This will be 4a plus 7 is equal to a minus 2. Subtract a both the sides and subtract 7 both the sides. So this is how it looks. 3a is equal to negative 9, which makes a as negative 3 over here. So it should be option A. That should be the correct choice. Okay, identify VA. So we need to factorize the top and bottom completely. If we factorize the top, this is going to look like x plus 4x minus 1. And the bottom will look like x plus 2x minus 1. And VA is only at this point because x equal to 1, the degree is same at the top and bottom. So that's going to give me a whole. So x plus 2 is equal to 0 is going to give me a VA, which is x equal to negative 2, which should be option B. Okay, we are going to limit as x approaches infinity. So here the idea is again that in a rational function, if the degrees are same, which it is in this case, the answer is just the ratio of the leading coefficient, which is on the top it's 1, at the bottom is 2. So the answer is just 1 over 2. Pretty straightforward if you know the rule. Okay. This is the same idea that which of the following has HA at y equal to negative 1/2. HA happens when x approaches to plus or minus infinity. So this is definitely not the case because here the degree of the denominator is more. So when x approaches to infinity or minus infinity, you will get y equal to 0. Here the degrees are definitely same. So it will be 2 divided by 1. So y equal to 2 is HA. Here the degrees are also same, which will be of the top it will be 1, the bottom is negative 2. So isn't that the answer? Yeah, should be option A. There's no need to check option B. Option A is definitely right. Okay. Which of the following A value, uh, for which of the following A does this exist? Okay, all right. So limit x is approaching to A. Um, Fair enough. Let's take 3 out uh, from here. Okay, I think infinity is definitely an answer because if a approaches to infinity, then this becomes the bottom heavy function, and the bottom heavy when x approaches infinity is 0. So 2 is definitely correct. So 2 is definitely correct means the answer cannot be option A or C. Now let's, what do you call it as? Put negative 2 actually. Let's put negative 2 as A. So limit x approaching to negative 2, I'm checking the third one, 3x squared minus 12 over x cubed minus 8. So if I put negative 2 here, I can put that directly actually if you realize, because negative 2 at the bottom will become negative 8. So this will become negative 2 squared is 4, 4 times 3 is 12, 12 minus 12 is 0. So 0 over negative 16 is just 0. Definitely it exists. So 1 is also correct. But for 2, we need to again check it separately. So let's do that for statement number 1. Limit x approaching to 2 of 3 is taken out, x squared minus 4, and denominator is x cubed minus 8. If you notice carefully, we have done this exact same expression earlier. I think it was question 1 or 2, maybe in the first 5 it was there, where I factorized this as x minus 2 and x plus 2, and factorize the bottom as x minus 2 times x squared plus 2 squared plus 2 times x. So these two are gone. And if I put x equal to 2, yes, definitely I will get a finite number. So yes, this also exists. So all three will exist. All three values of a will make the limit exist. So yeah, option E. Okay, we need to find limit x approaching to 0 over here. So I think I'm going to take x as a factor from the top. I'm left with x minus 1. And x cubed as a factor from the bottom. I'm left with x plus 1 over here. So this will become, 1x will be gone. So x minus 1 over x squared times x plus 1. And if I put x as 0 now, clearly the top will become negative 1 and the bottom will become 0. And negative 1 over 0 is definitely does not exist. So this is different from 0 over 0. Whenever you get a non-zero number over 0, it always does not exist. Okay. The graph of which of the following has y equal to negative 1 as asymptote? Okay, I'm just looking here. Isn't that our answer? Because the degree of top and bottom is same, and the ratio of leading coefficient top and bottom is just negative 1. So that's the horizontal asymptote, right? Because y equal to something is always horizontal asymptote, like something like this. And this one definitely matches with that. Okay. What is this? Okay, this is a very interesting question and a slightly tricky one. Uh, Here we take the 9x square as a factor from the top, because right now it doesn't look like their degrees are same. So if I take 9x square as a factor, remember square root and everything else remains as it is. If I take it as a factor, inside I'm left with 1 plus the other one will become 2 over the thing that I factored out, which is 9x squared. Now, what is the square root of 9x squared? It's not 3x, it's absolute value of 3x. The absolute value is really important over here because that will decide the sign of the limit. Now, if we notice carefully, the x is approaching to positive infinity. So yes, now I can open the absolute value 3x as just 3x because x is going to a positive number. So this is limit x approaching to infinity of this square root of 1 plus 2 over 9x square over 4x plus 3. And now we can see that this is the same as the ratio of the leading coefficient because the degree is same. Don't worry about this radical function. This will just become 0 because the moment you put x as infinity, this becomes 2 over infinity, which is just 0, and 1 plus 0 is just 1. So that expression will not bother us. The answer is just 3 over 4 over here. So 3 over 4 is an option B. That should be our correct choice. Okay. Yeah, here, for example, limit as x is approaching to negative infinity. So I do the same approach where I take 3x square out as a factor. I'm left with 1 minus 4 over 3x square. And the moment I will take the square root of this, I will take absolute value of square root of 3x, correct? And square root of 1 minus that entire thing remains as it is. And now since x is approaching to a negative number, the absolute value will also open with a negative sign. So it will become 3x over negative square root 3x square root 1 minus 4 over 3x square. Remember, I'm not really plugging in the limit right now. I'm just checking the behavior of the absolute value function. And now you can see that since the degree of top and bottom is same, the answer is just the ratio of the leading coefficient, which is just 3 over negative root 3, which is just negative root 3. This guy will just become 0 as I've explained in the previous question. So yeah, answer is negative root 3. And see how careful, they know the traps. That's why they put option A and D both as in root 3 and negative root 3. So if you miss that negative sign here, you might end up marking A, but the answer is D. Okay. Find a limit. Okay, these are one-sided limit. So the question is whether that's infinity or minus infinity. So the way I do these questions is, first off, how do I know it's infinity or minus infinity? Because I just plugged in x as 2. So 1 over 2 minus 2 is 0 and 1 over 0 does not exist. But whether that's infinity or minus infinity, that depends on the sign. So 2 minus means a little less than 2. A little less than 2 may be 1.9. And 1.9 minus 2 is a positive number or a negative number? Negative number. So the answer will be negative infinity. So first I determine whether that's infinity or minus infinity, and then I determine the sign. Okay. For k not equal to 0, what is this? Okay, looks interesting. I'm just gonna factorize the top because I can just see it right away. It will be x minus k, x plus k. And over here, I think I'm gonna take x as a factor and I'm left with x minus k. These two are gone. So I'm left with limit x approaching to k of x plus k over x. So this will be k plus k over k, which is 2k over k, and it's already given that k is not equal to 0, so we are safe. Answer is just 2 because k and k is gone. So option B is the correct choice. Okay. Find the limit of this. This is essentially the same question that we did earlier. They have just complicated this a little bit, but no worries here. When x is approaching to 7, uh, and by the way, there is an option does not exist as well as you might have predicted. That is the correct answer. So I'm going to take 8 out. I'm left with x minus 7 absolute value over 7 minus x. 8 is just thrown outside from the entire limit because that's has no job inside the limit. And I have absolute value of x minus 7 over 7 minus x. No need to solve all this, guys. We know that the answer does not exist because this is the same format as I have mentioned earlier. Left side and right side will differ by a sign, so just D and E. Okay. What is this? I think if we open the denominator, it looks like a minus b, a plus b expression, which is a square minus b square. So the answer will just be the ratio of the leading coefficient, which is 3 over -1. And 3 over -1 is just -3 because limit is approaching to infinity. So the answer is option B. Okay, what is this? Again, the same idea, guys. The degree, the leading coefficient on the top is 1. The leading coefficient on the bottom is -3. They're of the same degree, so the answer is 1 over -3, which is right here. Okay, this tests a little bit of your inverse trick, how much you remember it. I can literally just put it right away. This is a direct substitution question because nothing is going to go cattywampus here. Tan inverse 1 is pi over 4. Sine inverse 1 is pi over 2. So this will be pi over 4 over, if we take the common denominator, I'll get 2 here and pi plus 2 over here. So I'll do keep change flip, but I'm gonna first write it like this. And then I can just say it is keep change flip. So that's pi over 4 times 2 over pi plus 2, which is 2 pi. In fact, 2 times 2 is 4, right? So top is pi, and the bottom, if I multiply 2 inside or distribute, that will be 2 pi plus 4, which looks like option E. That is the correct choice. Okay. We have to find what this is. So obviously, uh, the fight might be between infinity and infinity because the moment I put 1, 1 minus 1 is 0, and 5 over 0 is infinity or minus infinity. But if you notice carefully, this is a square. So it doesn't really matter whether you put left side limit or right side limit, because the square is always going to make this positive. So the answer is always going to be positive infinity over here. It should be option D. Okay. Interested in knowing that which of the following has y equal to 0 as HA? And this happens when it is bottom heavy, right? In all these questions, I think this one looks like a bottom heavy function because the denominator is x squared and the top is just x. So this is y equal to 0. Yeah, option D is the correct choice. And when it is top heavy, what is that? This is clearly top heavy, so HA does not exist in that case if it is top heavy. Okay, what is this over here? So there's another identity, guys, just like the sine x over x and tan x over x. Limit x approaching to 0, 1 minus cos of something over something. This is just 0. That's the identity, right? So here, obviously, the problem is we don't have something over something, as in that 4 is missing. But that's totally fine. It can be very easily manipulated. 1 minus cos 4x over 3x, right? We need 4x at the bottom, correct? No problem. Let's multiply by 4x and divide by 4x because math allows us to, to do the same thing in the top and multiply the same number at the top and bottom. And now let's move this guy inside and this guy outside because I'm just really changing the position. I hope you understand. 1 over 2 times 3 can also be written as 1 over 3 times 2. That's essentially the same thing. So it'll be 1 minus cos 4x over 4x times 4x over 3x. Limit x approaching to 0. And now you understand that this thing is 1 minus cos of something over something where something approaches to 0. So answer is 0. And this is just x is gone and I'm left with 4 over 3. And 0 times 4 over 3 is just 0. So the answer is option B over here. Okay. We have to find the value of a and b so that this is continuous over here. So let's start by making sure that it is continuous at x equal to -2. So at -2, I will say that negative left side of the -2, which is 3, should be equal to the right side of the -2 by plugging -2 over here. So it will be a times -2 plus b, which is 3 is equal to -2a plus b. which is negative 2a plus b is equal to 3. That's equation number 1. Equation number 2, x equal to 3, we have to prove that it is, or make sure that it is continuous. So on the left side of the 3, obviously it is applicable over here. Replacing x by 3, I will have 3a plus b. And on the right side of the 3, I will have negative 5. Equation number 2, and I think you know what to do now. Calculator is not allowed. This is a system of equations, so you are going to solve for a and b. I think I'm going to isolate b from here, which is 3 plus 2a, and I'm going to isolate b from here, which is negative 5 minus 3a, and I'm going to equate these two. So this is going to look like 3 plus 2a is equal to negative 5 minus 3a. Add 3a both the sides, so 3a plus 2a is 5a. Subtract 3 both the sides, which is negative 8. So a is negative 8 over 5. Well, not a nice number. But yeah, I hope I have not made any mistake anywhere. Um, yeah, okay. And plug in a back in here. So b is equal to 3 plus 2 times negative 8 over 5, which will be 3 minus 16 over 5, which will be 15 minus 16 over 5, which is just negative 1 over 5. That's the value of b. Right, so this is what we have as the values of a and b. Okay, write a function whose VA are this and HA is this. So this is an open-ended question. Obviously, there can be various functions. The easiest would be having the denominator as x plus 3 and x minus 5 to make sure that it has VA. And HA of y equal to negative 4 would mean that it is first off equally heavy. So if the bottom is x square, the top will also b of x square, and we have to make sure that their ratio is negative 4. So the denominator is just coefficient is 1. The top should have negative 4 then, you know, if I want to make this, make the HAY equal to negative 4. So this should be our simplest function where the top is negative 4x squared and the bottom is x plus 5, x plus 3, x minus 5. Okay. The function is satisfying the following inequalities. So we need to find for 0 to 2. So we need to find what is this limit. Whenever in limits you see inequalities, I think it should remind you of squeeze theorem. So I'm going to take limit x approaching to 1 minus all the three sides. So the left side will definitely look something like this. Middle one is the unknown guy. And the right one is limit x approaching to 1 minus of negative e to the x minus 1. Let's plug in 1 in all of these. So I will get 2 sine of pi over 2 over 1 minus 3. This is unknown. And this is negative e to the 1 minus 1. What is sine pi over 2? Not 0, it's 1. 1 times 2 is 2, so 2 over negative 2 over here, and this is e to the 0. 2 over negative 2 is negative 1, and e to the 0 is 1 with a negative sign outside. So yes, a squeeze theorem works only when the left and right, both the guys are equal, which it is in this case. So I'm just going to confidently mark my answer as negative 1. That's the only possibility. As this question is on composite functions, the first one is we need to find limit x approaching to 1 of f of fx. So obviously we are going to do this both ways. Limit x approaching to 1 minus f of fx is going to be a little less than 1. A little less than 1 will give me a little less than 3. And a little less than 3 again I sub in the function, which is obviously 1 over here. So this is going to give me 1. And limit x approaching to 1 plus f of fx, a little more than 1 is this, which is again a little less than 3, which is again obviously going to give me the same number. So the answer for question number 1 is just 1. Question number 2 is x approaching to 3 this time. Limit x approaching to 3 of f of gx. A little less than 3 will give me 0, but 0 from the left side. And 0 from the left side, if I plug into the function, 0 from the left side is going to give me -1. So 3 minus is -1. But if I put x approaching to 3 plus of f of gx, 3 plus will give me 0 from the positive side, and 0 from the positive side will give me 3. So yes, these are not equal, so the answer is does not exist. Question number 1. What is the average rate of change of the function? This is more pre-calc rather than calculus, but yeah, obviously this is starting. So yes, of course, we are just reminding ourselves. So AROC, that's what we call as average rate of change, is FB minus FA over B minus A. That's how we write this, correct? B in this case, B and A are basically the x values. So f of 3 minus f of -1 over 3 minus -1. Okay, let's find f of 3 and f of -1 separately. F of 3 is 3 times 3 square minus 4. I just replace x by 3. 3 square is 9. 9 times 3 is 27. 27 minus 3 is 20. 27 minus 4 is 23. Okay. F of -1 is 3 times -1 square minus 4. Be careful here. -1 when squared, the negative is also squared. So that will become +1. So +1 times 3 is +3, and 3 minus 4 is -1. So here I will get 23 minus -1 over 4, which is 24 over 4, which is just 6, right? Because 4 times 6 is 24. So I think option D should be the best choice. Okay, once again, another AROC. So I'm gonna but this one is just a funky function here. So 2 times ln, I can obviously write the formula for you. F of B minus f of A over B minus A. So 2 ln e to the 5 minus 2 ln 1 over e to the 5 minus 1, correct? Okay. If you remember the properties of log, the thing which is in the power inside the log is thrown outside. And when it is thrown outside, it will multiply with this 2 to become 10. So 10 ln e. ln 1, if you guys remember, is just 0 over e to the 5 minus 1. So ln e, what is ln e, guys? It's just 1. So 10 times 1 is just 10. Minus 0 over e to the 5 minus 1. So the final answer is 10 over e to the 5 minus 1. Pretty straightforward here. Okay. All right. Limit definition of derivative. Pretty annoying because it's unnecessarily lengthy. Not as important, guys, for AP calculus as an AP exam, but yes, your school definitely will be interested in such questions. Okay. The definition is very important. What is limit definition of derivative? As in definition, as in the formula. They say that f prime x is basically limit h approaching to 0, f of x plus h minus fx over h. That's how it is. Okay. So limit h approaching to 0, f of x plus h means you replace x by x plus h. So 3 over x plus h minus 2. Then you write fx again, which is 3 over x minus 2 over h. This will be limit h approaching to 0 over h remains as it is. Now very carefully we will make the common denominator for the top. So the common denominator will become x plus h minus 2 times x minus 2. Okay, now the left side will become 3 times x minus 2. And this will become 3 times x plus h minus 2. I hope you're with me. Okay, now we will do keep change flip. So if we do keep change flip, then basically this guy will come down and will multiply with this h. So it will become x plus h minus 2, x minus 2, and then h. Let's open up the top carefully. So 3x minus 6. Okay, this is where I have seen students making a mistake. Remember that this negative will be distributed, right, to all these people. So their signs will change. So the first term will be negative 3x, the next term will be negative 3h, and the third term will be negative 3 times negative 2, which is plus 6. Okay, now I think 3x is minus 3x gone, negative 6 and positive 6 is also gone. So what are we left with? Limit h approaching 0, negative 3h on the top, and denominator is just as it is. Fortunately, the h is also gone, and now we are in a position to sub in 0 everywhere as in instead of h. So it will become negative 3 over x minus 2, because h is just 0. So our final answer is negative 3 over x minus 2 square. That is a derivative of the function using the limit definition of derivative. Right, I hope this makes sense. Okay, this is alternate definition of derivative. So alternate definition of derivative is used when we want to find the derivative at a specific point. That specific point is usually called a in the formula, and the formula is given by f prime a is equal to limit x approaching a fx minus fa over x minus a. So limit x approaching a is 4. F of x is what? Same as y, right? So it is square root of 2x plus 1 minus f of a is basically replace x by 4 here. So 4 times 2 is 8. 8 plus 1 is 9. So root 9 over x minus a. Okay. So limit x approaching 4, square root of 2x plus 1 minus 3 over x minus 4. Now, whenever there are radicals, it doesn't really matter whether it's on the top or bottom, you have to rationalize this. So rationalization means you multiply by the same guy but opposite sign, as in between the sign, which is called conjugate as well, and the in between sign you change it and you multiply and divide by that thing. Okay. So the top will turn into a minus b, a plus b identity, which is a square minus b square. I hope you understand what I mean, because I'm considering this entire thing as a and this entire thing as b. Okay. So a minus b, a plus b, sorry, a square minus b square will make a square minus b square, and the denominator, I don't think so I can do anything with that, so just gonna write that x minus 4, just putting it in parentheses because there are two guys now, so they are separate. No, not interested in foiling, not even required. Okay, so if we simplify, if we square root, then both these guys nullify each other, so 2x plus 1 minus 9, and this is x minus 4, and this is root of 2x plus 1 plus 3. Okay. 1 minus 9 is negative 8, so 2x minus 8, and I can take 2 out, so I'm left with 2 times x minus 4, right? So 2 times x minus 4 will be 2 times x minus 4 over x minus 4, then square root of 2x plus 1 plus 3. Okay. Now comes the real stuff. These two are gone, and now we replace x by 4. So if we replace x by 4, because of the limit, 4 times 2 is 8, 8 plus 1 is 9, 9 squared is 3, 3, and then this 3 is as it is. So 2 over 6, 2 over 6 is what? 1/3, right? So that should be our final answer. Right. Okay. I'll find limit delta x approaching to 0, and oh my goodness, this grows. Don't worry, you don't really have to open anything out. This is basically just a limit definition of derivative where you can think about delta x as your h, and this is f of x plus h. This entire thing is f of x plus h, and this is fx, and this is over h. So basically the setup is f of x plus h minus fx over h. That's how the setup looks like, and this is limit h approaching to 0. So we know that this is nothing but f prime x. So find the fx from first, which is obviously sitting right here, and just find the derivative of that. So we know that fx is 2x cubed minus 4x squared plus 6x minus 5, and the derivative using the power rule is just 3 comes down, so 3 times 2 is 6, 6x squared, 2 comes down, 8x, and then 6x is just 6 because the derivative of x is just 1. So that's our answer. Okay. Okay, a couple of straightforward questions here where we need to find the derivative. So this is a power rule. F prime x will be 4 times 3 is 12, 12x cubed. 6 times 3 is 18 because 3 comes down and the power decreases by 1. So 6 3s are 18x squared. And this is just 3. So that's f prime x over here. The next one, you might think about applying a quotient rule. Nothing wrong in quotient rule, but I will personally try to avoid that thing because I can just write 1 over sine as secant. Sorry, 1 over sine as cosecant and 1 over cos as secant. So I'm going to change the function as 2 over 3 remains as it is, and this is c as cx, and 5 over 2 is as it is, and this is secant of x. Now I'm going to differentiate cosecant because I know the derivative of cosecant is negative cosecant cotangent. So negative cosecant cotangent. And the derivative of secant x is secant x tangent x. Okay. Then we have the next question, which is f of x is equal to negative 3 cot x minus x to the fourth root of x cube is 3 over 4, can be written like that. And then if I differentiate, then derivative of cot is negative cosecant square x. So negative cosecant square x. And here we apply power rule. So 3 over 4 x to the 3 over 4 minus 1, which is negative 1 over 4, which can be rewritten as 3 cosecant square x minus 3 over 4, and x to the negative 1 over 4 can be written as x to the 1 over 4 at the bottom. So this should be our answer. Okay, in D, definitely we need to apply a product rule over here, right? So in the product rule, we will keep the 3. I have a habit of throwing the 3 out, as in basically I will place a parentheses and do the product rule for this one because constants usually come out. But some students prefer to treat probably 3 root x as the first term and ln x as the second term, which is also right. It's literally what you're comfortable with, do that thing. So I'll just do this one, 3 root x taken as a first term and ln x as second term. So first term as it is, you differentiate ln x, which is 1 over x. Then ln x as it is, and then you differentiate first term, which is 3 root x, as 3 remains as it is. And derivative of root x is 1 over 2 x to the minus 1 over 2. Okay. Now root x over x is just root x at the bottom, right? I hope you understand this. Root x over x is just 1 over root x. And 3 over 2 as it is, ln x as it is, and then x to the negative 1 over 2 is 1 over x to the 1 over 2. So 3 over root x plus 3 ln x over 2 root x. That should be our final answer. I've just decorated this and nothing else. Okay. Okay, all right. Next is we have to find a derivative at a specific point here. Again, you might be thinking of using a quotient rule. Nothing wrong, but I'm just going to split the fractions. I'm just going to rewrite this as t cubed over t plus 2 over t. And then this will become f of t is equal to t squared plus 2 times t to the minus 1. And now I'm going to differentiate f prime t will be 2t, and then this will become minus 2 because minus comes down and power decreases by 1, so minus 2. We need to find at a point negative 2, so t is negative 2 here. Let's replace that. 2 times negative 2 minus 2 times negative 2 to the minus 2. So this will become negative 4. This will become negative 2 times 1 over negative 2 square, because negative power can be converted into positive power by doing this, the reciprocal. This will become negative 4 minus 2 times 1 over 4. So this will become negative 4 minus 1 over 2. And negative 4 minus 1 over 2 is, I think, what? Negative 9 over 2, right? So this should be our answer. Hopefully, yes, it is in the options as well. So option A is the best choice. Okay, what is the instantaneous rate of change? Just a different way of asking the same thing. We need to find what dy over dx is. So rather than doing dy over dx first, I'm gonna decorate this slightly by rewriting 1 over x as x to the minus 1 and this as x over 2. So this will become dy over dx, and here minus comes down and x, the power decreases by 1, so it becomes minus 2. And this is just 1 over 2 remains as it is, and derivative of x is just 1. Okay. So this will become negative 1 over x squared, because if we convert into positive power, that's how it becomes. And this is just 1 over 2. Taking a common denominator, which is 2x squared, this will become minus 2, and this will become x squared. So this will be minus 2 plus x squared is x squared minus 2. X squared minus 2 over 2x squared. This is dy over dx, which is option C. Yeah. Okay. Pretty straightforward here. We are given a relationship between gx and fx. They are saying what f prime minus 6 is. We have to find g prime minus 6. So let's differentiate both the sides here. G prime x will be equal to 9 times f prime x. So g prime negative 6 is equal to 9 times f prime negative 6. F prime negative 6 is 4, right? And 9 times 4 is 36. So g prime negative 6 is just 36, which is option A. Okay, all right. Over here, we need to find f prime x. So f of t. I don't think so I need to decorate this. It's already decorated. So I'm just going to differentiate right away. F prime t using the power rule, 2 over 3 drops down, and the power decreases by 1, which is 2 over 3 minus 1 is negative 1 over 3. And then minus, again the power drops down and the power decreases by 1, which is negative 3 over 2 minus 1. Okay. No need to really simplify too much, because remember, after all, you need to replace t by 1. So it's just become plus 3 over 2, and this becomes minus 5 over 2. So if I replace t by 1, f prime 1 will be 2 over 3, because 1 to the negative 1 over 3 is 1. And 3 over 2, because 1 to the negative 5 over 2 is also 1. Taking the common denominator as 6, this will become 4 over here, and this will become 9 over here. 9 plus 4 is 13, so 13 over 6, that should be our final answer, which looks like option B. That should be the correct choice. Okay. Fx is given as this. We need to find f prime x. Okay. This one looks like a quotient rule, yes, but I can use a trig identity as well to simplify it further. I'll show you both ways. You can pick whatever you want. So first, let's apply the quotient rule. So f prime x will be low square. Low square is like this. Then okay, low d high. Now in low d high, as soon as you will do the derivative of high, you have to use something called chain rule that you may not have learned yet if you have not started unit 3, because chain rule is the first thing in the unit 3. So since that topic is not a part of this particular unit, I'm just gonna skip this, and it looks like but obviously once you learn the unit 3 and the chain rule, you can do it using this way as well. But for the moment, I'm just gonna do it the other way. which is using trig identities, as in writing sine square x as 1 minus cos square x. I hope you understand, because this is using Pythagorean identity. We very well know that sine square x plus cos square x is 1. So I just replace sine square x by 1 minus cos square x. Okay, if you think that you can cross these out like this, you are sadly mistaken. This is not how the math works. I've seen some of my students doing this mistake, so please don't make it. Here, what you're going to do is 1 minus cos square x can be seen as 1 square minus cos square x, which is a square minus b square. And a square minus b square is a minus b times a plus b. And the denominator is as it is. And now you can cross these out, and we are left with 1 plus cos x. So, okay, this is not f prime, by the way. This is just f because I'm just simplifying the function right now. So it is 1 plus cos x, and now you can differentiate. So f prime x will just be 0, and cos is minus sine. So minus sine x over here. So f prime x is minus sine x, which is option C. All right. Over here, we got to use a product rule, of course. There is no other option. So f prime x will be x minus 1 square remains as it is. Derivative of cos is negative sine x. I'm just putting in parentheses because there is a negative, and if I won't put, you might think that I'm subtracting these two, but I'm not. It is just a product with minus sine x. Plus cos x remains as it is, and the derivative of x minus 1 whole square can just be written as 2 times x minus 1. If you don't understand how I got 2 times x minus 1, I mean, I have basically used a power rule, because power rule can be used even if the x is not x is x plus 1 or x minus 1. But if you are confused with this, you can rewrite x minus 1 whole square as, open up the parentheses, which will become x minus 1 times x minus 1, which can be written as x squared minus 2x plus 1. And then you differentiate this thing. So if you differentiate, you will get 2x minus 2, which can also be written as 2 times x minus 1, which is exactly what I have over here. Okay, and now I'm just going to replace x by 0 without simplifying. So the beauty about this is sine 0 is just 0. So 0 times anything, any finite number, that's just going to be 0. Here cos 0 is 1, 2 is just 2, and 0 minus 1 is minus 1. So 1 times 2 times minus 1 is just minus 2, which should be our final answer. So I'm going to mark option A over here. Okay, we need to find a double derivative. Okay, well, that's a little new. First, we find a single derivative using a quotient rule. So low square is over here. Low d high, derivative of high is just 1. Minus high, which is x plus 2, d low, derivative of low is just 1. So x minus 3 minus x minus 2 over x minus 3 whole square. X and minus x is gone. So I'm left with minus 5 over x minus 3 whole square. This is dy over dx. Okay, so what is a double derivative then? D square y over dx square is going to be, again guys, you can use a quotient rule, but I would prefer not to. I'm just going to rewrite this as negative 5 times x minus 3 to the negative 2. And now I can just apply the power rule. So negative 5 remains as it is, negative 2 comes down, and x minus 3 and the power decreases by 1, so negative 3. Negative 5 times negative 2 is 10, and negative power means in the denominator it will be x minus 3 cubed. So 10 over x minus 3 cubed, which is option A. All right, okay. We need to use the following tables for these two parts. Okay, if h is some function that is a product of two functions, we need to find what is the value of h prime phi. Okay, so h prime x using the product rule is f prime x times gx remains as it is, and then fx remains as it is, and then g prime x. I need h prime minus 5. So let's replace x by negative 5 everywhere. So negative 5, negative 5, negative 5, and then negative 5. And just be careful while reading the values, because we are looking for this, because x is negative 5 right here. Okay, we are not bothered about the row that involves x equal to 4. So what is f prime negative 5? F prime is here. F prime negative 5 is just negative 5. What is g negative 5? G is here. G of negative 5 is 2. What is f negative 5? 6. What is g prime negative 5? Negative 1. So this will be negative 10 minus 6, which is negative 16. That should be our final answer. For the next one, we need to use a quotient rule, and also it is at 4. Anyway, 4 comes later. So I'm just going to clear this thing because now we need to focus on this particular row. But yeah, of course, let's do the quotient rule. So g prime x will be equal to low square, low d high is f prime x, minus high d low, which is g prime x. Okay, I'm going to replace x by 4 now. So this is going to look like g4 square, g4 f prime 4 minus f4 g prime 4. Okay, what is g4? G is here, 4 is here, there you go, that's 4. What is f prime 4? There you go, 7. What is f4? There you go, negative 3. And g prime 4 is just 1. So literally there is no need to write. That's just not going to make any difference. And what is g of 4? That's 4 square. So 7 times 4 is 28 plus, because double negative is positive, over 16. So the answer is 31 over 16, which is the final answer. Okay. All right. Let's move on to the next one. Here we are given a function and we need to find f prime 0. Okay, looks like a quotient rule, right? Okay, so let's apply the quotient rule over here. So f prime x will be equal to low square, low d high, derivative of 4x is 4, minus high d low, derivative of x square minus 2a is 2x minus 0, because a is a constant, as we can see here. Okay, f prime, and now replace x by 0. So f prime 0 will be 0 minus 2a times 4 minus 0, because, you know, x is 0, over 0 minus 2a whole square. Let's replace f prime 0 by 6. So this is 6. Negative 2a times 4 is negative 8a. And negative 2a square is 4a square over here. Okay, so 8 over 4 is 2, negative remains as it is, and a over a square is 1 over a. Let's cross multiply, so 6a is equal to negative 2, and divide both sides by 6, so negative 2 over 6 is negative 1 over 3, which, yes, fortunately it is in the options. It should be option B. Okay. Now, if double prime is given, we need to find what is the fourth derivative of the function. So it's nothing but differentiating it 2 times, right? Because if we differentiate this again, I will get f prime 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 x, which is what? Using the power rule, this will become 6x. This will become just 6. And the fourth derivative, usually whenever the derivative is 4 or higher, they start writing the number on the top rather than putting prime, 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 prime. Nothing wrong, but it's just difficult to count there. So they start putting that number in the parentheses, which denotes that it is basically how many times the derivative has been taken. Okay, derivative of 6x is 6, and derivative of 6 constant is just 0. So 6 plus 0 is 6, which should be option B. Okay, find the derivative of this at this point. Okay, quotient rule, guys. So f prime t is going to be low square. So cos t squared, low square, low d high derivative of t is 1 minus high d low derivative of cos is negative sign, remember. So just a one step decoration, do negatives will become positive t sine t, and I hope you understand that cos t square is basically cos square t. That's how we write that. And then replace x by or t by pi over 3. So your old friend unit circle coming back in now. Calculator is not allowed. What is cos pi over 3? 1 over 2. T is just pi over 3. What is sine pi over 3? Root 3 over 2. And what is cos pi over 3 is just 1 over 2, but this time there is a square as well. Okay, I don't really like this. It's extremely gross. Let's simplify this if we can a little bit. The denominator is definitely just 1 over 4. The top, I'm just going to take a common denominator, which is 6. So this will become 3 plus root 3 pi. And finally, I'm just going to do keep change flips. So I'm just first going to rewrite this divided by this. This is the question. I'm not doing keep change flip right now. I'm just rewriting that the question can be written like the expression can be written like this. And now I'm going to do keep change and flip. That's how it is. Okay. So this will become 3 plus root 3 pi, and then 4 over 6 can be reduced as 2 over 3, and 2 can be distributed. So 3 times 2 is 6, and this will become 2 root 3 pi and over 3. That should be our final answer, final expression for the derivative over here. Okay. Tangent lines now. Find the equation of the tangent line to this at this. So tangent line is all about point and a slope. I mean, line is all about point and a slope. Only x value is given. So let's find the y value first, corresponding y value. So replacing x by pi over 6. So pi over 6 times sine of pi over 6. Sine of pi over 6 is 1/2. So pi over 6 times 1/2 is pi over 12. That's the y value. Okay, let's keep it aside. I need slope as well. So slope is what? Prime. Here, product rule, yes. So x remains as it is. Derivative of sine is cos. Then cos remains as it is. Sorry, sine remains as it is. And derivative of x is 1. Replacing x by pi over 6 everywhere. So pi over 6 times cos pi over 6 is root 3 over 2. Sine pi over 6 is 1 over 2. This will be root 3 pi over 12 plus 1 over 2. That's the slope. I think I'm just going to keep the slope like that and write the point slope form, which is, okay, let's clear this up. So point slope form will be y minus y1, which is pi over 12, equal to slope, which is root 3 pi over 12 plus 1 over 2. Let's put that in parentheses, times m times x minus x1, which is pi over 6. Yeah, even if this is asked in AP as FRQ, it's totally fine to write it like this. They are not going to take off your points just because you didn't simplify. If the calculator is not allowed, yes, absolutely, you can leave like this, leave it like this, and all good. Okay, find equation of a tangent line to a similar question, but this time we need to use a quotient rule. Let's put x as 1 first off to find the y value. So y is just, well, fortunately, it's just 1 minus 1 over 1 plus 1, which is 0 over 2, which is 0. Cool. So the point is 1 comma 0. Now y prime will be low square. So x plus 1 square. Low d high derivative of x minus 1 is just 1 minus high d low derivative of x plus 1 is just 1. Let's distribute this 1. So it will become minus x plus 1 over x plus 1 whole square. 1 plus 1 is 2, so 2 over x plus 1 square, that is y prime. But we need y prime at 1. So let's replace x by 1. So y prime will be equal to 2 over 1 plus 1 is 2, 2 square. 2 square is 4. 2 over 4 is 1 over 2. So the equation is y minus 0 equal to m times x minus 1. or y is equal to half x minus 1. No need to go any further because I can see that in the options already. That should be our answer. C. Okay. Find the equation of the line tangent and the line normal as well this time at the specified location. So first let's find the point because point is same. If I put x as 0, what is the value of y? Y is going to be 3 sine of 0. What is sine 0? Not 1, it's just 0. E to the 0 is again not 0, it's just 1. E to the 0 is 1 this time. So 0 minus 5 is minus 5. That's the point. It doesn't really matter whether you are finding tangent or normal. The point is just the same point, right? We don't really have two different points for it. Now, the slope of the tangent is given by dy over dx, and slope of the normal is given by basically negative reciprocal. Negative reciprocal is negative dx over dy. No need to really find this separately. Find this and take the negative reciprocal of it. So let's differentiate that guy. Y prime will be equal to 3 sine differentiation is cos and e is just e. And now if I put x as 0, cos 0 is 1. 3 times 1 is 3 and e to the 0 is 1, so 5. So this is minus 2. It is the equation which is the slope of the tangent. So the slope of the normal will be negative reciprocal. So negative reciprocal, just ignore this for the moment now. Just focus on this one. Negative reciprocal. So negative and then reciprocal. Reciprocal is negative 2 comes at the bottom. So it's just 1 over 2. So the equation of tangent line is going to be y minus minus 5 equal to m times x minus 0, which is y plus 5 is equal to negative 2x. That's for the tangent. And for the normal, I have y minus minus 5 equal to 1 over 2 this time. 1 over 2x minus 0. So the equation of the normal line is y plus 5 is equal to half x. Of course, you can subtract 5 both the sides if you want to isolate y, but it's fine. This looks like we have to show work, so this is absolutely fine as well. Okay. For the function, find the location of any horizontal tangent. What is the property of horizontal tangent? What is its slope? 0, which means that we are looking for the points where dy over dx is 0. Correct? Because slope is dy over dx. Okay, what is the derivative of x to the 4 over 4? 1 over 4 as it is, and x to the 4 is 4x cubed. This will be 3 times 3 is 9, 9x square. 9 times 2 is 18, 18x, and that should be equal to 0. So these two are gone, and I'm left with x cubed minus 9x square plus 18x is equal to 0. Calculator is not allowed, so I'm just going to factor out 1x over here, which is x square minus 9x plus 18 is equal to 0. Looks like this is just x minus 3 whole square. No, it's not. Sorry, misspoke. This is x minus 6 times x minus 3, if I'm not wrong, right? Yeah, I think yes. So that's the factorization, and then that's it. The roots are going to be either this can be 0, so x is 0. This can be 0, so x can be 6. But this can be 0 when x can be 3. So this should be our final answer. 3 points where we have horizontal tangent. Well, they are asking locations. Locations is a pretty... I'm not really sure whether they want the y coordinate as well. I think if they need y coordinate, they will use the word points. If they are using points, then yes, you have to plug in x coordinate back here and then figure out what y is. But locations, I think I understand from location as just the x value, so I'm just going to leave my answer here. Okay, we need to find a table is given. We need to find h prime 0. So again, this is a similar question that we did earlier. Product rules. So first term remains as it is. Derivative of secant x is secant x times tangent x. Then secant x remains as it is, and gx is g prime x. So h prime 0 is going to be g0 Actually, you know what? What is tan 0, guys? That's just 0. So this is poofed. That's just 0. And secant 0 is 1. And g prime 0, I do not know. So let's look at let's focus at the table. So g prime is here, 0 is here. So I'm looking at 4 over here. So this will be 4. And yeah, fortunately, that is in the options as well. So I'm just going to mark option C as the answer. Okay. Oh, graph related question. The function is shown from 0 to 4. Put the following from least to greatest. The first guy is f of 1. Now I can read it. F of 1 is just 8. So that's 8. AROC from 2 to 4. Interesting. At 2, the point is 2 comma 4, and at 4, the point is 4 comma 8. So AROC is basically slope, right? y2 minus y1 over x2 minus x1. So this will become 8 minus 4, 8 minus 4 over 4 minus 2. So 4 over 2, and 4 over 2 is just 2. Limit x approaching to 1, fx minus f1 over x minus 1. If you remember, this is alternate definition of derivative, which is just a fancy way of saying f prime 1. And what is the slope at 1? Isn't that horizontal tangent, which is 0? And what is this? Let's sub in the numbers. What is f3? f3 is 0. What is f2? f2 is, there you go, 4. And 3 minus 2 is 1. So this is negative 4. So they're asking least to greatest. Least is, of course, the negative number. So 4 is the least. So 4 should come first. And, well, they have 3 options. I'm not surprised where 4 is first. Then comes, I think, 0. So then I have option number 2. There you go, statement number 2. And then I have 2. And then I have sorry, I misspoke. First we have negative 4, and then 0, which is statement number 3. So statement number 3 is here. Then I have statement number 2, which is 2, giving me a value of 2. And then biggest is statement number 1, which is giving me 8. So that should be the correct choice, which is option B. Just a reverse order, basically. Negative 4, 0, 2, and 8. Okay. L is tangent to this and parallel to this. What is the y-intercept? Okay. Parallel means what? Slope is same, right? So let's find the slope of this one by moving 12x over on the other side. So it's negative 12x plus 4. Y equal to mx plus b, which means that the slope is negative 12. So I know that the derivative of this at some point should be negative 12. So let's find that out. Dy over dx is what? 10x plus 8. And I want this to be same as negative 12. So what is that point? Negative 12. So 10x will be negative 20. So x is negative 2, of course. If x is negative 2, what is the y value? Let's plug that back in here. And y will be 5 times negative 2 square plus 8 times negative 2. Negative 2 square is 4. 5 times 4 is 20. 20 minus 16 is 4. So equation will be y minus y1, which is 4, equal to slope, which is already negative 12, right? Times x minus minus 2. So it will become y minus 4 equal to negative 12x plus 2. And they need y-intercept, which means that I substitute x as 0, which means that y minus 4 is negative 12 times 0 plus 2, which is 2. Which means that y minus 4 equal to negative 24. And adding 4 both the sides, y is negative 20, which is option C. Okay. If the graph of this parabola is tangent to the line, then what is the value? Okay, again, the same situation that if this is tangent to the parabola, then there must be a point where the derivative must be equal to the slope of this line, because this line is tangent to it, which is negative 3. So what is f prime x first? F prime x is going to be 4x plus 1, because k is a constant, so that's just gone, that's just 0. So 4x plus 1 should be negative 3, which means that 4x is negative 4, which means that x is negative 1. Of course, they are not asking what x is, they are asking what k is, but we are getting there. Okay, so this means that uh, this line and this function, consider it like this. This function is a parabola, right? So it is something like this. And the line is something like this. And it is tangent right here, where x value is negative 1. And of course, I can find the y value as well. What is the y value? I'll just plug in x over here, which is negative 1. So 3 plus 1, which is just 4. So x value is 4. So basically this point lies on the straight line, as in the tangent line, because it is the point of contact, and the parabola as well. So all I have to do is plug in this point in this function. So fx is replaced by 4 and x is negative 1. So this is negative 1, this is negative 1, and then k. So 4 is equal to 2 minus 1 plus k. 4 is equal to 1 plus k. Subtracting 1 both the sides. So I have 3 is equal to k. Flip the omelette. So k is just 3, which is option number C. It was a pretty decent question, I think. So yeah, that's how we do it. Okay. I'll use the provided graph of this function to find, okay, well, that's interesting. So clearly this is a product rule. I definitely am not going to open this up. I'm just going to treat these as two functions and use the product rule. Let me just zoom in, and I'll zoom out when we have to read from the graph. So h prime x is going to be the first, this thing remains as it is, which is 2fx minus 3, then times derivative of gx minus 2, which is g prime x plus 0. So I'm not writing plus 0. Plus the second term remains as it is, times the derivative of the first term, which is 2 times f prime x, and minus 0 again. So what is h prime 6? H prime 6 will be replacing every x by 6. So this is how it looks. This is g prime 6, and then this is g6 plus 2 times f prime 6. And that's when I go to the graph. We are just interested in x equal to 6. So this is the x equal to 6 thing, and this is the line that's going over here. Okay, first let's clearly read f6 and g6. So f6 is the bold one, which is right here, and this point is what? 3, 4, 5, 5. And what is g6? G6 will be right here, which is 3. Okay, just to avoid any confusion, I'm just gonna sub in these 2 points. So f of 6 is 5, right? F of 6 is 5. 5 times 2 is 10. 10 minus 3 is 7. So this is 7 times g prime 6. And g6 is 3. 3 plus 2 is 5. 5 times 2 is 10. So 10 times f prime 6. Now how to find derivative? That's pretty interesting over here. Now, although we did all this because I wanted to show this work still to you, still I want to show f prime, how to find it, but f prime you find using the slope between these 2 points, because after all, this is just the slope between of this entire line. So this point is 3, 8, and this point is 7, 4. The slope is going to be 8 minus 4 over 3 minus 7, which is 4 over negative 4, which is negative 1. So this is f prime 6. So f prime 6 is negative 1 over here. But what is g prime 6? Now notice carefully that at x equal to 6, g has a sharp corner. Right, g has a sharp corner. So, and what is the derivative when there is a sharp corner? It's undefined. So even after doing all this, yes, g prime 6 is undefined, and that's why this entire derivative does not exist. But I still wanted to show the entire work to you, because what if G prime 6 does not exist? Maybe it exists. So this is how you do the other portions. So this is not for specifically this question, but just to help you learn for the other stuff as well. Okay. Determine the locations where a function is not differentiable. So there are four cases when the function is not differentiable. One is when it is discontinuous. And there are three cases when the function is continuous. Despite that, it is non-differentiable. Sharp corner, that's the first thing. Sharp corner, then we have vertical tangent, and then we have cusp. Okay, these two are sometimes confused. I'll give you two very popular examples of this. Vertical tangent is whenever you have the power as something like, let's say, 1 over 3. And cusp is whenever you have some powers like 2 over 3. I can generalize this for you. If it is something like x plus a to the power, let's say, m over n. And if the power is less than 1, remember, power has to be less than 1. If the power m over n is less than 1, then there are three possible cases. Either m is odd and n is odd, m is odd and n is even, or m is even and n is odd. Remember, both even are not possible, because if both are even, like 2 over 4, it will eventually reduce to one of these two cases. For example, in this case, 1 over 2. So even and even are not possible. Now, if both are odd, let's say, for example, 1 over 3, this is the case of vertical tangent. If m is odd and n is even, something like 1 over 2, this is also a case of vertical tangent. But if it is even and odd, for example, 2 over 3, then it is a case of cusp. So this will be very helpful for you if you want to make sort of like a rule, because they often ask, and remember, I'm only talking when the power is less than 1. So if you ask what is 2 over 1, then no, I'm not talking about that case, because that is not a power less than 1. So if we understand the right side, then this is very easy for you to understand, because this is a power of 4 over 5, as in even on the top, odd at the bottom, which is forming a cusp. Where exactly, by the way? Cusp at the point where this inside thing is 0, which is at x equal to minus a. So it is not differentiable at x equal to minus 3, because it is forming a cusp. And this is odd over odd, so it is not differentiable at x equal to 4, because it is forming a vertical tangent. Okay. The other thing is just, I think, discontinuity, the option B, because if we simplify this, this is going to look like x minus 2 over, I think, x minus 1, x minus 2. And yes, it is definitely discontinuous at these points. So at x equal to 1, it has a vertical tangent. So at x equal to 1, it is not vertical tangent, vertical asymptote. So it is not differentiable. And at x equal to 2, it has a hole over here. That's why it is not differentiable, because it comes in the category of being discontinuous. I hope you remember this from unit 1, because x minus 2 is same on top and bottom. So it is a hole case. And the last one, whenever you see absolute value, that is a sharp corner. Absolute value of a linear function, it always forms a sharp corner wherever the inside thing is 0. So 2x is 3, or x is equal to 3 over 2, it forms a sharp corner over here. So it is not differentiable because of the sharp corner case. So in this question, I intentionally took these 4 parts so that you can see all the cases. I can also talk about this thing with you, which should make things easy. Okay, which of the following statements is true here? Now they are asking about the limits and some differentiability as well. Okay, let's find limit x approaching to 1 minus and 1 plus. So it's as straightforward as put 1 here, because that's applicable for less than 1, and this is greater than 1. So this will become, simply replace x by 1. So 5 minus 8 is negative 3. And this is ln 1 minus 3, which is 0 minus 3, which is negative 3. So yes, they are not equal. This is a false statement. They are equal. And since they are equal, it is continuous as well. So there's a removable discontinuity. That's also wrong. Now, in order to find whether that's differentiable or not, we differentiate the pieces separately. So differentiate 5x squared minus 8x as 10x minus 8 for x less than 1. Notice I removed the equality sign because that's where I'm trying to find what's happening. And derivative of ln x is 1 over x, and 3 is just 0 for x greater than 1. Now you put x as 1 over here, which will give you 10 minus 8, which is 2, and this will give you 1 over 2. Clearly, these are not equal, so it is not differentiable. Had they were asking why, the reason is sharp corner, because very clearly, since the left side is steeper, it's something like this. Left side has a positive slope, left side has a slope something like this, and the bottom side has a slope of, so let me redraw it, corner. So this is, let's say, x equal to 1. The left side has a slope something like this, and the right side is a little less steep. So obviously this forms a sharp corner. Whenever the derivatives are finite and not equal, it forms a sharp corner, just in case they are asking. Right, I hope this one makes sense. The last question is about for what values of a and b is that differentiable? So for it to be differentiable, it should be continuous as well. Well, let's put 1 here on the left side, because left hand limit should be what, 2 plus a in that case, and right hand limit, let's put x as 1, which should be b minus 1. So this means that a should be b minus 3 if I subtract 2 both the sides. And then for differentiability, f prime x will be equal to derivative of 2x plus a is just 2 plus 0 for x less than 1. And for this one, it will be 2bx for x greater than 1. So we put 1 here and we'll put 1 here and equate both, so that because we want them to be differentiable. So 2 is equal to, 2 is equal to 2b because x is just 1. So 1 is equal to b, or b is equal to 1. And if b is 1, then the value of a is 1 minus 3, which is negative 2. So b is negative 2. So a is negative 2. I don't know why I wrote b here. It should be a as negative 2. So negative 2 and 1. Yeah, there you go. Option C should be the best choice. First question, we need to find dy over dx of each of this. So it looks like we have to use the chain rule, right? So dy over dx is going to be, chain is always, I always think of chain rule as breaking stuff. So when you are breaking sine of 2x, first you break sine. Break means differentiate. So derivative of sine is cosine, and the inside guy remains as it is. And then you break 2x, and the derivative of 2x is just 2, right? But we are not done yet. What is the formula for a to the something? Usually students forget that. It's a to the something is a to the something natural log of the base times the derivative of the power. That's how the derivative works over here. So let's decorate this. It can be written as 2 cosine 2x, yeah? And the derivative of sine is cosine, of course. So the answer is 2 to the sine x times ln 2 times cosine of x. So that's going to be our final answer. Okay, be careful in question number 9. The log is with a different base, right? At the base of 9. So I would recommend that in the log questions, always try to see how much you can simplify the question itself without before differentiating it. For example, I know right off the bat that this power will be thrown outside as per the properties of log. So it can be written as 5 times log with base 9 of 6x to the power 4 plus 3. And now I'm gonna use the change of base formula, because the formula for derivative
is available only for log, as in a default base of 10, or natural log, right? Not for anything else. So I'm going to rewrite this as natural log of 6x to the 4 plus 3 over natural log of 9, right? I'm just rewriting the question. I'm not differentiating anything right now. And now if I want to differentiate, obviously the 5 over ln 9 has nothing to do with the derivative. So I'm gonna, write it together so that in the immediate next step, I'm just going to take it out because that's a constant. So if I want to find g prime x, like I said, 5 over ln 9 sits outside. The derivative of ln is 1 over the inside thing. So it'll be 1 over 6x to the 4 plus 3. But we are not done yet. We need to use chain rule. So we go inside and break this stuff up. So derivative of 6x to the 4 plus 3 will be 6 times, and derivative of x to the 4 will be 4x cube, and derivative of 3 is just 0. So I'm not going to write that. So finally the answer is 5 times 4 is 20. 20 times 6 is 120. So it's 120 x cube over ln 9 multiplied by 6x to the 4 plus 3. That is going to be our final answer. Okay. Question 3 should be easy, I think. How we can rewrite, how we can differentiate it right now is just by, taking the, applying the rule that a raised to something is just a raised to something times natural log of the base times the derivative of the power, and the derivative of x squared minus 1 minus 7, if you understand it directly, it's just 2x because 7 is just 0. So it's actually 2x minus 0, but there is no need to write that zeros, and I don't think so I need to simplify that. That is my answer. Okay. Let's try to differentiate this one. So f prime, this is thankfully just the natural log. So it's just 1 over the inside guy, which is 4x cubed plus secant of x. But I'm not done yet. I'll go inside and differentiate this entire thing. Derivative of 4x cubed will be 4 remains as it is. And derivative of x cubed will be power rule. So 3x squared, and derivative of secant x is secant x multiplied by tangent of x, right? And I don't think so we can simplify. I mean, we can write 4 times 3 as 12. I'll do that for you. 12x squared plus secant x tangent x divided by 4x cube plus secant of x. So that should be our final answer, I think. Okay, question 5, I need to use a product rule followed by a hidden chain rule, right? Should not be that bad. Let's apply the product rule first. So dy over dx is going to be, the first term remains as it is. So let's say x squared plus 1 cube remains as it is. You could have taken this one as it is as well. It doesn't really matter. The order is irrelevant. And then we differentiate this one. Now be careful here. We need to apply the chain rule. So first, this is protected by the power. So we need to apply the power rule. So 5 comes down and it will become 4x plus 3 to the power of 4. Then we go inside and differentiate 4x plus 3, and the derivative of 4x plus 3 is just 4. Plus, then 4x plus 3 to the 5 remains as it is. And then we differentiate this guy, which is once again a power rule and then chain rule. So power chain rule. So 3 comes down and then it is x squared plus 1 square. And then the derivative of x squared plus 1 is or 2x. Finally, 5 times 4 is 20, so I can write it as 20 times x squared plus 1 cube, and then 4x plus 3 to the power of 4, plus 3 times 2x is 6x, and then 6x times x squared plus 1 whole square, and 4x plus 3 whole to the 5. So that should be our final answer. Okay, another one we have, question number 6 is, once again, guys, whenever I see a log, I have a tendency to always check whether I can simplify it further or not. And it looks like I can simplify it, because natural log of 4x, root of 4x plus 2 can be written as 4x plus 2 raised to 1 half. And log has a property that if inside guy is raised to a power, then the power is thrown outside. So this will look like secant of 5 raised to 2x plus 1 over 2 drops outside, and then natural log of 4x plus 2. So I'm going to differentiate this now. G prime will be, what is the derivative of secant? Secant is secant of that something, tangent times tangent of the something, tangent of the 5 raised to 2x. But I'm not done yet. I need to differentiate this inside guy as well using the chain rule. So 5 to the 2x derivative is just 5 to the 2x times natural log of the base, which is natural log of 5. But again, we are not done yet. We need to differentiate the power as well, which is 2x, so derivative of 2x is just 2. Oh, plus 1 half remains as it is. Derivative of natural log is 1 over the inside thing, so 1 over 4x plus 2. But I'm not done yet, then I'll differentiate 4x plus 2, which is just 4 over here. Obviously, you can do 2 times 2 is 4, but other than that, I don't really think so you can simplify anything else. So yeah, that's about it. That's my answer. Okay, and we are talking about at what point on this graph is the tangent line parallel to the line this. Okay, tangent line parallel means what? We need to compare the slopes, and parallel lines means equal slope. So I'm looking for the slope of this function at that point. Should be same as the slope of this, and thankfully this is y equal to mx plus b form, so the slope is just 2. And what is slope, guys? Isn't that just the derivative? So I am looking for the point x, or they're asking points, so maybe they want x and y both. I can give them both, where dy over dx is equal to 2. Let's differentiate 4 to the x plus 3. So obviously derivative will be 4 to the x times natural log of 4, and derivative of 3 is just 0, so I don't really care about that. So that should be equal to 2, which means that 4 to the x should be equal to 2 over natural log of 4. And well, that's a little weird, because if I need x, I'll just take natural log both the sides. So natural log of 4 to the x is equal to natural log of 2 over natural log of 4. Too many lns over here, but yeah, the x drops down. So this can be written as x times natural log of 4 is equal to natural log of 2 over natural log of 4. Oh my god, that's extremely gross. But yeah, finally I'm going to divide both sides with natural log of 4. So answer is 1 over natural log of 4 times natural log of 2 over natural log of 4. Obviously, if the calculator is allowed, you can just find that, but at the moment I'm just going to stop at x. I don't think so. I want to put that back in and find y. I think I'm happy with x. Okay. Implicit derivative. So we are given an equation and we need to find a single and double derivative both. So let's differentiate this right away. Derivative of 2x square is going to be 2 times 2x, because 2 remains as it is and derivative of x square is 2x. Here usually students get confused when I just write, they say it should just be 2y. Remember, we are differentiating in terms of x, not y. So we want to find what is d over dx of y square. So derivative of y square will be 2y, of course, using the power rule, but using the chain rule, you need to go inside and differentiate this y as well, because right now you just differentiated the power. But when you differentiate the inside guy, you cannot really differentiate. You just have to end at dy over dx. So it's not just 2y, it's 2y dy over dx, and the right thing is not just 1, that's 0, because derivative of constant is 0. So this will become 4x. Let's move this on the right side of the equation. So 2y dy over dx. Let's divide both sides by 2. So 2x is equal to y dy over dx. And dividing both sides by y, I have dy over dx as 2y over x over here. So that's my part A, which is dy over dx is equal to 2x over y. Now I need d square y over dx square. So let's differentiate this again, but be careful. You need to apply quotient rule and then be careful again, because that's an implicit differentiation. So quotient rule, first off, I'm going to take 2 outside because this innocent guy has nothing to do with the derivative. It's a constant multiplied with the variable, it's going to come out. And then I will say low square, low d high means derivative of high, which is 1. Because derivative of x with respect to x is 1, minus high is x, d low. Now remember, this is not 1. This will not be 1. D low will be dy over dx because again, we are differentiating with respect to x. Students ask me, can we leave here? No, because your answer is in terms of another dy over dx. That's not allowed. You have to simplify. They are very categorically saying that you have to simplify in terms of x and y. So we are going to replace this dy over dx again by 2x over y. And then we are going to take the pain and simplify this. So this will be over y square remains as it is. The common denominator is y. This will become y square minus 2x square. I hope you are able to follow. And then keep change flip will make this y and y square multiply. So it will become 2 times y square minus 2x square over y cube. And that should be my final answer for the double derivative. Right, I hope this makes sense. All right, guys, if you're finding this video helpful so far, by the way, please like and subscribe. Please share it. Really help my channel, really help the other students as well. And if you need private tutoring, feel free to reach out. Here we need to find the equation of tangent and normal lines to this curve at this point. So obviously I have a point, I need slope. Slope is the derivative. So I need to differentiate this guy and find dy over dx to get the tangent, sorry, slope of the tangent. So x square y square is equal to 16. You know what? I can differentiate it right away. I have to use a product rule, or you can be a little smart and move 16, divide 16 on both the sides and do it that way as well. Honestly, I'll just do it with the product rule because I think the other method might confuse you. Okay, so product rule would mean that x square remains as it is. Derivative of y square, again, I already explained this earlier, it's 2y dy over dx. And then y square remains as it is, and the derivative of x square is just 2x. And that is equal to 0. Okay. I'm not really going to take the effort of isolating dy over dx, at least now, because I have a point. So it's better to simplify when I have numbers than I have variables. So I'm just going to replace x by -1. So -1 square and y by 4. So let's do all that. Y by 4, x by -1 equal to 0. -1 square is 1, 4 times 2 is 8, 8 times dy over dx minus 4 square is 16, 16 times 2 is 32 is equal to 0. This means that 8 dy over dx is 32, and fortunately 8 times 4 is 32. So the slope of the tangent is 4, which means that I have the equation as well, because the point is -1 comma 4. So the equation that I have is y minus y1 equal to m times x minus -1, which will just become 1. It's okay to leave it like that. Even in APs, they are going to give you full credit. No need to convert in slope intercept. Slope intercept form. They need a normal as well. Normal is nothing but the negative reciprocal. Normal slope is nothing but the negative reciprocal of this guy's slope. So its slope will be -1 over 4 for the normal. So the equation is going to be y minus, what was the point again? 1 comma 4. 4 equal to -1 over 4 x minus -1 or x plus 1. So that is going to be the equation of the normal. Alright guys, we have an FRQ style question. We are given a curve and we need to prove that dy over dx is this. So let's do that. This is again implicit. So derivative of y square is going to be 2y dy over dx. If you don't mind, I'll write dy over dx and y prime. I'm very lazy. So in x square y, I'm going to write x square as, product rule. So x square times y prime and then y as it is, and derivative of x square is 2x, and that is equal to not 6. That will be 0. So 2y prime, I'm going to open up the parentheses, minus x square y prime minus 2xy is equal to 0. So 2y prime minus x square y prime is equal to 2xy. I'm going to take y prime as a factor. So 2y minus x square is equal to 2xy. So y prime finally, which is also known as dy over dx, is equal to 2xy divided by 2y minus x square, which is exactly what I wanted to prove. Okay. Then they're asking that find the equation of a line tangent to the curve. Well, that's pretty straightforward. They have given a point. I'm going to plug that point over here to get the slope. So dy over dx will be replacing x by 1, y by 3, again y by 3, x by 1. So it will be 6 over 6 minus 1, which is 6 over 5. So the equation of the line tangent will be y minus 3 equal to 6 over 5 x minus 1. That's going to be the equation of the tangent line. Now they're saying that show that there is a point P with the x coordinate 0 at which the line tangent to the curve P is horizontal, and find the y coordinate of the point P. Don't you think that makes sense? I mean, see, if the line tangent is supposed to be horizontal, obviously its slope is supposed to be 0. And the slope is 0 means what? Dy over dx is 0. A dy over dx should be 0. This means that 2xy over 2y minus x square should be 0, which means that the top should be 0, right? So 2xy should be 0. So obviously one possibility is when x is 0, and one possibility is when y is 0. I don't really care about y equal to 0 because they are just saying that prove that the x coordinate is 0. So obviously x coordinate equal to 0 is definitely a possibility. And they're asking find the corresponding y coordinate. So all I need to do is plug in this x coordinate, x equal to 0, in the original equation and find the y. So this is going to look like y square minus 0 equal to 6. So y will be, although I want to say plus minus root 6, but I'll just say root 6 because I see the note here that y is greater than 0. So the answer is 0 comma square root of 6. That's the point. Okay, and finally, they want, oh my goodness, they need the value of d square y over dx square at the same point. And that's going to be fun. So we need to find the d square y over dx square, which involves a quotient and then chain and product. I don't know how many rules are there. So quotient rule is the first thing. I think I'm going to need more space. So I'm going to differentiate this and use the quotient rule first. So it will be low square 2y minus x square square. Low d high. When I differentiate 2xy, I need to use the product rule. So 2x remains as it is, and the derivative of y is y prime. And then y remains as it is, and derivative of 2x is just 2. Minus high d low, so high is 2xy, and derivative of low will be the derivative of this one. So it will be 2y prime minus 2x. That's the thing. Don't again make the mistake of simplifying the expression because they need at a particular point. The point is P, and P is 0 comma root 6, right? So I just have to plug in x as 0, which is beautiful, and y as root 6, because if I put x as 0, then lots of things will, just disappear. So let's put x as 0 first and see what are we left with. So this is 0 plus 2y minus, oh my goodness, great, x is 0, the entire thing is gone. This is 2y whole square. 2y times 2y is 4y square, and this is also, oh my goodness, really? Is the answer 1? It looks like that. Because, yeah, I mean, 4y square over 4y square, the answer is indeed 1. So d square y over dx square at the point P is just 1. Perfect. Okay. Inverse trig, guys, inverse trig. We need to find the equation of the tangent line to the tangent line means point and a slope, and unfortunately they have only given us the value of x. So they want us to find y and the slope. So derivative. Let's find f prime x first. So f prime x will be, the formula is 1 over square root of 1 minus inside guy square times the derivative of inside thing, which is just 5. And if I put x as negative root 3 over 10 over here, so that's going to look like 5 over square root of 1 minus 5 times negative root 3, or I can just put the negative here and multiply this by root 3 over 10 square. So this will be 5 over square root of 1 minus 5 times 2 is 10, right? And the square of negative root 3 over 2 is just 3 over 4, because square of negative is anyway positive. I hope you understand. 1 minus 3 over 4 is 1 over 4, and the root of 1 over 4 is 1 over 2, and 5 over 1 over 2 is 10. So that's the slope. I need to find its y coordinate as well. So it's just that I'll just plug in x as negative root 3 over 10 in the equation. So root 3 over 10. So this will look like sine inverse negative root 3 over 2. Now, if you guys think that the answer is um, 4 pi over 3, you're wrong. And that's the mistake that usually students do over here. Remember that sine inverse, when inside thing is negative, it returns a negative answer or negative angle. So the answer is negative pi over 3. Just be careful. So the equation of the tangent line will be y minus pi over 3 or plus pi over 3 is equal to slope, which is 10, times x minus root 3 over 10 or plus root 3 over 10. So that is the equation of the tangent line. All right. E to the x multiplied by secant inverse x. So that's the product rule, of course. I'm going to use dy over dx will be equal to e to the x remains as it is. Derivative of secant inverse x is 1 over absolute value of x square root of x square minus 1 plus secant inverse x as it is, and derivative of x e to the x is, it's like the most innocent function, right? It's just again e to the x. So the answer is e to the x. Honestly, I cannot really do much. I'll just rewrite probably in a more, it will look a little more aesthetic probably, but yeah, I cannot really do much about this guy. So that should be my final answer. That's what I'm going to mark. All right, derivative of inverse. Usually students are confused about this concept. Try to explain my best here. uh, g and g prime are given at various values of x, and h is the inverse of g, right? H is the inverse of g. So what is the derivative of h at negative 1? This means that derivative of h at negative 1 is as good as asking derivative of the inverse of g, derivative of the inverse of g at negative 1, right? Because h is g inverse. So I just replace this h with g inverse. And the formula is the derivative of inverse of a function is 1 over derivative of the original function at g inverse of that point. So it will be 1 over g inverse 1 over g prime of, now g inverse negative 1 is basically we are looking for y value in the g table, because g inverse minus 1 is original function's y value. So I can locate negative 1 over here in g. And what is its corresponding x value? That's negative 5. So I'm looking for g prime 5 basically. And what is g prime 5? Isn't that, sorry, g prime negative 5? Isn't that negative 3? Because g prime at negative 5 is negative 3. So the answer is 1 over negative 3. Likewise, over here we have, what is the equation of the tangent line to h at negative 1? Be careful. Tangent line at negative 1 means, once again, the negative 1 point is on the inverse, and we already have its slope. The slope is negative 1 over 3. So the point is negative 1 comma, negative 1 is original function's y value, and the original function's x value is negative 5, which will become inverse's y value. The slope is negative 1 over 3. So the equation of the tangent line will be y minus 5. So can't I just write plus 5 equal to slope, which is negative 1 over 3 times x minus minus 1, or x plus 1 over here. That should be our answer. Then they're asking what is the equation of the line that is normal to the curve at negative 3. So for normal, unfortunately, first I need to find the equation of the tangent or the slope of h at negative 3. So once again, if I'm looking for h prime negative 3, so basically I'm looking for g inverse prime of negative 3, which is 1 over g prime of g inverse negative 3. G inverse negative 3, as you can notice, is this is the y value, so its corresponding x value will be negative 4, so it will be 1 over g prime negative 4, and negative 4 g prime negative 4 is negative 5, so it's 1 over negative 5. But be careful, they're asking for the equation of the normal, which is negative reciprocal of this guy. Negative reciprocal will just be 5, and the point is negative 3 comma negative 4, right? Negative 3 comma negative, sorry, negative 3 comma negative 4, as we can see over here. So the equation of the tangent line will be y minus y1, so plus 4, equal to 5 times x minus minus 3, or plus 3. Right, guys, another similar question. Fx is g inverse x and gx is given. We need to find what is f prime of negative 10. I know that f is g inverse, so f prime of negative 10 can be written as g inverse prime of negative 10, which can be written as 1 over g prime of g inverse negative 10. And g inverse negative 10 we already know, right? Because g of negative 2 is negative 10. So g inverse of negative 10 is negative 2. So 1 over g prime of negative 2. And unfortunately, I don't know g prime, but I know g. I can easily differentiate this. So g prime is going to be, I think, 6x square minus 2x minus 5. So g prime of negative 2 is going to be negative 2 square is 4, 6 times 4 is 24. Negative 2, right? Negative 2 times negative 2 is positive 4, and this is negative 5. So this will be 28 minus 5, which is 23. So this will be 1 over 23. And that should be my answer, right? That should be my answer. That's what I'm looking for. Okay. We are given a function and its derivatives value at the point 0 and 1. And you need to find the first derivative of this guy. Let's call this guy gx. So g prime x at 0 is going to be, first let's find g prime. So I think I need to use a quotient rule. So I'll do low square 2 plus cosine x square, low d high, derivative of f is f prime, minus high, which is f prime x, and sorry, fx, times the derivative of low is derivative of 2 is 0 and cos is minus sine, so minus sine x. And all I need to do is just plug in 0 everywhere. So this is going to look like what? Cos 0, 2 plus cos 0, cos 0 is 1, 2 plus 1 is 3, then f prime 0, and then f0, it doesn't matter because sine of 0 is 0, so that thing is gone. Again, cos 0 is 1, so 2 plus 1 whole square. F prime 0, this is 0, this is f prime, which is just obviously 2, negative 2 over here. So 3 times negative 2, this guy is 0, over 3 square is 9. So the answer is negative 6 over 9, which is negative 2 over 3. So that's g prime x, and that should be g prime 0 to be precise, and that should be our answer. Finally, we have this last question. So we need to find, this is a composite function or nested functions. So we are given kx as a composition, and we need to find k prime x and then k prime pi over 4. So k prime x is going to be first the derivative of the outside guy, which is g prime, and inside guy remains as it is. And then we differentiate f, which is f prime x. So we know g, we don't know g prime. Obviously, we need to find that. So what is f prime x? obviously derivative of sine square x using the chain rule, because sine square x can be written as sine x square. So it'll be 2 times sine x, and then derivative of sine x is cos x. What is g prime x? That's going to be, of course, just 2x. So g prime of fx will be just 2 times of fx, right? So here I'm going to write 2 times of fx. I hope you understand. I just replaced this g prime of fx by 2fx, and then f prime x by 2 sine x cos x. That's basically I'm borrowing from here. And fx is sine square x. So 2 times sine square x times 2 sine x cos x. 2 times 2 is 4. Sine square x times sine x is sine cube x, and cos x is just as it is. So k prime x is this. And then in b, I just have to replace x by pi over 4. So we know that sine of pi over 4 is root 2 over 2, and then cube, and cos is also root 2 over 2. Root 2 over 2 cube times root 2 over 2 is basically root 2 over 2 raised to 4. And then root 2 over 2 can be written as 1 over root 2 raised to 4. And root 2 raised to 4 is basically root 2 times root 2 times root 2 times root 2. Root 2 times root 2 times root 2 times root 2. This is 2, this is 2. 2 times 2 is 4. So this is 4 times 1 over 4. So the answer is just 1.
The rate at, okay, just be careful if they are talking about the rate or the normal function, right? Just be careful, because APs usually trick like this. So this, they are talking about the rate. So P is rate. The rate at which Dr. L is downloading research articles per year is modeled by this, where T is measured in years. So what is the meaning of P3 equal to 150? So I would say that at t equal to 3 years, Dr. L, or the rate at which Dr. L is downloading research articles is 150 articles per year, right? It should make sense. That's a pretty straightforward thing. Okay, just be careful, or be attentive here to always mention the unit, because the APs are really specific about seeing the units of such questions. In fact, they mention it categorically, that mention the units as well, so just be careful. Right, now B is interesting. B is talking about the derivative, right? And remember, this is already a rate. So this is in a way the double derivative of the original function. So we are going to say that at t equal to 4 years, the rate at which Dr. L is downloading research articles is increasing, because the rate is now increasing, right? The rate is changing. That's basically a rate of rate. So I'm going to say that the rate of the at which he's downloading the research articles is increasing, and increasing and decreasing are again are really important. Had this was a negative, I would have said decreasing, but since this is positive, I'm going to say increasing. Increasing at the rate of 10 articles per year per year. That's the unit. So be careful again with the unit. So either you can write it as per year, or you can also write it as 150 articles per year square. Both are correct. Okay. The temperature of a freshly baked cookie in degrees Celsius is modeled by T, a differentiable function of time t minutes after the cookie is taken out of the oven. Given that t prime 4 is -6, then which of the following statements is definitely true about the cookie's temperature 4 minutes after it was removed? So obviously, just without reading the options, I can see that if t prime 4 is negative and T is the temperature, then obviously at T equal to 4 minutes, the temperature of the cookie is decreasing at the rate of 6 degrees Celsius per minute, right? Okay, option B looks pretty tempting. The temperature of the cookie is decreasing at the rate of 6 degree per minute at t equal to 4 minutes. I'm going to go with option B, but okay, let's read the other options as well. The temperature of the cookie, nope. The cookie's temperature is increasing, definitely not. The temperature of the cookie has decreased by total of 6 degrees, not really. Derivatives are not about total. That's the integral word. Integration talks about the total thing, not the derivative. So definitely the answer is option B. A vertical cylindrical rainwater cistern with a radius of 5 meter and height 10 meters being filled. The water level is rising at a constant rate of 0.4 meter per minute. That's the rate of change of height, of course. Which of the following statements is true when the height of the water is h equal to 3 meters? And they are talking about the volume and area and these things. So, what is the volume of a cylinder, by the way? It's pi r square h. And obviously, the radius is not going to change in a cylinder, right? The radius is always constant in a cylinder. Doesn't matter what is the level of the water. Let's say the water is over here. So, the radius is not changing. But yes, of course, the height is going to change. So what is the dV over dt? I'm talking about related rates now. So it will be pi r square dh over dt because radius is not changing. What is radius? I think that's 5. And what is dh over dt? That's 0.4. 5 square is 25. 25 times 0.4 is 10. So that's going to be 10 pi. So volume is changing at 16 pi. That's not correct. There you go. Option D. The volume of the water in the cistern is increasing at the rate of 10 pi cubic meter per minute. Of course, the unit is very important. Volume is meter cube and the unit of time is, in this case, is minutes. So meter cube per minute when h is 3 meters. All right, that's how it works over here. So option D. Okay. Research team created the function p of t. Predict the number of penguins in an isolated coastal colony over the next 20 years, where PT is the projected penguin population 2 years from now. According to the model, which of the following represents the rate at which the penguin population will be changing at t equal to 7? Okay, they are asking what is the rate of change of the penguin population when t is 7. Obviously, these two are rejected because these are talking about average rate of change, right? Final, FB minus FA over B minus A, which is AROC. But if you're looking for the change at a particular point, which is 7, then you're talking about the derivative of the function at that particular point, which is going to be C. So it's P prime 7. That's how it is. Okay. The function t is equal to fp represents the time in minutes for a cooling fan to shut off automatically as the function of its power level p in volts. What are the units of f double prime p? Like this question was asked, similar question was asked in AP, I'm pretty sure, and here they are just tricking us with the weird variables here because we are not used to such variables. We are used to y equal to fx. So that's totally fine. Let's answer in terms of y equal to fx and then find out or draw an analogy with this question. Remember, we are talking about the double derivative of the function. So f prime x, let's say I'm talking about f prime x. F prime x is nothing but dy over dx. So its unit will be the unit of y over unit of x. That's how the unit of single derivative works. And the double derivative is nothing but d square y over dx square. In other words, that's basically again the unit of y, but this time unit of x squared because we are again differentiating it with another time with x. So if we draw the same analogy and replace y with t and x by p, this unit for the double derivative will look like unit of y, and y in this case is t, so t, over unit of x square, x in this case is capital P, so p square. What is the unit of t? Time is minutes, and the unit of p is power level measured in volts, so that's going to be minute per volts square. That's going to be the unit of f double prime p. I hope this makes sense. All right, suppose a car travels along a straight road according to the velocity time function this, where v is measured in miles per hour and t is in hours. At what time does the car change its directions and explain? The car changes direction wherever velocity changes sign. Right, so here the idea is we find the velocity function, which we don't have to because velocity function is already given in the question as t square minus 4. So I need to first find the zeros of this velocity function and then make a sign chart. So in other words, I want to set v to 0, which means that I want to set t square minus 4 to 0, which means that I want to do t minus 2, t plus 2 to 0, which means that the roots are clearly minus 2 and 2. And if I want to find the sign of this velocity, then just notice this expression and plug in the values of, uh, you know, uh, the time. Minus 2 doesn't make any sense because time is negative and obviously they are just talking about 0 and 5. So it makes sense that if you put anything greater than 2, maybe 100, so this expression will become positive. Anything less than 2, maybe 1, this expression will become negative. So yes, it changes the sign at t equal to 2, and that's my answer. At what time? So t equal to 2, the unit is hours, so t equal to 2 hours, that's my answer. That's when the object changes the direction. Right, pretty straightforward, I believe. A body's velocity function is given by this. Find the body's speed each time acceleration is 0. Okay, acceleration is just the derivative of time, a derivative of velocity. So I have to find v prime t, of course. And this is a pretty straightforward function, guys, in my opinion. It's just a polynomial. So the derivative of 2t cubed is going to be 6t square. Negative 9t square is going to be negative 18t, and 12t is just 12, and 5 is just 0. I want to find where acceleration is 0 first to find those times. So I'm going to set 60 square minus 18t plus 12 to 0. I think I can divide the entire equation by 6 or take 6 as a factor the way you want to see it. So 6 times t square minus 3t plus 2 is equal to 0, which means that t square minus 3t plus 2 is equal to 0, which means that t minus 1, t minus 2 is 0. That's a pretty straightforward quadratic, so I just factored it, which means that t is 1 and t is 2. Okay. Now at this time, I need to find the speed, mind it, speed, not the velocity. So how do we give, what is the formula for the speed or the relationship? The speed is just the absolute value of the velocity function. So all you have to do is plug in 1 and 2, 1 by 1 over here, and just take the absolute value of that, and that's your answer. So if I plug in 1, that's going to be 2 minus 9 plus 12 minus 5, which is going to be, this is minus 7, this is minus, oh, is that just 0? Yeah, I think so. So that's 0 meter per second at t equal to 1. And if I put t equal to 2, then that's going to be 2 times absolute value of 2 times 2 cube minus 9 times 2 square plus 12 times 2 minus 5. So that is going to be 2, 4, 8, 8, 16, 16 minus 4, 9 times 4 is 36. Remember guys, these all questions are no calc unless otherwise stated. So 24 minus 5, this is going to be, I think, minus 20. 24 minus 20 is 4. 4 minus 5 is minus 1. An absolute value of minus 1 is 1 meter per second. So that's the other answer at t equal to 2 seconds. Right? I hope this makes sense. Alright guys, buckle up. Well, that's a pretty long question. Particle motion again. Particle moves along the horizontal line so that its position is given by this, where x is measured in feet and t is measured in seconds. What is the displacement of the particle during the first 3 seconds? Explain its meaning. So the displacement is just given by the change of position, guys, right? Let's denote the displacement by s. So s is during the first 3 seconds is given by x of 3 minus x of 0, as in the position at 3 minus the position at 0. How do I know the starting point is 0? Because, well, they are saying t greater than or equal to 0, so the starting point is 0. Let's plug in 3 here. So 3 over here. 3 square is 9. 4 times 3 is 12, and 3 is just 3. And if I plug in 0, then I get 0 minus 0 plus 3, so that's just 3. So this comes out as 9 plus 3 is 12. 12 minus 12 is 0. 0 minus 3 is minus 3 meters. So what this means is it is 3 meter to the left of where it started from. So that's what that's what we say is the meaning of this. That is 3 meter to the left of its starting position, starting position, starting position. All right. The next is find the average velocity during the first 3 seconds. Guys, we need to know the formula that V average is given by total displacement over total time. We already found the displacement during the first 3 seconds in part A, right? That was -3. So that's going to be -3 over 3, which is -1 meter per second. Okay, they're also asking the meaning of this -1. So the meaning is going to be on an average, the object or the particle is going to the left at 1 meter per second during the first 3 seconds. That's what it means. Okay. Part C is asking when the particle's initial velocity and the velocity at rate. So this is about instantaneous velocities. This is not average. How do we find velocity from the position function? Obviously by taking the derivative. So I'm just going to do it over here. Velocity function is just t square, 2t minus 4. That's the derivative. So v at 0 is going to be -4 meter per second. And what this means is that at t equal to 0 second, the particle is going to the left at 4 meter per second. And if we find V3, it will be 3 times 2 is 6, 6 minus 4 is 2 meter per second, which means that at t equal to 3 seconds, the particle is going to the right at 2 meter per second. That is the meaning and the interpretation. Right, find the particle's acceleration at t equal to 3, explain the meaning. So acceleration is obviously just the derivative of the velocity. I already have the velocity from here, which is 2t minus 4, which means that the acceleration is just the derivative of the velocity, which is 2 meter per second square. Explain its meaning in terms of particle's velocity. So if the acceleration is positive, which it means that the velocity is increasing. So at t equal to, what was that? 3, the velocity of the particle is increasing at the rate of 2 meter per second square. That is the interpretation. At t equal to 3 seconds, is the speed of the particle increasing or decreasing? This is a pretty popular question, guys. They are asking whether it is speeding up or slowing down. And remember that speeding up and slowing down depends on two things: velocity at that point and acceleration at that point. If both are of the same sign, for example, both are positive or both are negative, that's going to speed up or increase, speed is going to increase. And if they're of the opposite sign, then the speed is going to decrease. Now, we already have the speeds, right? The velocity at 3 is 2 meter per second, which is positive. Acceleration at 3 is also 2 meter per second square. The point is it is positive. Since both are positive, it is going to increase. Why? Because the velocity is also positive and acceleration is also positive. During what times is the particle moving to the right, to the left? At what values does it change the direction? So obviously this is more about just the velocity thing. It moves to the, let me do it over here. So we know that the velocity function is 2t minus 4. That was it, right? Yeah. So it is moving to the right. I'm just going to make a sign chart. What will be the 0 of 2t minus 4? If I equate 2t minus 4 to 0, obviously I'm going to get t as 2. So, remember that this is just 0. So anything greater than 2, if I plug in over here or over here, that's going to be, let's say, 100. So that's going to be positive. And if I put 1, that's going to be negative. which means that it is moving to the left between the time 0 and 2. 0 can be included, close bracket 0 and parentheses 2, and it is moving to the right for 2 to infinity, which also means that at t equal to 2 it changes direction, changes direction over here. Okay. Find the total distance that the particle travels in. Now, this is very careful. Be very careful about the total distance because, yeah, of course, you will be exhausted while solving all this. But remember, since we do not know the integration yet, we have to be really careful where it is taking the reverse direction and where it is forward. And fortunately, we have that, right, for the first 3 seconds. So we know that from 0 to 2, it is going to the left, right? So let's say it started at t equal to 0 here. So at t equal to 2, it will be somewhere over here, going to the left. And from 2 to 3, it is going obviously to the right. So I don't know, maybe somewhere here. I don't know how much it travels, but the point is it is going to the right. So this question should be solved in 2 parts. First, find the total displacement from 0 to 2 and put a take the absolute value of it. So we have to find what is x of 0. I think I already found that x of 0 in this question is 3 right here. So x of 0 is 3, which is just here. What is x of 2, guys? Do I have x of 2? I don't. So let's plug in x as 2 over here. 2 square is 4, 4 times 2 is 8, and plus 3. So that's 7 minus 8, which is minus 1. So it started from 0 and then it went to minus 1, which means that how much has it covered? 4 units. I'm just interested in the magnitude because I'm talking about the distance. Then x of 3. I think x of 3 is just 0. I already found that over here. It was 0. So if x of 3 is 0, then from negative 1 to 0, how much it has covered? 1 unit. So what is the total distance? That's just going to be 5 units or 5 meters. That's going to be our final answer. I hope this makes sense. It was a pretty good question, extremely conceptual, but yeah. Okay. Now this is based on graph. The graph above shows the velocity function. Just be careful. What is that? Is that position, acceleration, velocities? In this case, it is velocity. For 0 to 11, semicircle, At what times between 0 to 11 is the particle speed the greatest? And what is speed? Speed is just the absolute value of the velocity. So I don't really care about the sign now. I just look at what is the maximum number, absolute number possible. And it looks like that is 6 because absolute value of negative 6 is 6. And that's going to be the greatest speed, which happens at t equal to 8. It looks like it's t equal to 8. Yeah. So at what time they're asking, I'm going to return t as 8 hours or just t as 8. At which of these times is the acceleration of the particle greatest? So acceleration is just the derivative of the velocity, and which is just the slope. So at t equal to 2, obviously the acceleration is just 0 because the slope is 0. So that's 0. At t equal to 6, 6 is somewhere over here, guys, which is going to be a negative number. And t equal to 9 is somewhere over here, guys, which is going to be a positive number over here. But I think they are just interested in the magnitude, right? Which one has a bigger magnitude? So I think you need to find the slope at these two points, right? This point is 8 comma negative 6. This point is 4 comma 0, and this point is 10 comma 0. So over on the left side, the slope is going to be 0 minus minus 6 over 4 minus 8, which is 6 over negative 4, negative 6 over 4, or negative 3 over 2. Over on the right side, the slope is going to be 0 minus minus 6, which is again 6, over 10 minus 2, which is, I think, 10 minus 8, which is 2. So that's going to be 3. Obviously, this is way bigger than negative 3 over 2. Also, it looks more steep just by eyeballing it, but I just wanted to show you the math as well. So I'm going to call t equal to 9 hours as the answer. Over what open interval between 0 to 11 is the particle moving to the left? Obviously, the particle moves to the left whenever the velocity is negative. And I can see that the velocity is negative as in below the x-axis over here. So my answer is going to be 4 to 10, right? That's where the velocity is negative. On what interval is the velocity of the particle increasing? The velocity of the particle increases wherever acceleration is zero. Acceleration is greater than zero. And acceleration is positive, or literally, why to even go in all of that? They are just calling velocity increasing, and the graph is of velocity. So it's as simple as where is the function increasing? So obviously, the function is increasing over here and over here. That should be my answer, right? That's where the function is increasing. So I'm going to say that my answer is going to be 0 to 2 union 8 to 11. That's going to be the answer. On what open interval is the speed increasing? Now be careful. Speed is not the same as velocity. Speed means both acceleration and velocity are of the same sign because they want it to be increasing. So let's divide it in portions. Between 0 to 2, okay, I know that velocity is positive when it is 0 to 4, right? Now in 0 to 4, where is the acceleration also positive? Obviously, wherever the function is increasing or the velocity is increasing, and that happens from 0 to 2. So my first interval, let's write it like this, is 0 to 2, because here the velocity is also positive and acceleration is also positive. Not in 2 to 4, I think we agree, because the acceleration is negative. Now over here the velocity is negative and acceleration is also negative because that's a negative slope. So I have 4 to 8 as well in my answer. But 8 to 10 will not work because velocity is negative and acceleration is positive. So that's a no. 10 to 11 will again work because that's a positive slope. So positive acceleration and positive velocity. So there you go, 10 to 11 as well. So this is my final answer. Let me zoom it out. So I'm going to say that it is 0 to 2 union 4 to 8 union 10 to 11. At what time is the acceleration undefined? Acceleration is undefined wherever the derivative is not possible. And the derivative is not possible at the sharp corners in this case. So 4 is a sharp corner and 8 is a sharp corner. So at these points, the differentiation is not possible and hence the acceleration is undefined. So that's going to be t equal to 4 and t equal to 8. Find the area of the semicircle from 0 to 4 bounded by the curve and the x-axis. Then find the area of the triangle from 4 to 10. And finally, the area of 10 to 11. If all of these areas were positive and added together, propose what quantity this might be in terms of the particle movement. This is more of a concept, guys, that whenever you find the area of velocity time curve, there are two things that you can get. If you add the sign sensitive areas as in, let's say the magnitude of these areas are A1, A2 and A3, this one is A3. If you add A1 minus A2 and A3, because this area is below the x-axis, so that's negative, you will get displacement. But if you only add the magnitudes, guys, then you are going to get distance. And that's what they are asking, that if we just add the numbers, then what will be the answer, and what will that be? So that will be distance. That's the first thing. So I'm going to get distance over here. That's for sure. That's distance. And what is the answer? Area of the semicircle is half of pi r square, and r is just 2. So that's 2 square. Area of triangle will be half times base. 4 to 10 is 6, of course, so that's the base. And height is 6. Plus the small triangle, half of base is 1, and the height is, I think the height is going all the way to 3, so 3. So that's going to be 2 squared is 4, 4 over 2 is 2, so that's 2 pi plus 36 over 2 is 16, and this is 1.5. So my answer is 2 pi plus 19.5. 2 pi plus 19.5. That's going to be the distance over here. That's the answer. Yeah. I hope this makes sense to you guys. Okay, guys, if you feel like you need some extra help or something, this is too complicated for you, then feel free to reach out for the private tutoring. All right, we are now going to the related rates question. Okay. A conical paper cup is 10 centimeter tall with a radius of 10 centimeter. The cup is being filled with the water so that the water level rises at 2 centimeter per second. So this is clearly the rate of change of height. At what rate is water being poured into the cup if the water when the water level is 8? So they are asking, it's very important to know what they are asking. Rate at which the water is being poured means they are asking what is dV over dt over here. Okay. With the cone, it's not that easy because the radius and height are changing together. So let's say this is some particular instant, and over here the height is obviously the radius is 10 and the height is also 10 over here. Let's say this radius is r and this height is h at some point. So this is a very popular relation in a cone that when we make two triangles like this, first is what you're seeing in the green and the other in what you're seeing in the blue. They are similar because these are 90 degrees and this angle is common. So by asimilarity, they are similar. So I'm going to write the ratio that 10 over 10, as in this side over this side, should be equal to r over h, which means that 1 is r over h, which means that r is always h. That is required because when I will write the volume formula, which is 1/3 pi r square h, I don't really know at what rate is radius changing because they honestly just gave me the height. So it's important to replace radius in terms of height so that I can proceed with this question. So v is 1/3 pi h squared times h. So that's going to be 1/3 pi h cube. That's going to be v. So dv over dt is going to be 1/3 pi, and the derivative of h cube is 3h squared dh over dt. I hope you understand this. It's just a chain rule. 3 is gone. So dv over dt is going to be pi h squared dh over dt. And height is given. We have to find when the when the water level is 8, which means that the height is 8 and dh over dt is obviously 2. So my answer is 64 times to 128 pi. Unit is very important. Volume is going to be centimeter cube and per second is as it is. So that's going to be the final answer at which the rate of volume is changing. Okay. The spherical balloon is inflated so that its radius is increasing by, oh, that's interesting because the rate of change of radius is dependent on the radius. How fast is the volume changing? Okay, volume of the sphere, guys, is given by 4 over 3 pi r cube. So dv over dt is given by 4 over 3 pi, and the derivative of r cube is 3r square dr over dt. 3 is gone. So I'm left with 4 pi r square and dr over dt is 2 over r. So this is going to look like 4 times 2 is 8. So 8 pi r, that's the dv over dt. And all I have to do is plug in r as 4 over here. So 8 times 4 is 32. So it's 32 pi, and the unit is of course centimeter cube per second. So that's the final answer. Right. A 7 feet tall person is walking away from a 20 feet tall lamppost at a rate of 5 feet per second. Assume the scenario can be modeled with similar triangles. So at what rate is the length of the person's shadow changing when the person is 16 feet from the lamppost? Okay, the situation is something like this. There is this lamppost which is 20 feet, and then there is this person who is 7 feet. And this is how the triangle is being formed, similar triangles. And obviously, if you are able to imagine, if the lamp post is somewhere over here, if this is the lamp post and this over here is the person, then his shadow will be this length, right? The shadow will be this length. A person is walking from the lamppost as well at the rate of 5 feet per second. Okay. Let's take some numbers, and what do we need to find first? What is the rate of change of the length of the shadow? So let's say the shadow is x, and let's call this as y. We need to find what is dx over dt, that is for sure. And what are we given? Don't you think this 5 feet per second is basically the rate at which this person's distance from the lamppost is changing, right? So isn't that just dy over dt? That's given in the question as 5. Okay, now we're going to talk about similar triangles. So 20 divided by x plus y, because that's the side length of the triangle. So 20 divided by x plus y, that is equal to 7 divided by x, because these are the side lengths of a smaller triangle. So 7 over x. Let's cross multiply. So 20x will be equal to 7 times x plus y, which is going to be 20x is equal to 7x plus 7y, which means that 13x is equal to 7y. And I need to find dx over dt. So let's isolate x, which is 7 over 13y. And all I need to do is take the derivative on both the sides, as in dx over dt on both the sides is equal to 7 over 13 times dy over dt. And what is dy over dt? 5. So that's going to be 7 over 13 times 5, and 7 times 5 is 35. So that's going to be 35 over 13 feet per second. That's going to be the answer of the rate at which the length of the shadow is changing. This question is pretty important, guys. At least it's important for a school. AP is also, you can expect something like this in MCQ as well. So yeah. Okay. An observer stands 700 feet from a launch pad to observe a rocket launch, and the rocket blasts off and maintains a vertical speed of this. Assume the scenario can be modeled by a right triangle. How fast is the observer rocket angle of elevation is changing? Okay, interesting. When the rocket is this, okay. Situation is something like this, guys. This is the rocket, and this is how it is going up. And the person is at a constant distance, fixed distance of 700 feet. And this is how the person is looking at the rocket at any time, sorry. And this is the angle. And we are given that if this is y, then we are given dy over dt, which is the vertical speed, is 900 feet per second. Fair enough. Okay. The way I see it, since I need to find d theta over dt, I think I need to find a way to relate theta and these people, right? And I think tan is a good way, because if I say tan theta, then I will say y, which is opposite, over adjacent. Adjacent is fixed always. So this. And if I take the derivative, then the derivative of tan is secant square theta. And then I have d theta over dt is equal to 1 over 700 as a constant. And the derivative of y is dy over dt. What is dy over dt? 900. Let's sub that in. So 1 over 700 times 900. Now the question is, what is secant square theta? And that's where this comes in. That we need to find the angle when the rocket is 2400 feet. So when the rocket is 2400 feet, the scenario will look something like this. This is 2400 and this is 700, right? I think I can definitely use Pythagoras and find this one. Guys, this is a very popular triplet, 7, 24, and the other one has to be 25. You can definitely check from the calculator, but it's going to be 25, and I'm just going to put 2 extra zeros. This is theta, and cos theta will be adjacent over hypotenuse, which is 7 over 25. So the secant theta is just the reciprocal of cosine, which is 25 over 7. Square d theta over dt. 0, 0, 0, 0 is gone. 25 square is 625. 7 square is 49. D theta over dt is equal to 9 over 7. 7 times 7 is 49. This is crossed out. So my answer will be d theta over dt is cross multiply. 9 times 7 is 63 and over 625, and the unit is of course radian per second. So this is the rate at which his angle of elevation is changing, or yeah. Alright guys, so far we have covered what do you call it, as interpretation of derivative and double derivative and the function. We have covered particle motion, we have covered related rates, and now we are going to cover the last topic, that is L'Hopital's rule. Yes guys, these are the only 4 topics in this particular unit. Okay, this is popular guys. Usually they ask L'Hopital's rule in as a part of FRQ and in MCQ as well. Okay, evaluate this limit. So since I already told you this is L'Hopital, so obviously this is going to turn into a 0 over 0 form. You can definitely check if you plug in 3 here, 3 minus 3 is 0, or over here 9 minus 3 is 6, and ln 6 minus ln 6 is 0. So how do you perform L'Hopital? You differentiate the numerator and you differentiate the denominator separately till the point you get a situation where you have a closure. Either you have an answer or you have an undefined, something should be there, not indeterminate. That's what you want to avoid. Derivative of ln of x squared minus x is 1 over the denominator, 1 over the inside, and the chain rule says that it should be 2x minus 1 as well over here. Ln 6 is 0, so I'm not writing that. If you want, you can use a product rule here, or if you want, you can also or we can open the denominator up as well. So let's do that. Numerator will just remain as it is, and denominator will be x squared plus 4x minus 3x is x, and minus 12. I hope you guys understand how I opened this up. I just foiled it. Okay, what is the derivative of x squared plus x minus 12? It's just 2x minus 2x plus 1. I'm sorry. Okay. Well, it looks pretty gross, so I'm gonna probably decorate this a little bit. So 2x minus 1 as it is. Using keep change flip, I have x squared minus x here and 2x plus 1 here. And it feels like if I put x equal to 3, I will get an answer, because if I put x equal to 3 on the top, 3 times 2 is 6, 6 minus 1 is 5. 3 squared is 9, 9 minus 3 is 6, and 3 times 2 is 6, 6 plus 1 is 7. And 7 times 6 is 42 over here. Sorry about this, guys. The options are wrong over here. This should have been 5 over 42. Let me correct that. Yeah, so answer has to be option B. Okay, evaluate this limit. Once again, if you put -1 over here, you can check that e to the 1 minus 1 minus 1 over cos of -pi over 2 is just e to the 0. E to the 0 is 1, 1 minus 1 is 0, and cos minus pi over 2 is also 0. So yes, it meets the condition to apply the L'Hopital's. Let's apply the L'Hopital's over here. So I'm gonna differentiate the numerator, which is just going to be e to the something is just e to the something, and the derivative of the power is just 1. So I mean, there is a chain rule, but there is no chain rule. Plus the derivative of x is 1, and then the derivative of cos is negative sine pi x over 2. Using the chain rule, I go inside and differentiate pi x over 2, which is just pi over 2. So I'm going to place x as -1 now, which is e to the 1 minus 1 plus 1 over negative sine negative pi over 2 times pi over 2. So that's going to be e to the 1 minus 1 is 0, 0 plus 1. Sine of negative pi over 2 is -1, so it's minus of -1 times pi over 2, which is 1 over pi over 2, and using keep change flip, I have 2 over, oops, sorry, made a mistake. E to the 0 is 1, not 0. So e to the 0 is 1, 1 plus 1, so that's 2 over pi over 2. That's going to be 4 over pi. So 4 over pi is option C. Yeah. All right, guys, over here, we are given a twice differentiable function, and we need to answer this. So let's find out, let's plug in x as -3 and see what are we getting. Or on the top, it will become -6 minus 1, f of -7, and f of -7 is clearly 0. And if I put -3 here, then -3 squared is 9, 9 minus 9 is also 0. So yes, L'Hopital's case. So I'm going to differentiate the top, which is going to look like f prime 2x minus 1 times 2. Using the chain rule, and x squared minus 9 is just 2x, and 2 is gone. Let's plug in -3 again. So this is going to become f prime -7 over -3. F prime -7 is 6. So 6 over -3 is the answer, which is -2. So it has to be option B. The second one says that again, if you put -5, that's going to turn into a 0 over 0. F of -5, for example, is -3, and f of -3, since this is a composite function, f of -3 is clearly 0. So let's differentiate this as, and obviously denominator is -15 plus 15, so that's 0. That allows L'Hopital's. So I'm going to differentiate this guy, f of fx. So that will be f prime of fx times f prime x using the derivative rules, and the denominator is just 3. So if I plug in f of -5 now everywhere, this is how it is going to look. What is f of -5, guys? F of -5 is -3. So let's write that. Let me zoom it out so that I can see everything. Yeah, that's a good window. I hope you can also see it. F prime of f of -5 is -3, and f prime of -5 is as it is over 3. Now, what is f prime -3? F prime window is this one, and -3 is over here. So we are talking about 9. F prime -3 is 9, and f prime -5 likewise is -1 over 3. So -9 over 3 is just -3, which is going to be option B. That's the answer. Over here, we are given a graph, and once again, we need to find a limit of x approaching to 4 of this. So again, if you put 4, then you will get g of 4 minus 3 is g of 1, g of 1 is 0. And if you put 4 over here, you are also going to get 0. So using L'Hopital's, I'm going to say that limit x approaching 4, g prime x minus 3 over 2x minus 2. And if I plug in 4 now, that's going to be g prime 1 over 4 times 2 is 8, 8 minus 2 is 6. G prime 1 is basically the slope at this point, right? So I can just take any 2 points. This point is -1, -1, and this point is 1, comma 0. So the slope is going to be y2 minus y1 over x2 minus x1, which is going to be 1 over 2. So that will be 1 over 2 over 6, which is going to be 1 over 12. So that's the answer, which is option A. And a similar question over here, h4, if you plug in, obviously that's 0, and this is also 0. So again, I'm going to differentiate this, which is going to be limit x approaching to 4 of h prime x over 1, which is going to be h prime 4. And clearly h prime 4 is just the derivative, which is the slope at 4, which is just 0. So it has to be option B. All right. Let f be a function defined on 2 to 6 and f2 is equal to f6, and the following properties that as f might have. The first property is f is continuous on 2 to 6 closed interval and differentiable on the open interval. Okay, fair enough. Fx is this, and then fx this is. Which properties ensures that there exists at least one c in this such that f prime c is... What does this remind you of? This setup that f2 is equal to f6 and f prime c is equal to 0 reminds me of Rolle's theorem. I hope it reminds you as well of Rolle's theorem. And Rolle's theorem states that if a function is continuous in a closed interval and differentiable in an open interval, and fa is equal to fb, as in f2 is equal to f6, then there exists at least one value of c within the interval of 2 to 6 such that the derivative at that point is 0. That's what Rolle's theorem suggests. So 1 definitely works for, because isn't that just the definition of Rolle's theorem? 2 also works because cos cube x is continuous always and differentiable always, right? The trig functions, sinusoidal functions are always continuous and differentiable. So 2 works, but be careful. This guy will not work because we know that absolute value guys form a sharp corner wherever the inside guy is 0, or in other words, x is equal to 4 in this case. So at x equal to 4, it is a sharp corner and sharp corners are not differentiable, and since within this there is a point where it is not differentiable, so 2 is definitely sorry, 3 is definitely not correct. So 1 and 2 both will work, so the answer has to be B in this case, option B. All right, determine if the function satisfies the hypothesis for MVT. If it does, then find all the possible values of C satisfying. Okay, MVT is what? There's just one condition overall is that is not an MVT, which is F0 is equal to F1. That we don't care about. We just care about whether it is continuous. Uh, in the closed interval and differentiable in the open interval. So yes, this guy is definitely continuous because x is not x is a cube root, so there is no such thing that is making this undefined at any point between 0 and 1, and this is also continuous. And yes, these guys are definitely not differentiable at for example, x equal to 1, because in this case x equal to 1 is forming a vertical tangent, or x equal to 0 over here is forming a bird or a cusp. But like I said, differentiability is on the open interval, not a closed interval. So yes, this is continuous between 0 and 1 closed interval, and this is differentiable in 0 to 1 open interval. So since this happens, differentiable in the open interval. So since both these happen, this is definitely, MVT is definitely applicable. Now what is MVT? MVT says that f prime C is fb minus fa over b minus a. Let's find FA or F0 first. So honestly, that's just 0, right? Because you put 0 here, you put 0 here, and 0 times anything is 0. So I'm getting 0 plus 0, which is just 0. And let's find f of b, which is f of 1. So that will be 1 plus 1 raised to 2 over 3, 1 minus 1 to the 1 over 3, which is 1 plus 0, which is just 1. And the derivative, okay, the derivative is going to be fun. So f prime x is going to be 1, that is the derivative of x, and here I need to use a product rule. So x to the 2 over 3 as it is, then 1 over 3, 1 minus x to the minus 2 over 3 times minus 1, plus 1 minus x raised to 1 over 3 as it is, and then 2 over 3 x to the negative 1 over 3 as the other thing. By the way, let's complete this thing. This is FB, which is 1 minus 0 over 1 minus 0, which is just 1. So I want that to be equal to 1. Okay, well. So this is 1 minus, because there is a minus from here, 1/3 x to the 2 over 3 and 1 over 1 minus x to the 2 over 3. I just brought this negative power in the denominator to make it positive. And the other guy is 2 over 3, and again this is a negative power, so let's bring it to the reciprocal, and this will be 1 minus x to the 1 over 3. And I want this f prime guy to be equal to that fb minus fa over b minus a, which is just 1. So let's put 1 over here. This 1 and 1 is crossed out. This 1 and 1 is crossed out, and I'm gonna move this entire thing on the left side. So it's gonna look like 1 over 3 x to the 2 over 3 over 1 minus x to the 2 over 3 is equal to 2 over 3, 1 over x to the 1 over 3, and 1 minus x to the 1 over 3. Annoying, right? I know. 3 gone from both the sides. Let's cross multiply. So x to the 2 over 3 is multiplied by x to the 1 over 3. It won't be annoying anymore. And then here 2 times 1 minus x to the 2 over 3 is comes here, times 1 minus x to the 1 over 3. Base is same, power is added, so it will just become x, because 2 over 3 plus 1 over 3 is 1. And likewise, base is same, power is added, so 2 over 3 plus 1 over 3 is again 1. So x is equal to 2 minus 2x. I just, distributed, adding 2x both the sides, so 3x is equal to 2, and x finally, oh my goodness, is 2 over 3. Unfortunately, 2 over 3 is also in the options, and 2 over 3 is also between 0 and 1. That's something that we have to make sure. So our answer, my dear friends, is option A. Okay. Which of the following functions satisfies the hypothesis of the MVT? Okay. I think this does, because it is always continuous. I mean, obviously not continuous at -2, but I'm not bothered. It is always continuous between 0 and 2. There is no such point that can make it discontinuous. And it is always differentiable as well. I mean, again, it is not differentiable at -2, but -2 is not here. So 1 definitely meets the criteria. So it cannot be option D. Okay, this guy, be careful. It's not differentiable at x equal to 1 over 2 right away. I think by this time you should be in a habit of seeing the powers of 1 over 3 and 2 over 3. These guys are so popular that x minus a raised to 1 over 3 and x minus a raised to 2 over 3. At x equal to a, these guys are not differentiable, this one, because it forms a vertical tangent. Remember, I'm saying vertical tangent. I'm not saying vertical asymptote. It is continuous but not differentiable because of vertical tangent. It is continuous but not differentiable because of cusp, which is basically a bird function. You must have heard this in your school, probably. That's what they call it. It's a bird function, something like that. And cusp is like something like that. Sorry, vertical tangent is something like that. Okay, so right off the bat, I know that x equal to 1 over 2, this is a vertical tangent. Unfortunately, 1 over 2 is between 0 and 1, so this is gone. Nope. And this guy, I think, yes, it has a sharp corner at x equal to 0. It is something like this. But once again, I'm not really bothered at x equal to 0 because it's not differentiable at x equal to 0, but the differentiability is checked in open interval, not closed interval in MVT. So this was a touch and go case, but it is accepted. So answer is 1 and 3. Yeah, option C makes the perfect sense. Right, selected values of differential data, which of the following could be false? By the intermediate value theorem, okay, by the way, this is a differentiable function. So whenever they say that a function is differentiable, it is automatically continuous, right? Because a discontinuous function can never be differentiable everywhere. By intermediate value theorem applied to the function in the interval 2 to 5, there is a value of c such that fc is equal to 10. This is true. They are asking what is false. So this is true, right? This is classic IVT, and not of this unit, but I hope you remember. IVT is just that since it is continuous between 2 to 5, so all the values between 1 to 31 will be possible, and 10 is between that. So since this is true, this is not our answer. We are again looking for false statements. By MVT applied to the function in 2 to 5, yes, we can apply that. There is a value of c such that f prime c is 10. We need to find that. Let's find f5 minus f2 over 5 minus 2. f5 is 31, f2 is 1, this is 3, so 30 over 10 is 10. Well, this is also true. So this is also true, not interested. By Rawls' theorem, in 2 to 5, there is a value of c such that f prime c is 0. Uh, really? Well, I don't really see any two values that are equal, at least over here. So I think this could be false because Rawls' theorem is only applicable when any two functional values are equal. I'm going to place a question mark here. Let's read the last one. By extreme value theorem, there is a value of c in 2 to 5 such that fc is less than equal to for all values between 0 to 3. Sorry guys, there is a slight correction here. This should be 2 to 5, not 0 to 3. So please make sure you make that correction. And yes, this is also 100% true because extreme value theorem, this is just a fancy way of saying there is a global minima. And yes, global minima occurs definitely between any 2 points if the function is always continuous. And yes, it is continuous. So between 2 and 5, there will be a global minima and there will be a global maxima as well. That's what it suggests. So yes, our speculation is correct. The answer is indeed option C. Right. Consider this differential equation. All right, guys, this looks like a tangent line approximation question. And fx be the particular solution to the differential equation with the initial condition f2 is 0. They're asking me to find the equation of the line tangent to the graph at this point. So, of course, line tangent needs a point and a slope. I have a point. I need the slope. So all I need to do is plug this point over here. So the equation or the slope is going to look like dy over dx will be equal to replacing y by 0 and x by 2. This is how it will look. E to 0 is 1, 2 squared is 4, 4 times 2 is 8, 5 times 2 is 10, so this is negative 2. So I have the equation now, and the equation of the tangent line is going to look like y minus 0 is equal to negative 2 times x minus 2. So it will be y is equal to negative 2x plus 4. That's our answer to question number 8. Then they're asking use the tangent line to approximate 2.2. So all you have to do is plug in 2.2 over here, because tangent line approximation is used to approximate the value of any point that is closer to this point. I mean, practically it makes sense only when you're picking a point that is closer to this one. So if I put 2.2 over here, my answer will be negative 2 times 2.2 plus 4, which is negative 4.4 plus 4, which is negative 0.4. That should be the approximation. Okay, find the absolute extrema of this. Candidates test, guys. Candidates test. I hope you remember what a candidates test is. The first step is to differentiate and find the critical points. Let's do that. This is a pretty easy function. So f prime x will be equal to 3x square minus 5 over 2 times 2x, gone. So this will be 3x square minus 5x. This can be, x can be factored out, so it will be 3x minus 5, that is f prime x. To find the critical point, we equate the derivative to 0 or undefined. This cannot really be undefined, right? This is a polynomial, but this can definitely be 0. So if I equate x times 3x minus 5 to 0, this means that x is 0 and 3x minus 5 is 0, which means that 3x is 5, which means that x is 5 over 3. Next step is to make a table and find the the functional value at these points. What I want to say is I usually make a table, and along with the critical points, you need to find the functional value at the end points as well, as in negative 1 and 2. So I'm going to write negative 1 here, 0 here, 5 over 3 here, and 2 here. And you're going to, we are supposed to plug all these points into the original function and find out how it works. So if I put negative 1 cube is still negative 1, and negative 1 square is just 1. So negative 1 minus 5 over 2 is negative 7 over 2. So negative 7 over 2. If I plug in 0, obviously this is just 0. If I plug in 2, 2 cube is 8 and 2 square is 4. So it will be 8 minus 10, which is negative 2. So negative 2. And if I plug in 5 over 3, then 5 over 3 cube minus 5 over 2 times 5 over 3 square. We can take 1 5 over 3 square as a factor. What are we looking for, by the way? Absolute extrema. Okay, so minima and maxima both. So this will become 5 over 3 minus 5 over 2. So this will become 25 over 9 times, I think this is, if I'm not wrong, over 6. 3 times 2 is 6, and 10 minus 15 is minus 5. So that's coming as a negative number, okay? Negative 125 over 54, that's what I have. So negative 125 over 54. So clearly, global maxima is this This is global maxima because this is the maximum value. So global maxima is this. And the minimum value is negative 3.5 because this, guys, is not even 3. It would have been 3 had this was 150, more than 150, the numerator. So it's not even 3. And this guy is, I mean, it's not even negative 3. And this guy is negative 3.5. So this guy is the global maxima, sorry, minima. So we got both the global minima as well as the global maxima from candidate's test. That's how it works. I can write the coordinate pair for you. This is 0, 0, and this is negative 1 comma negative 7 over 2. That's how it works. Okay, find the point at which this has the maximum. That again a candidate's test, this time with trigonometry. So again, I'm gonna find the derivative h prime x, which is 3 cosine x, and I'm gonna equate it to 0 because undefined is not possible. Remembering unit circle, guys, when is cos x 0? When x is on the y-axis, basically. When x is pi over 2 and 3 pi over 2. Let's find the functional values. Instead of making a table, I'll just write like h0, h pi over 2, h3 pi over 2, and h2 pi. From where is this 0 and pi, 2 pi coming from? These are the endpoints of the interval. We have to check at those points as well. What is h of 0? Remember, you need to put in the original function, not the derivative. So h of 0 is 3 times sine 0. Sine 0 is 0, so 0 plus 1 is 1. H of pi over 2, sine of pi over 2 is 1, so 3 plus 1 is 4. H of 3 pi over 2, sine 3 pi over 2 is negative 1. Negative 3 plus 1 is negative 2. And h of 2 pi, sine 2 pi is 0, so that's 1. They're looking for the maximum, and clearly the maximum is right over here. So the global maxima is going to be pi over 2 comma 4. This is the global maxima over here. Right, guys, I hope you understand this. Okay. Next question, what we have is, once again, guys, if you're finding this video helpful so far, please like it, please share it with your friends. It's going to really help them. And it will help me as well. And if you need private tutoring, feel free to reach out. Okay, now we are talking about when is the function increasing and where are the relative extremas. So increasing and relative extremas are all about first derivative and doing the sign chart on the first derivative, right, guys? So what are we looking at here? It's a simple polynomial. F prime is 3x squared minus 6x minus 9. I'm going to take 3 out, so it will be x squared minus 2x minus 3. And this can be factored very easily as x minus 3, x plus 1. So if I make a sign chart over here, this will be negative 1, this will be 3. And I hope you guys know a shortcut. I think I've been talking about that earlier, but I can explain it again. If the powers of all the factors that we have is odd, doesn't matter how big or small that is. For example, here it is just 1. Even if it is 101, then all you need to do is find this sign. For example, if you put anything greater than 3, maybe 100, so it will be positive. And then just blindly toggle the signs. No need to plug the numbers again and again. This is always going to happen provided the powers are odd. So they want increasing. Increasing is wherever f prime is positive. So the answer is negative infinity to negative 1, union 3 to infinity. And for what values of x does f have relative minimums or relative maximum? So relative minimum wherever this happens, right? Sorry, this happens, x equal to 3. Because relative minimums where the derivative changes from negative to positive, so x equal to 3. And maximums where it's plus to minus, so x equal to negative 1 is the relative maxima. Oh, there's more. For what values of x does this have point of inflection? So point of inflection is all about the double derivatives. So let's find the double derivative of this one. So f double prime is going to be what? 6x minus 6, right? Okay, so that's pretty straightforward, I think, in my opinion. If I just take a 6 out, I'm left with x minus 1. And when we equate this double derivative to 0, we will get x equal to 1. I will make a sign chart at 1. Anything on the right, maybe 100, positive, negative. And yes, this ensures that 1 is inflection. Remember, this is not the point where we can just stop and conclude that 1 is inflection, because at inflection point, the double derivative must have a sign change. And yes, this ensures that it has a sign change. Over here it is concave down, over here it is concave up, the original function. So yes, x equal to 1 is definitely an inflection point. Okay, all right, guys. Oh, now we're talking about graphs. Oh my God, that's a big question. All right, y is equal to g prime x. This is the graph of g prime x. Remember, g prime x, not gx. Determine where g has horizontal tangents and justify your answer. G has horizontal tangents wherever g prime is 0. And fortunately, we know the graph of g prime. So wherever g prime is 0, and I do see 3 points where the g prime is 0, so our answer should be x is equal to -5, x is equal to 2, and x is equal to 9. That's where the g prime is 0. What are the critical points of G? Well, critical points of G are wherever G prime is 0 or undefined. Well, I don't really see any such points where the G prime is undefined. I don't see any vertical tangent or anything like that. So I'm again going to stick with G prime equal to 0, which honestly I already have, right? So the answer will be -5 and 2 and 9. These are the points where the G prime is 0. For each critical number, determine if G has a relative min, max, or neither. And that depends on the sign change, guys, as we already know. So for example, I can make a number line here, -5, 2, and 9. And we don't even have to plug in the numbers. We just have to look at the graph. If you look at -5, it is changing from negative to positive because it is below the x-axis and above the x-axis. At 2, it is not really changing because it was positive before and positive after. And after 9, it is negative. This makes it very clear that the relative minima will be at x equal to -5 because it is changing from negative to positive. What is changing? G prime. And it is from positive to negative. So for x equal to 9, it should be a maxima. So that's how these things work over here. On what intervals is G decreasing? So G is decreasing wherever G prime is negative. G prime is negative. And G prime is negative when it is below the x-axis because this is the graph of G prime. So this is one interval and this is another interval. So I'm going to answer that it is going to happen from -infinity to -5, union 9 to infinity. That's where this thing is going to happen. Next, you're asking during which interval is G double prime negative? Okay, that's a little confusing. Why? Because G prime graph is given. G double prime is negative means G is concave down. Everyone knows that. But not helpful here because graph of G is not given. So G double prime x is negative or less than 0 also means that G prime of x is decreasing. Think about it like that. Whenever any function is decreasing, think about it just like a function. This is a function. And if this function is decreasing, its immediate next derivative should be negative. And that's what is happening over here, right? This is helpful because we are given the graph of G prime x. So all I have to find is where it is decreasing. So it is decreasing from here to here and here to here. So the answer is going to be, I think, -2 to 2. That's the first thing. -2 to 2. And the other thing is, I think, 6 to infinity, right? So 6 to infinity. That's the other interval where it is decreasing. Where exactly is it concave up? So again, concave up, G is concave up wherever G prime is greater than 0, and G double prime is greater than 0 wherever G prime is increasing. So it is increasing in the interval from negative infinity to negative 2, the other part that we didn't take earlier, and 2 to 6. So negative infinity to negative 2 and 2 to 6. That should be our answer. Negative infinity to negative 2 union 2 to 6. That should be our answer. And oh my goodness, this question will never end. On what intervals is G both decreasing and concave down? Fortunately, I have both the things right here on this window. G is decreasing here and G is concave up, sorry, decreasing and concave up here. So just find a common interval where both are happy. I'm going to make a number line. I'm going to plot negative 5 and 9 first and say that it is decreasing from negative infinity to negative 9 and 9 to infinity. And then concave up, I'm going to plot negative 2 here and 6 here. And I'm going to say that this is negative infinity to negative 2 and 2 to 6. Okay, sorry, I need a 2 as well. Then 2 to 6 over here. Okay, this is where it is concave up. Where are both of them happy? Where is the top line matching with the bottom? I think only this interval. Only this piece, right? That's where both are happy. So my final answer is negative infinity to negative 5. That's where it is both in decreasing and concave up. I hope you understand. And for what values of x does G have a possible point of inflection? So G has a point of inflection wherever G double prime is going to be 0 or undefined. And they're asking possible point of inflection. So yes, for it to be 100% true, the G double prime should also change the sign. But in other words, I can also say that because I need to, work in terms of G prime. So G double prime will be 0. How will I see that G double prime is 0 or undefined? Obviously, the derivative of this function, which is already G prime, is never undefined. There is no vertical tangent. But yes, the derivative is definitely 0 at here, at these 3 points. That's where the derivative is 0. And this is G prime and its derivative is G double prime because these are horizontal tangent lines. So the possible points of inflection are negative 2, 2, and 6. Why am I saying possible points? Is because I'm not really checking whether G double prime is changing its sign or not. Although this is a little weird question because they don't really ask about possibilities. They just ask about whether it is or not. But to be precise that whether these points are inflections or not, actually they are. Because if you notice carefully, in this portion, G prime is increasing, which means that G double prime is positive. Then this is decreasing, so G double prime is negative, and then increasing, and then decreasing. So actually, negative 2, 2, and 6 are the points of inflection. Negative 2, 2, and 6 are points of inflection. It's not about whether they are or possible or not. 100% they are points of inflection. So that should be our answer. Right, here we are given f prime x and they're asking for what values of x does f have a relative extrema. That's easy because f prime is already given. So I'm just gonna set f prime to 0 and then find the, what do you call it as? Sign chart. So 3x square x minus 4x plus 2 should be equal to 0, which gives me from here x equal to 0, from here x equal to 4, from here x equal to negative 2. Let's plot a number line. So this is negative 2, this is 0, this is 4. Anything greater than 4, let's call it 100. Remember, I'm using a first derivative test, so I'm going to put my numbers in the first derivative. Anything greater than 4, maybe 100. This is going to be positive. Let's put 1 here. So 1, I don't think so I need to ask this guy again and again because this is always positive. So 1 will make this negative and this positive, so overall negative. Then put minus 1, which will make this negative, this positive again, so it is again minus. And put negative 100, so this will make it this negative, so yes, a double negative will make it positive. They're asking relative minima or maxima, so this is relative maxima. X equal to negative 2 is relative maxima because it's changing from plus to minus, and this is just a critical point. It's neither max nor min because there is no sign change, and this will be relative minima because it is changing from negative to positive over here. Okay, fellas, a similar question, that double derivative is given and we need to find where h have an inflection point. Okay, where does h have? So again, the double derivative should be 0 and undefined. Undefined is obviously not possible, and it should change the sign. Remember, critical and inflection, these are a little different. So it is 0. I think I don't need to, you already, I hope you know that you just equate the individual factors to 0 just like that. So from here you're going to get 2, from here you're going to get negative 1 and negative 5 from here. So you make a number line, negative 5 here, negative 1 here, and 2 here. Okay, any number greater than 2 that you like, maybe 100. If you put 100 here, that will definitely be positive. Anything between these two, let's put 0. And once again, guys, I'm not really going to ask this guy again and again about his sign because that is always positive. It's a square. So if I put 0, these two are also positive. If I put negative 2, then this is negative, and remember it's a cube, so it will stay negative. And this is positive, so negative. And anything less than negative 5, maybe negative 100. So this is negative, so double negative will make it positive. So fortunately, there we have two guys who are point of inflection. Remember, this is not a point of inflection because there is no sign change. So x equal to negative 5 and negative 1 are the points of inflection. Then they're asking on what open interval is h prime increasing. H prime is decreasing. H prime is decreasing wherever its immediate next derivative is negative. And this is indeed the sign chart of h double prime. Where is it negative? Here, and well, only here. So the answer is negative 5 to negative 1. That's where h double prime is negative, so h prime is decreasing. And where is h concave up? H is concave up wherever h double prime is positive. And h double prime is positive means that h prime is why am I going that far? I don't need that because I have the sign chart. So h double prime is positive, and yes, the other intervals we can just clearly see that it's negative infinity to negative 5, union negative 1 to 2, union 2 to infinity. Fair warning, guys, I've seen students answering this guy as negative 1 to infinity. It's not correct just for one small reason, that you have to exclude x equal to 2, because at x equal to 2 the double derivative is 0. It's not positive. These are the zeros of that. So make sure you make that you have that break in your interval. All right, fellas. Question number 12, xe to the x, they're asking that for each of the following values of x, does the graph of k has a relative extrema? Okay, I think same old school. I need to find derivative of this, but unfortunately product rule is calling us now. So x times x remains as it is, derivative of e to the x is e to the x, and then e to the x as it is, and derivative of x is just 1. I'm going to take e to the x out and then x plus 1. That's what I have. For relative extrema, I need the critical point. For critical point, I need to set this to 0 or undefined. It cannot really be undefined. I don't really see any such thing. It's not a rational function or something. So it's just 0, which means that e to the x times x plus 1 is 0. E to the x is never 0. I hope you remember from your algebra class that e to the x just keeps increasing. It never hits this x-axis. It's actually an asymptote for it. So only x plus 1 can be 0, which makes x as negative 1. So if x is -1, need to find the sign change of it, and sign change means of f, sorry, k prime, right? Anything greater than -1 may be 0. No need to ask e to the x again and again, because like I said, e to the x is always positive. It's above the x-axis. So if you put maybe anything on the right, maybe 0, so that's going to be positive. Anything on the left, maybe -2 or -100, that's going to be negative. So they're asking for what values of x it has relative extra. Okay, so it has relative minima, not maxima, at x equal to -1. So please um, make sure you have that as minima, not maxima. Okay. Uh, this is based on a table pretty popular in AP, guys. Sometimes they ask 2 or 3 questions as a together based on the single, single table. So the table gives the f prime and f double prime of 2 guys, f and g. They're asking if g is an implicit function of this, is h, sorry, if h is an implicit function of this, then is h increasing or decreasing at 2? Or h has a horizontal tangent? To answer any of this, I need to find h prime. So h prime is going to be g prime fx times f prime x. I need to find at 2, so h prime 2 will be equal to g prime f2 times f prime 2. Okay, what is f prime 2? This is the 2 row and this is f prime row, so it is 3. And what is f2? f2 is, there you go, f2 is 0, so g prime 0. And what is g prime 0? This is 0 and this is g prime. G prime 0 is 2, right? G prime 0 is 2. So that's going to be 2 times 3. 2 times 3 is of course 6. 6 is a positive number, so this means that h is increasing. H is increasing at that particular point. So my answer is increasing. Right. Likewise, we have q function, which is this. So is q concave up or concave down? So unfortunately, this goes to 2 iterations. I need to figure out the double derivative. Q prime is going to be f prime 2x times 2, which is 2 times f prime 2x. And if we find the double derivative, q double prime, so 2 remains as it is, and f prime 2x derivative will be 2 f double prime 2x using the chain rule. So that's 4 f double prime 2x. That is q double prime. They're asking at x equal to 1. So q double prime 1 is 4 times f double prime 2. F double prime 2, so at x equal to 2, f double prime is 2, right? At x equal to 2, f double prime is 2 if I'm reading it correctly. So 4 times 2 is 8, so 8 means it is concave up. All right. Does the graph have a relative minima or maxima or neither at x equal to 0? Let's figure out. X equal to 0, guys, is right here. Now this is x equal to 0 line. Now is that a critical point? First off, yes, because f prime 0 is 0. And if we need to find the relative extrema, just find a sign of f double prime x, which is the second derivative test, right? So since f double prime 0 is a positive number, it is a relative minima. I hope you understand. I have used second derivative test, not the first derivative test, to figure out the relative maxima or minima. We cannot even use the first derivative test because in the vicinity of x equal to 0, we don't know. I mean, you might think that we know -2 and 2, but these are not the immediate vicinities. We need the sign chart and exact all the critical points, etc. So second derivative is the safest choice over here. Does g have a relative extrema or neither at x equal to 4? Let's figure out. at x equal to 4 is g prime 0? Yes, it is 0. At x equal to 4, g prime is 0. And g double prime at x equal to 4 is negative, which means that again using second derivative test, this time it is a local maxima. So using second derivative test, it is a relative maxima. Find the equation of the tangent line when x is negative 2. So first off, I need to figure out the y coordinate. So p of negative 2 will be f negative 2 cubed. What is f negative 2, guys? F of negative 2, there you go, 3. So 3 cube is 27. So the point that I have is negative 2 comma 27. I need to find the slope as well. So the p prime value, the p prime is going to be 3 times fx square times f prime x using the chain rule. If I plug in negative 2, then p prime negative 2 is 3 times f of negative 2 square times f prime negative 2. So this will be 3 times, what is f of negative 2? F of negative 2 is just 3. So I'm going to plug in 3 here. So this will be 3 square. And f prime negative 2 is? F prime negative 2 is right here. F prime, this is negative 2, this is f prime. So this is negative 4. So that's negative 4. 3 times 3 is 9. 9 times 3 is 27. 27 times 4 is, I think, 81, right? 7 was 28. Carry 2 4 so 9, sorry, 108. Yeah, 108, negative 108. So this is the slope and we need to find the equation. So I'm just going to write equation over here. It will be y minus 27 equal to negative 108, x minus minus 2, which will just become x plus 2. So this is going to be our equation for E. And F, increasing or decreasing, once again this is just the f prime thing, guys. So for the f prime, unfortunately we need to use a product rule here. So m prime x is going to be f prime x times gx plus fx times g prime x. So m prime negative 2 will be f prime negative 2 times g2 plus f, sorry, why is that g2? G negative 2. G negative 2 plus f negative 2 times g prime negative 2. Okay, all right, let's move up and get the values at negative 2. I'm just going to shade it, otherwise I will be lost with so many values. And I'm looking for first f and f prime. Let's find f and f prime. So f is 3 and f prime is negative 4. Okay, f is 3 and f prime is negative 4. And g prime. G is 4, g prime is also 4. Great. 4, 4. So there's 4 and then there is another 4. 4 times negative 4 is negative 16 and 4 times 3 is 12. So this guy is negative. So this is, since derivative is negative, the function is, sorry, what am I saying? The function is decreasing at that point. So the derivative is negative, which means that the function is decreasing over here. Well, that was a long question, guys. I hope you understand. Right. All right, guys, doing something light now. These are multiple choice. Light doesn't mean easy. Light just means that these are multiple choice. So we are given h and we need to figure out which of the following could be h prime. All right. I think I'm interested in looking at the maximas and minimas first, because the maximas and minimas of h prime are clearly where the derivative is 0, because these are, you know, horizontal tangent, or maybe by the first derivative test we know that. So it looks like the derivative should be 0 at a negative number and at a positive number. Clearly not a derivative is not 0 in the negative. Clearly not B, it's not 0 anywhere in the positive direction. And C, D, and E are definitely strong candidates, just keeping that thing in mind. Okay, what else? I think I'm talking about increasing, decreasing now, because wherever the H prime is increasing, I'm sorry, H is increasing, the derivative should be positive. So the derivative should be positive during this highlighted interval.
right? Let's see if the derivative is positive. Okay, clearly C is gone because C is behaving exactly opposite. On the left side of this, it is negative, right? It is going in the negative direction, which is definitely not something that we want. So this is gone. And this makes sense because it is positive here and then it is going negative in between, and it is positive over here as well. So it has to be either of D and E, but then I'm again noticing, I mean, I know that the answer has to be E because my logic says that this looks like a cubic function, and derivative of cubic is a square, square is a parabola, which looks like E. But okay, if anyone of you is not convinced with this logic, then look at this now. We are talking about concavity. Look that, if you notice carefully, this is all frowning in nature till this point, and then it is smiling. Frowning means h double prime is negative, which also means that h prime is decreasing in nature. But look at this portion. It is not decreasing, it's increasing slightly. I want completely decreasing and then completely increasing. So this logic also corroborates our understanding that it has to be option E. I hope you understand the logic. Okay. Now this is vice versa. Here we are given f prime and we need to figure out what is f. So once again, the logic still stays the same, guys. Wherever f prime is 0, for example, you know, this one where f prime is 0, so fx has to attain a local max or min. It cannot be A, it cannot be B, it's not attaining any max or min. C, D, and E are definitely attaining a max or min at these points, so that works. Now, another way, another important thing is f prime is positive between -2 and 2. It means that the function should be increasing from -2 to 2 because f prime is positive. But here the function is increasing and then decreasing and then increasing. Here the function is increasing and here the function is decreasing. Since I only need increasing, it has to be option E clearly because it has to be increasing because the derivative is positive. All right, guys. Let f be a function that is continuous in the interval -2 to 3 such that f prime does not exist, f prime 0 does not exist, f prime 2 is 0, and f double prime is negative for everything except 0. Which of the following could be the graph of f? Okay, if it is continuous in -2 to 3, how can D be the answer? Because it looks like D is discontinuous, right? There is a break over here. There are two separate pieces. So D is gone for that reason. F prime does not exist, F prime 0. So F prime 0 does not exist means, you know, at 0 it has a vertical tangent or a sharp corner, etc. But look at C. C does not have any such funky stuff. In fact, we can easily draw a tangent at 0 and find f prime 0. So that's gone. Yeah, A, B, and E have sharp corners, so they are not defined. Now they are saying f prime 2 is 0. It means that at 2 I have a local max or min. Unfortunately, all three are meeting that criteria, so this is not helpful for us. And f double prime is negative for all except x equal to 0. F double prime is negative means function is concave down. But how can A be the answer then? Because this is smiling in nature. Concave up, not allowed. How can B be the answer? It is smiling in nature all the way, not allowed. Yes, E is the answer because it is frowning here and it is frowning here as well. It's concave down, that's what I want. So the answer must be E, guys. I hope you understand. Right. Here we are given that y is a function such that its derivative is positive and double derivative is negative. So which of the following could be a function? I think that's pretty straightforward because if derivative is positive, it means that the function is always increasing. So it cannot be C because this is decreasing. It cannot be D because it is decreasing after this portion. So it has to be the remaining three. And they are saying that y double prime is negative, which means that it is concave down always. It cannot be A because it is a smiling in nature.
It cannot be E because it is smiling during this portion. It has to be B because it is continuously frowning in nature or concave down. Okay, fellas, optimization. All right. A rancher has 200 feet of fencing to enclose two adjacent rectangular corrals as shown. Find the values of X and Y that will maximize the total area. All right, fellas, this is X, this is X, this is X, Y, and Y. 200 feet of fencing means that sum of all these boundaries is equal to 200, which means that I have 1, 2, 3, 4 X's and 3 Y's that should add up to give 200. What is the idea of optimization, guys? The idea of optimization is first to optimize means making anything maxima or minima. So first you might want to find the function that you have to maximize or minimize. In this case, the area. So the area is definitely xy plus xy because there are two small rectangles. So it's 2xy. And in order to maximize or minimize anything, you will differentiate. But you will have two variables in such questions. So in order to do away with the other variable, you have a condition given in the question. And using that helpful equation, you find that third variable, plug that back in over here so that this is only in terms of x. Then you differentiate and then you use the candidates test, of course. That's what we are looking for. So over here, I'm gonna find that 3y is equal to 200 minus 4x and y will be equal to 200 minus 4x over 3 over here. So the function is going to look like 2x times 200 minus 4x over 3. So that looks like just 2 over 3 times 200x minus 4x square. If you want, we can take 4 out as a factor as well from 204. So it will look like 4 times 50x minus x square. So it's 8 over 3, 50x minus x square. That's how it looks like. Although I said candidates test, but 99% chances these things doesn't maximize or minimize at the terminal point. Because at the terminal point, for example, in this question, if you notice, the terminal value of x, as in the maximum value of x is 50. But at that 50, the y will just become 0. So it doesn't make any sense, like practically it doesn't make any sense. So first derivative test mostly works here. I'm gonna find the derivative, which is 8 over 3 times 50 minus 2x. Equate the derivative to 0, which means that I think only this is equated to 0. So 50 minus 2x is 0, which means that x is 25. And that's about it. 25, anything greater than 25 will make this guy negative. Less than 25 will make it positive. So yes, we do have a maxima at 25. What are they asking? Values of x and y. Great. I have x as 25 over here. And then what is y? Y is just plug in 25 over here. So 200 minus 25 times 4 is 100 over 3. So that's 100 over 3 feet, or what? Feet. Yeah. So these are the dimensions, guys. X is 25 feet and y is 100 over 3 feet. That's our answer. Okay. This is a very popular question asked in various ways, just the language changes and the concept is same. Okay, this one says that a lifeguard stationed on the beach sees a swimmer in trouble 150-meter down the beach and 60 meters out in the water. So this is the swimmer who is in trouble. This is the lifeguard who is and he's seeing this swimmer at 150-meter down and 60 meters into the water, out in the water. The lifeguard can run at 5 meters per second on the beach and swim at 3 meters per second. What path along the shoreline and out into the water should the lifeguard take to reach the swimmer in the shortest amount of time? In other words, they are saying that he ran till some point, then he jumped So find what is that, what x, what distance along the shoreline he should jump so that the time is minimized. So let's say this is x over here, right? So obviously this will be 150 minus x. And using Pythagoras, I can find this one, which is square root of 60 square plus 150 minus x square. Now we need to minimize the time, right? And what is the time? Time is distance over speed. So the function of the time, the function that we are looking for, is the time on the beach plus time in the water. Time in the beach is distance uh, ran on the beach over the speed in the beach. Speed on the beach is 5. Time in the water is distance in the water, which is just the Pythagoras. Of course, it's a gross expression, but we cannot do anything about it. And swim at 3. Fortunately, we already took the variables into consideration such that we don't have anything except x. So all we need to do is differentiate and equate to 0. So f prime will be 1 over 5 plus this will become 1 over 3 is as it is, and this will become 60 square plus 150 minus x square raised to, if we differentiate, then 1 over 2 comes down and the power is negative 1 over 2. We go inside and then derivative of 60 square is 0, and this will be 2 times 150 minus x times minus 1. That's how it looks, right? I've used chain rule. And this should be equated to 0. I'll do that in the next step. So 1 over 5, and then this is 1 over 6, and then this is just 1 over square root of 60 square plus 150 minus x square. And this is, remember, this is negative 2, so negative 2 times 150 minus x. Finally, this can also be written as 1 over 5, and negative 2 times 1 over 6 is negative 1 over 3. So negative 1 over 3, 150 minus x over square root of 60 square plus 150 minus x whole square. Oh my goodness. Okay, equating that guy to 0 now. So I'm gonna get 1 over 5, minus 1 over 3, 150 minus x over square root of 60 square plus 150 minus x square is equal to 0. I hope you understand that I will bring this entire thing on the right side and it will just become positive. So if I just edit this equation, this will just be equal to, I hope you understand. I'm going to cross multiply, so it will look like 3 times square root of 60 square plus 150 minus x whole square is equal to 5 times 150 minus x. Correct. I'll keep solving. This is no calc, so I'll square both the sides. This is 9 times 60 square plus 150 minus x square is equal to 5 square is 25, and this is 150 minus x square. Okay, if I distribute this thing, so it will become 9 times 60 square. These are not smileys, just so you know, these are just imply symbols. Plus 9 times 150 minus x square is equal to 25 times 150 minus x square. Subtract 9 times 150 minus x square both the sides, so this will become 16 times 150 minus x square over here, and this is 9 times 60 square over here. I think we can simplify this a little bit because it looks like this will become 3600, and this is 16, and this is 150 minus x square. I think this can go away with 8, because 8 times 2 is 16, and 8 times 4 is 32, and 8 times 5 is 40, and then 0. And then this can again cross out with 2 times 2 is 4, 2 times 2 is 4, 2 times 5 is 10. So it's 225. Okay, I think that's actually very good for us. You'll understand in a minute, because both of these are perfect squares. I'm just going to write this one on the left side. So 150 minus x whole square is equal to 9 times 225. And if I take square root both the sides, then 150 minus x is equal to square root of 9 and 225. And fortunately, square root of 9 is 3 and square root of 225 is 15. So 150 minus x is this. So 150 minus x is 45. So minus x is negative 105. So x is 105. If you're thinking that when I took the square root over here, I should have taken plus and minus sign. Yes, I should have taken plus and minus sign, but it won't make any practical sense because then the answer would be greater than 150, which does not make any sense. It has to be less than 150. So 105 is the value of x, which is in meters or what? Meters. This is the value, or this is the distance that the swimmer, that the lifeguard has to run on the beach and then jump so that he can reach in the minimum time. Again, you might be wondering that I have not found the sign change of the first derivative, because how do I know this is a minimum? This could be a maximum as well. Yes, you are right, but again, in such questions, they don't go this far that they will make you find the sign chart and all as well. The value that we get is most likely, I'm not saying it is 100%, but most likely it's a safe way to assume. But if you are really want to make sure, then feel free to plug any number of your choice that is less than 105 and greater than 105. Maybe put 1 over here and you can get a number approximately, and then put probably 120 or I don't know, maybe 150 also will work, because 150 will just make it 0. And if you put just 0, in fact, this will make everything this much greater, and it will become negative. So it is going from negative to positive, so it has to be a minima. Okay. And finally, the last question, this is calc active, thank God. So the wall of a building is to be braced by a beam that must pass over a parallel fence 5 feet high and 4 feet from the building. So this means that the fence is 5 feet high. So let's say this is the fence, this is 5 feet high, and this is 4 feet from the building. And let's say this is where the building is over here. Let's say this is the building. And we have to find the length of the shortest beam that can be used. So the beam must glance through, this fence and will look something like that. So this green guy is the beam. So let's connect these things. So it looks like a similar triangle the moment we draw it. That's what we might need to, find over here. So let's figure out that what we need for the length of the shortest beam that can be used. So basically they need the value of the green guy over here, right? Okay, fair enough. So let's call this as X, right? And this building is Y. And I need to find Z over here. But honestly, I can find Z as soon as I have X and Y, because I can use Pythagoras, right? Now, like I said, and like you agreed, I hope, that these are similar triangles. So can we agree that 5 over x, why they are similar, by the way? Because these are 90 and this angle is common. So using AA similarity. So 5 over x is equal to y over not 4, 4 plus x. Be careful. So cross multiply. 5 times 4 plus x is equal to xy, I think. So 20 plus 5x, sorry, 20 plus 5x, yeah, is equal to xy, which means that 20 plus, I don't know why I did all that. I could have, okay, anyway, 20 plus 5x over x is y. So I got that. Now, what is z? Z that we have to optimize. So the function that we are looking for, which is z, is nothing but square root of y square plus x plus 4 square using Pythagoras. And we have y already. So we have that in a single variable, which is 20 plus 5x over x square plus x plus 4 square. So we need to figure out where this derivative is 0 and it changes from positive to negative. That's our, sorry, negative to positive, because we are looking for the shortest beam, and that's our answer. So that's where Desmos comes into action over here. So this is my Desmos over here, and I'm gonna type in the function as it looks on the other screen. First, I'm gonna replace and square root. Right, guys, if you type this in, it is going to look like this. Obviously, you might be wondering that how can x be negative, but don't worry. Zoom out a little, and there you go. You have this function right here, which is minima. So there are two ways actually, guys. If you want to make sure that this is the function and you're finding f prime x, so just hide this and now see that f prime x should be 0 and it should change from negative to positive, right? So there you go. This is the point that you're looking for, where f prime is 0 and f prime changes from negative to positive. So I got the x value, but I need the function's value at this point because I need the length of the ladder or the beam. So f of 4.64 and what was that? 159. So that's what I have. That's what I have. The length of the beam comes out as L is equal to 12.70, and that's the number that we are looking for. So that should be our answer. Also, I hope you guys know that Desmos is now allowed in AP. It's sort of like hybrid. So that's why I've been using Desmos in all my unit review videos. First question is, looks like this is on integral as accumulation. This is very popular in AP, especially in FRQ. Definitely usually the first or second question, whether that's AB or BC, is on this topic. Okay, fx is a function consisting of a line segment and a circle. G be a function that is given by g prime as fx. So they're asking that if g of negative 2 is 0, then what is the value of g of 2? So the way we do this is we integrate, because I need to figure out the value of g and I'm given g prime. So the only way we can do this is, of course, by integrating it, right, on both the sides. So, and the bounds of integral should be from negative 2 to 2, because these are the two numbers I'm interested in. So g prime of x is equal to fx. I'm going to integrate both the sides. So there's a dx here, and the bounds are from negative 2 to 2. I think we already agreed on that. The integration of g prime is just g. I'm just going to continue over here so that we can see the graph. So this will be gx, and remember the bounds are from negative 2 to 2. Now, how will you integrate fx from negative 2 to 2? Area under the curve, right? And remember sine sensitive area. So from negative 2 to 0, that's just a triangle. The area of the triangle will be half times base, which is 2, and the height, which is also 2. But make sure to put a negative sign out in the front because this is below the x-axis. And the remaining guy is the semicircle. The radius is obviously 1 unit, so it will be pi r square divided by 2, because divided by 2, why? Because that's a semicircle. The left side will become g of upper bound minus g of lower bound. This will become boom boom, negative 2 plus pi over 2, I believe. G of 2 is what we need to find. G of negative 2 is, wow, 0, is equal to, let me write pi over 2 first. So pi, or let's keep it like that, negative 2 plus pi over 2. So isn't that the answer? G of 2 should be equal to negative 2 plus pi over 2, which looks like option, what do you call it, B, right? Makes sense? All right. This one is, I think, a pretty straightforward question. Here we have to integrate fx, but it is given that fx is same as g prime x. So first I'm going to replace f with g prime. So g prime x dx from 1 to 3. And what is the integral of g prime? I mean, obviously, integral of any derivative is just that function, because the integration and differentiation are two opposite operations that, sort of nullify each other. But of course, the bounds remain as it is. So it will be gx from 1 to 3, which is nothing but g of 3 minus g of 1. Well, fortunately, we are given what is g of 3 and what is g of 1 over here. So I'm just going to plug that in right here. G of 3 is going to be, I think, 3 square minus 3 times 3 plus 4. I hope you understand. I'm just replacing x by 3 here, and then every x by 1. So it's just 1 minus 3 plus 4. So it's going to be 9 minus sorry, not 6, 9 plus 4 minus, this will become negative 2 plus 4. These are gone. So I'm left with 4 minus 2 is 2. 4 minus 2 is 2 here. Uh, and 4 minus 2 once again is just 2. So 2 is, yes, we have an option, which is option C. All right, great. The next one is on, okay, we are integrating a square root over here. I can definitely use a U sub and do this for you, but I think it would be helpful for you to understand the shortcut that we can apply. Because isn't that almost like a parent function? A parent function as in, how will you, how, had there was no 3x plus 1 here, first off, let's bring it to the top, right? So this will be 3x plus 1 raised to negative 1 over 2 times dx from 0 to 5. What I'm trying to say is, if this was just x raised to negative 1 over 2, then you don't really need any u sub. You know that you can use a power rule, add the power by 1 and divide by the same thing. Likewise, you can do the same thing over here. The why? Because this x is just replaced by another linear function. After all, this is a straight line, right? Mx plus b. The, the only difference is, after you find your answer, just divide it by the coefficient of x. Think about it like that. Had I was differentiating this 3x differentiation will be 3, so 3 will come out. So integral is exactly opposite. You have to divide by 3, right? So I'm just going to do it quickly like that, and then I can show you u sub as well. I don't know if some of you are still confused about this. So you add the power by 1, negative 1 over 2 plus 1 is 1 over 2, and you divide by 1 over 2, and then divide by a 3 as well. So the integral will look like 2 over 3, 3x plus 1 raised to 1 over 2, and then you put the bounds from 0 to 5. Of course, if you are not okay with that, I'm going to use a u sub. So u is equal to 3x plus 1, which means that du will be equal to 3 times dx. And remember, the bounds are going to change. So when x is 0, u will be 1. And when x is 5, then u will be 16. So this is going to be 1 to 16, 1 over square root of u, and dx is just from here, if you understand, it's du over 3, right? Because I divide both sides by 3. So this is du over 3. You see that? Over 3, that's what we got from the shortcut. So I'm going to take that 1 over 3 out, and this will be u to the negative 1 over 2 du integration from 1 to 16 over here. So this will become u to the 1 over 2 over 1 over 2 when we integrate from 1 to 16. Over 1 over 2, the 2 is going to jump up using keep change flip. So it will look like 1 over 3 times 2 root u from 1 to 16. So this will become 2 over 3 root 16 minus square root of 1. Square root of 16 is 4. 4 minus 1 is 3. 3 and 3 is gone. So I'm just left with 2 over here. So that should be our final answer. Is that in the options? Yes, we do have that in the options, which is option D. So now you know both the methods. Of course, I prefer the red one. It's fast, saves time. But if you're still confused, of course, you have the blue one. Okay. What is the sum of all values of k that satisfy this? So yes, integration rules here, power rule, I think, but with some algebra also doodling around. So what is the integral of this x? Isn't that just x square over 2? Or maybe I want to rewrite this because I don't like this x square at the bottom. So this can be written as x to the negative 2 dx, and this can be integrated from 1 to 2k, and that should give me 15. Integration of x is x square over 2, and integration of x to the minus 1 is x to the minus 1 over minus 1 from 1 to 2k, and this is 15, or this should give me 15. So this will be x square over 2, double negative is positive, and x at the bottom, and this is going from 1 to 2k, and that should be equal to 15. So if I put the upper bound, this will be 2k whole square over 2 plus k over 2k. That's how the upper bound looks like. And the lower bound will be 1 over 2 because 1 square is 1. and k over 1. So there is no need to write k over 1. I mean, I can write it, but you understand there is no need to write over 1. Okay, this will become 4k square over 2, and this will just become 1 over 2 because k is gone. If I distribute negative, that's how it looks like, and this is equal to 15. Okay, these two are gone. 4k square over 2 is 2k square. So 2k square minus k minus 15 is equal to 0. I think this can be factored minus 6k plus 5k, if I'm not wrong. Minus 15 is equal to 0. This is 2k, k minus 3 plus 5, k minus 3. Great. So I'm not explaining this. I hope you understand. It's just algebra 2 stuff. So I have two values of k. One is negative 5 over 2 and one is 3. They are interested in what will we get if we add these two numbers. So 3 negative 5 over 2 plus 3 is nothing but negative 5 plus 6 divided by 2 if we take the common denominator, which is just 1 over 2. Yes, we do have that in the options. So option B, 1 over 2 is the correct choice. Right. Okay, this is important, guys, because this is the integration of absolute value. And the way we do this is using graphs, because otherwise this becomes slightly complicated if you do not want to use the graph. So this is a classic question of integration as an accumulation. The way I hope you know the absolute value of x curve is just a v curve at the v at the origin like this. And the only difference is whenever you have some other stuff instead of x, just find that where exactly is this thing 0 to find the corner point. Obviously, if you want to make x plus 1 0, x should be negative 1, which means that the graph is making a corner at negative 1 like this, and it is going to look like this, right? It's going to look like this. Now, they want us to integrate from negative 2 to 5. So negative 2 is somewhere here, and 5 is probably, I don't know, somewhere over here. We know that integration is the area under the curve. So all we have to do is find what is the y coordinate at negative 2. It's pretty easy. I'll just put x as negative 2 over here. So absolute value of x plus 1 when x is negative 2, I will get absolute value of negative 1, which is 1. So this is going to return me negative 2 comma 1 as the height. And at 5, I'm going to get absolute value of 5 plus 1, which is 6. So 6 is probably somewhere here. Okay, area under the curve is just what? Area of this guy and the other guy. So of this guy, the area is, both are triangles, of course. So the area formula is pretty straightforward. So for the left piece, the area is going to be half base. Base is 1 unit, and height is also 1 unit. So it's just 1/2 A1, and A2 is going to be half base. Be careful, this is 6 units, and height is 6 units as well. So this is, I think, 18, right? Yeah. So the total area is 18 plus, well, half is 0.5, so 18.5. Yeah, makes sense. Should be 18.5, which is option C. Okay. What is F? Okay, very important question, guys. This is on FTC 1. Very important. Definitely expect a couple of MCQs, maybe some part in FRQ as well in your AP Calc exam. The way this works is f prime x will be f of upper bound. F of upper bound means just notice what the function is and replace its variable with the upper bound, right? So the upper bound is just x square. So replace every t, well, we just have t at one position over here, with x square. Then multiply it by the derivative of the top. Derivative of the top is x square, derivative is 2x. Minus, put the, although I don't need to write that, if you know this, that's going to just become 0, but I'll still show it to you for those who don't remember. Minus, you put the lower bound again instead of the t variable in this case, so it will become 1 plus 3 times you differentiate the bottom variable. So bottom one is not even a variable, right? The bottom guy, derivative of 1 is just 0 because that's a constant. And that's why this latter half is just 0. So the answer is 2x multiplied by square root of x squared plus 3. It's straightforward, yes, but very important. This is extremely important. So in our case, the answer is, yeah, option C, right? Option C makes perfect sense. Okay. This is based on, we have to find what is the integral of that if this integral is k. This is based on u sub. It's a pretty decent question because this x cube is, see, why I know this is u sub is because I need something like the bottom one so that I can use this in the first place. That's how I can convert the answers in terms of k, right? And the bottom one is in terms of a single variable, which is t. Now, it doesn't really matter whether that's t or u or anything. It should be a single variable, not really single variable with a single power, not really x cube or something. So I noticed that if I take x cube as u, its derivative will have an x square. And yes, I have x square outside as well. That can, so you know, the u sub can help me. That's why I thought it's a u sub. So I'm going to take u as x cube, which makes du as 3x squared dx. And this is perfect because 3x squared dx is sitting right here. But mind it, there will be some, what do you call it as, bound changes as well. The lower bound x equal to 0 will be same, but the upper bound x equal to 2 will become 2 cube, which is 8. So this question turns into 0 to 8, and f of x cube is just f of u because x cube is u, and the remaining thing is du. And isn't this same as this? Because again, it doesn't really matter what the variable is, whether variable is u or t or anything, this integral will still be same. So since these two are same, variable is irrelevant, the answer is still k, which is option D. All right. Once again, I think you notice that this is a clear case of FTC1 because it is integrated in terms of a variable and the bounds are some other variable. So f prime x is f of upper bound. So every t is replaced by 2x. Let's do that. Multiplied by the derivative of 2x, which is 2, minus is just 0. I hope you understand now. Same as the earlier question. So since this is a constant, it comes out to be 0. This will be square root of 4x square minus 2x times 2. They need the f prime at 2. So I will just replace x by 2. So this will be square root of 2 squared is 4. 4 times 4 is 16. And 2 times 2 is 4 times 2. This will become square root of 12 times 2, or 2 times square root of 12, and I don't even need to simplify this further because I can see one option that is exactly same as what I got. So this should be our answer, option E. All right, excellent. This one says that there is a graph of fx that consists of 4 lines. Okay, you can see that. And G is this. So use this graph to find the parts A to A. What is G0? Okay, so I think G0 is just you replace x by 0 over here. So let's find out. G0 will be equal to negative 4 to 0 ft dt. And negative 4 to 0 of a function whose graph is given is just the area under the curve from negative 4 to 0. So negative 4 is here, 0 is here. Let's find the area under the curve. I think these are just two triangles the way I see it. What is the area of this triangle? It is going to be half. Let's write it on another line. Half. Base is 3 units and the height is 2 units. And be careful, the other area will be minus because it is below the x-axis. Half, base is 1 and height is 2. So 2, 2 gone, 2, 2 gone, and 3 minus 1 is 2. So this answer is just 2. So it should be third option over here. Sorry, why will I mark 3? Should be option 2, right? Yeah, option 2, that should be our answer. What is the equation of the tangent line to G when x is 3? Oh, that's interesting. So for that, I need to find two things. One is the point, one is the slope, right? Let's find the point first. So for the y coordinate, I need to find g3. So g3 would mean that you replace this x by 3 over here, which was earlier replaced by 0. So negative 4 to 3 of ft dt. No need to find that negative 4 to 0 because you already have that area. So you can break it down like negative 4 to 0 and then from 0 to 3 of ft dt. So this is already 2. The first thing is already 2 as we found in question number A. So this is 2. And 0 to 3 is right here, 0 to 3. So it looks like one rectangle or a square and one triangle. So for this square, the area will be obviously 2 times 2 is 4, but keep in mind it is minus 4. And this will be half times base is 1 and height is 2. So it will be minus 1, minus 4, minus 1, which is minus 5 over here. So this is minus 5, and 2 minus 5 is negative 3. But this is just the point, guys, remember. So the point is 3 comma negative 3. Now for slope, I need to differentiate g, right? So again, we have to use the FTC1. So g prime x will be equal to f of upper bound, derivative of upper bound, so derivative of x is 1, minus 0 because this is a constant, so there is no need to write that. I'm looking for g prime 3, so g prime 3 is f3, which is, well, 0. Well, that's interesting because this is the graph of fx and f3 is 0. So, well, that makes things easy. So my answer will be y minus y1 equal to 0 times x minus 3. So y plus 3 is equal to 0. So y is equal to negative 3. Yes, which is in the options. So it should be the last one. And finally, which of the following statements is false for G? G has a relative minima, maxima, decreasing, increasing, and all that. Okay. For this one, we need to first find G prime x, which we already have. Earlier, we found that G prime x should be same as fx. So for relative maxima or minima, obviously we have to make sure that G prime is either 0 or undefined at these points. So let's find let's find what is f of negative 1, what is f of 3, and what is f of negative 2, because these should be what do you call it as? So these should all give me 0 or undefined, right? So negative 1 is yes, giving me 0. F of negative 1 is 0. F of 3 is also 0. But f of negative 2 is not really giving me 0 in the first place, right? So g prime negative 2 is g prime negative 2 is f of negative 2, which is not 0. So if it is not 0, how can it be a relative extrema in the first place? So they are asking what is false. No need to check the other options. It should be option 3. This should be the false option. Right. Use this graph to answer the following. So we have to find what is f of minus 2. It's sort of similar to the previous question, maybe a little bit more funky. So f of minus 2 is just replacing every x with minus 2. So minus 2 square plus negative 2 to negative 2 of gt dt. Negative 2 square is 4, and I think we know this from the properties of definite integral, that if the lower bound and upper bounds are same, the answer is 0, because basically you're not, tracing any area. So it's 4, and which should be, yeah, we do have that in the option, so that's our answer. F prime negative 2. Okay, what is f prime? So from here, I'm going to find f prime, which is 2x. And I hope you know this. This is now FTC1, so that's just g of x. They're asking f prime negative 2. So f prime negative 2 is f prime of negative 2 is 2 times negative 2 plus g of negative 2. And this is negative 4 plus, what is g of negative 2? This graph is of g, so at negative 2 it is, there you go, At negative 2, the value is negative 2. So negative 4 minus 2 is negative 6. And yes, indeed, we do have that in the options. It should be option 1. And f double prime f double prime 2, not negative 2, f double prime 2. So we'll just borrow this guy, f prime, from here and ram this once again. So differentiate it. F double prime x will be 2x is 2 and gx will be g prime x. They are looking for f double prime 2, which is 2 plus g prime 2. And what is g prime 2 if you look at it carefully? This is g, and obviously derivative is the slope at that point, which is a horizontal tangent line. So the slope is just 0. So it is 2 plus 0, which is just 2. Do we have that in the options? Yes, we do. So that should be option 4. Okay. If this is this, what is f prime? Once again, another question on FTC1. I hope you know how to do these things now. So f prime x will be, I'm happy that denominator is, sorry, not denominator, the lower bound is once again a constant. So it's, the second half is just 0. So it'll be 1 plus sine x square times derivative of sine is cosine of x minus 0. And that's about it. I'll just write cosine x first. And this is square root of 1 plus sine square x, which, yeah, option D. Right, option D makes sense. Okay. What is the value of g of 2? Okay. This is, in a way, I picked this question because sometimes you don't recognize that this is also FTC1. Because d over dx is, after all, finding the derivative of that thing, right? So this is the FTC once again, FTC1. So gx will be equal to 3 plus, you replace the upper bound, sorry, the variable with the upper bound. So variable is t square, t is replaced by x square. So remember, x square square. I hope you understand what I did here. Again, I'm repeating, I replace this t with x square, and the square of the question is as it is. But we are not done yet. Times derivative of x square, which is 2x, and that's it, because we subtract 0 from here because the denominator is a constant. So g is simplified as 3 plus 2x times 1 plus x to the 4, and I just replace x by 2. So g of 2 will be 3 plus 2 times 2, 1 plus 2 to the 4. This will be 3 plus 4 times 1 plus 16. 68, I think, 70, 71. So that should be our answer, yes, which is option E. That should be it, yeah. Right. Over here, we have to integrate this and figure out what the value of k is. Although we did a similar question, something similar to this. So the integration of 2x is, the 2 is just 2, and x is x squared over 2. Integration of k is just, kx. I hope you understand, because k is a constant. So just like integration of 1 is x plus c, likewise integration of k is this, k just remains as it is. It's kx plus c. So this is from 2 to 6, right? And this should be equal to 8. This 2 is gone. Upper bound 6 square is 36 plus 6k, minus with the lower bound 2 square is 4 plus 2k. That should be equal to 8. So 36 plus 6k minus 4 minus 2k is equal to 8. 36 minus 4 is 32. 6k minus 2k is 4k is equal to 8. Subtract both sides by 32. So I think that's what, negative 24. And divide by 4. 4 times negative 6 is negative 24. So yeah, negative 6, option A. Guys, that's what I'm getting. Option A should be our correct choice. Okay. This is a pretty interesting question. No, you do not have to integrate this entire gross thing, because notice carefully, if you remember the even odd functions property, all these with odd powers are odd functions. And when odd functions are integrated from negative a to a, to remind the memories, negative a to a fx dx is if fx is an odd function, is just 0. So these two are just gone because they are just, 0. You're just left with -4. So this question is essentially integrate -4 from -8 to 8. So -4 comes out, it's a constant, integrate from -8 to 8 of dx, and integration of dx is basically, 1 dx, and integration of 1 is just x from -8 to 8. So it will be -4 times upper bound minus lower bound. So it will be -4 times 16, which is -64. So option C is the best choice. Okay, over here we need to figure out, although this is a similar question as to what we did, but there's a reason why I picked this one. We need to find g of -1. So g of -1 will be from 0 to -1. And now you see the weirdness here. The lower bound is higher than the upper bound, right? So usually students mess these up with a sign. So we should understand that in order to write this in the usual notation, you swap the bounds, -1 to 0 ft dt, and you put an extra negative sign out in the front. And now it becomes a regular question. -1 to 0 ft dt is what? -1 to 0 is basically the area under the curve of this portion, right? So that's just negative remains as it is. And since this area is below the x-axis, another negative, half times base times height. So the answer is 1 over 2 and not -1 over 2. Well, that's the only thing, only probably catch here that we have to, take care into account. So that should be our answer. And the others should be straightforward because they are asking g prime now. So g prime, I think you very well know, g prime of x will just be f of x. So they are asking g prime of -1, sorry, -1 is just f of -1, and f of -1 is just -1, right? F of -1 is just -1. So this is -1 right over here. Okay. And then I have g double prime -1. So g double prime is just, I differentiate this once again. So g double prime x will be equal to f prime x. So g double prime -1 is just f prime -1. And f prime -1 is, what is the derivative of this function at this point? Well, derivative is just the slope. And we can see that this is the slope of this line is rise over run. There is a rise of, there is a rise of 2 units and there is a run of 2 units. 2 over 2 is just 1. So that's just 1. That's our answer. Right. Here we are given if gx is the integration of secant tangent and g of pi over 4 is this, then what is g of pi over 3? Coming on to trig rules here, guys. I hope you remember what is the integration of secant tan. If you do not, then it is secant. You can think about it in the other way, that when you differentiate secant, you get secant times tangent. So if you reverse engineer, you will end up with secant. So gx is secant x, not just that, plus c, because this is not a definite integral. And that's why they gave this piece of information so we can figure out what c is. So I'm going to put g of pi over 4, which is secant of pi over 4 plus c. G of pi over 4 is -4. Secant pi over 4 is root 2 plus c. So -4 minus root 2 is c. This I'm going to sub in over here. So I'm going to get my gx as secant x plus, not plus, c is -4 minus root 2. They're asking what g of pi over 3 is. So that will be secant of pi over 3 -4 minus root 2. Secant of pi over 3, what is cos of pi over 3? Pi over 3 is 60 degrees. Cos 60 is 1 over 2. So secant 60 degrees is 2. So 2 minus 4 minus root 2 and 2 minus 4 is -2. So it will be -2 minus root 2. That should be our answer, which is option C. That adds up. All right. Okay, integral. No one likes this thing, but yes, we have one question so that you can, this will rejig your memories. Right, so the way this works is this is a Riemann sum, and the way we convert a Riemann sum into a definite integral is the general structure is limit n approaching infinity, summation of i's from 1 to n, f of a plus delta x multiplied by I times delta x. That's how it looks over here. One parentheses is missing, guys. There should be a big parentheses over here so that there's no confusion. Okay, this should be the complete question. Where delta x is given by b minus a over n. Obviously, what is b, what is a, you will come to know, because this is equal to a to b fx dx. That's how it works. So the best way to answer this question is to reverse engineer. We can see what b and a are. So b minus a over n, that should be the delta x, which should be sitting right outside, which is over here. In other words, b minus a should be 6. So what is 11 minus 5? 6. 6 minus 5, 1. 11 minus 6, 5. 6 minus 0, 6. So that only eliminates, this thing only eliminates b and c. Now, look at the function. What will make sense? Now, what is a? The question is a 0 or is a 5? I think 5 makes sense because look at the inside. It should be a plus delta x times I. And this is a plus delta x, a plus delta x, and this is just a constant. So constant doesn't have any x to replace. So obviously the lower bound should be 5. So that should be our answer. Okay. Okay, evaluate this integral. So usually this is easy, but it still trips students up. All we have to do is distribute that. In other words, give this denominator to all these people separately so that we can apply the power rule here. In other words, write it like this: 6x cubed over x square minus x over x square dx, and you integrate and then reduce the power. So this is 3x squared minus 6x minus 1 over x dx, and then just apply the rules here. 3 is as it is, x squared is x cubed over 3. 6 is as it is x squared over 2, and 1 over x is ln absolute value of x. Don't forget plus c. So the answer will be x cubed, 3 and 3 is gone. 6 over 2 is 3, 3x squared minus ln absolute value x plus c, which looks like option D. No, minus, yeah, option C. That should be our correct choice. Okay, pretty good question. This is a U sub because there's no power rule or anything here. And whenever I see ln x, most likely it has to be some other integration techniques. And in AB, there are not many integration techniques. So this is a U sub because I can see 1 over x sitting here, which is basically the derivative of ln. So I'm going to take U as ln x. So du is going to be 1 over x dx. And if we rewrite this as 1 over x times 1 over ln x dx. So you see this 1 over x dx, that's just a du, and you see this ln x, which is 1 over u. So 1 over u integration is ln absolute value of u plus c. And what is u? That's just ln x. So it's ln of absolute value ln x plus c, which has to be option B over here. That's the answer. Okay. Evaluate this. So what is the integration of cot? Well, that is the only question. Cot is negative. Sorry. Okay. I was about to write negative cosecant square x, but that's not right because that is the derivative of cot, not the integration. So the integration of cot is ln of absolute value of sine x. So unfortunately, guys, you have to memorize these things from pi over 6 to pi over 4. So it will be ln of absolute value of sine of pi over 4 minus ln of absolute value of sine of pi over 6. Sine of pi over 4 is root 2 over 2. and sine of pi over 6 is 1 over 2. So this can be ln a minus ln b is ln a over b. I hope you remember the properties. So ln a over b. I'm going to use keep change flips. So keep change and 1 over 2 is flipped. 2 is gone. So I'm left with ln root 2, and that should be our answer, which has to be option A. All right. If f prime is this and f0 is ln 21, then what is fx? So this is sort of like a differential equation, not exactly, there's a separate unit for it. But in a way, f prime x is given as 1 over x plus 3. And to go from f prime to f, I need to find the antiderivative of it. So I integrate both the sides here. So f prime x dx integration will be equal to 1 over x plus 3 dx integration. Integration of f prime x is fx. 1 over x plus 3, obviously you understand is the same as 1 over x parent. So what, ln, right? Ln x plus 3, absolute value of x plus 3 plus c. I'm given an initial value to find c. So replacing x by 0. So f0 is equal to ln of absolute value of 3 plus c. f0 is ln 21. So ln 21 is equal to ln 3 plus c. So ln 21 minus ln 3 is c, and ln a minus ln b is ln a over b. So ln of a over b is c, which means that c is ln 7. 3 7s are 21. Let's plug that back in over here. So our function becomes ln absolute value of x plus 3 plus ln 7, I think, right? So that should be our answer, which I don't see anywhere in the options, but yes, they're actually playing with us because they have again used a log property, because log a plus log b is log of a times b. And a positive number can very easily go inside an absolute value. So it will be ln of absolute value of 7x distributed. So it will be 7x plus 21. That should be the function, which, yes, it is option A. Okay. Evaluate this. So this again looks like a u sub in this case, although this is a definite integral, but it doesn't really change the approach. So u is going to be ln x. So du will be 1 over x dx. So this 1 over x dx I can just see over here. This is replaced by du. Ln x will be u. But be careful, the bounds will no longer be the same because this is a u sub. I'm going to replace x by 1 because that's the lower bound. So u will be ln 1, ln 1. And what is ln 1? 0. And then x is e. So u will be ln e. And what is ln e? That's just 1. So now over here, I think I will have integration of u du from, what was that? I think 0 to 1, right? 0 to 1. So integration of u is u square over 2 from 0 to 1. Upper bound is 1 square, which is 1, and over 2 remains as it is, and minus the lower bound is 0. So the answer is just 1 over 2. Yes, 1 over 2 is in the option, so it should be option C. Okay. The next one is evaluate x tan of x squared dx. So of course, had this was just tan x, I do have a formula, but these are some funky stuff going on here. Classic u sub, where u is going to be x squared. So if I find du, it will be 2x dx. And I do see x dx in the question. So I'm just going to divide both sides by 2. So that it will be half du is x dx. So if I rewrite this question, let's write tan of x square first and then x dx. The reason is so that you can easily see this x dx is now replaced with half du. So half du. And x square is anyway u. So tan of u. 1 over 2 is thrown outside. So 1 over 2 integration of tan of u du. And the integration of tan is negative natural log of absolute value of cosine x. That's just a formula, guys. You have to memorize these formulas, plus c over here. So the final answer will be -1/2 ln of, sorry, this will no longer be, made a mistake here, x, this will be u because that is in the u word. And in the final step, -1/2 ln absolute value of cos of u will be replaced by x squared. So it will be x squared over here and plus c. So that should be our final answer. There are no options here, but yeah, this is our answer. Okay, all right. We have to integrate sine of 4x dx. So again, the integration of sine is minus cos, of course. So minus of cos of 4x. But since there is a 4 over here as the coefficient of x, you have to nullify that effect by dividing by 4, on the outside. If you again do not understand this, just like the earlier question, I think in the first 5 questions, I used a u sub. You can do that, but honestly, that's a bit of an overkill. You should be used to applying such shortcuts over here. And the bounds are from pi over 4 to negative pi over 2. -1 over 4 sits outside, and I put the upper bound, which is minus pi over 2. So it's 4 times minus pi over 2 minus cos of lower bound, which is 4 times pi over 4. So this is -1 over 4 cos of -2 pi minus cos of pi. Cos of -2 pi, remember cos is an even function, so it has nothing to do with, even if the negative sign is sitting outside, just digests it. So it's cos 2 pi minus cos pi. Cos 2 pi is 1 and cos pi is -1. No calculators allowed. I hope you remember your unit circle stuff. So this will be -1 over 4, 1 plus 1, which is going to be 2 over 4, -2 over 4, which is -1/2. That should be our final answer. Right, a decent question. Let's try the next one. All right, guys, this is a good question because this is based on something called uh, uh, a U sub, of course. Why is this a good question? Because sometimes it is difficult to see what the U is. So there are two possible U from this question. One is tan, because the derivative of tan is secant square x dx. And one is secant, because derivative of secant is secant x tangent x dx. So you can strip out one secant from here and take that as u, which is totally fine, but I'm not going to do that. I'm just going to do what looks like a straightforward u, which is tan of 2x. So du is going to be derivative of tan as secant square 2x, and derivative of this 2x is 2, so 2 comes outside. Divide both sides by 2, so 1 over 2 du is secant square 2x. Okay, the bounds are definitely going to change. So the initial x is 0, so u will become tan of 0, which is also 0. And the upper bound is pi over 8, so u is tan of 2 times pi over 8. 2 times pi over 8 is pi over 8 is pi over 4, tan of pi over 4 is 1, so upper bound is 1. So the integration looks like 0 to 1, tan of 2x is u, and secant square 2x dx is, oh, I missed a dx over here. There's a dx here, and yeah, that should be replaced by 1/2 du. So 1/2 du. Okay, just gonna take 1/2 out, so integration of u is what we are left with. Integration of u is u square over 2, which is from 0 to 1. So this will be 1 over 4, upper bound 1, lower bound 0. So the answer is just 1 over 4. That's our final answer for this one. Okay. These are pretty decent questions, guys. These are based on the properties of definite integral. We are given a bunch of information over here, and the first question is, what is the integration from 0 to 4 of 3 times fx dx? First, I think I'm just going to take 3 out. So 3 times integration of 0 to 4 from fx dx. Now, although I do not know what is the integration from 0 to 4, but I know 0 to 2 and
2 to 4. So this can be written as 3 times, I can integrate this from 0 to 2 first, fx dx, and then integrate from 2 to 4 fx dx, which is basically the same thing. So it's going to look like 3 times 0 to 2 integration is just 2, and 2 to 4 integration is 7. And 7 plus 2 is 9. 9 times 3 is 27. So our answer for part A is 27. Okay. Then we have 0 to 1 of fx dx. Once again, I do not have 0 to 1, but what I do have is 0 to 2 and 1 to 2. So obviously it makes sense that 0 to 1 integration is same as you integrate 0 to 2 fx dx, and then you subtract it from 1 to 2 fx dx. So you're going to get from obviously 0 to 1. So that's 2 minus minus 1. Be careful with the double negative. So the answer will be 3. The next is 0 to 1 x dx. Well, I don't really know what this has to do with the, okay, there is a typo, of course, in the question. This is not x plus 1. This is f of x plus 1. So please make sure you have that correction. Okay, so f of x plus 1, I don't really have f of x plus 1. I have all these people as fx. So fx or gx. So I have to do a u sub, of course, because I do not need x plus 1 here. I just need a single variable. So I'm going to take u as x plus 1. So obviously du is just dx. But remember, the bounds are going to change. When the lower bound is 0, x is 0, u will become 0 plus 1, which is, of course, just 1. And when I have the upper bound as 1, the u will become 2. So the integration will be from 1 to 2 f of u du. And the benefit of doing this is I do have 1 to 2, right? There you go. 1 to 2 fx dx, isn't that minus 1? I mean, I can go back to the question. You can have a look at it. 1 to 2, there you go. Now, I already told you it doesn't really matter whether the variable is x or u or t or z or anything. The idea is the structure is same. So 1 to 2 integration is negative 1. And yes, 1 to 2 integration is indeed negative 1. That's what I have here. So that should be our final answer. And finally, we have this thing. So first I'm going to distribute. So this is going to look like 2 comes out, 0 to 2 integration of fx dx, and 1/5 comes out, 0 to 2 integration of gx dx. Okay, now what is the integration of f from 0 to 2? I think I have this number, 0 to 2, 0, yeah, there you go, 0 to 2, there you go. 0 to 2 is just 2, so there you go, this thing is just 2. Minus 1/5, and I think this number is also given from 0 to 2 of g, there you go. 0 to 2 of g is negative 5, so I'm going to put negative 5 over here. Negative 5, so this will look like 4 plus 1 if you agree, because 1 over 5 and 5 is gone, and minus of minus 1 is plus 1, and 4 plus 1 is just 5, so that should be our final answer. Okay, pretty good question, time taking, but yes, important. This is based on even odd functions over here. So we are given that we have to find what is negative 3 to 3 of f of 3x. Same idea, guys. I do not really know what is the value of, I do not have any information in terms of f of 3x, so I have to do a u sub once again. So if u is 3x, du is going to be 3 times dx, or 1/3 du will be dx. Yes, the bounds are going to change. So the initial bound of u will become at x equal to minus 3. This will become minus 9. And the upper bound will become, that's not right u here. The lower bound will become minus 9. You understand? An upper bound, if I put 3, will just become 9. So the question boils down to negative 9 to 9. F of 3x can be written as now f of u, and dx is 1/3 du. So this will look like 1/3 negative 9 to 9 of f of u du. And remember, f is an even function. So for even function, the idea is negative a to a integration of an even function is 2 times integration from 0 to a. And in this case, of course, our a is 9 of f u du. So this will be 2 over 3 and 0 to 9. Bingo, we do have that. Once again, I hope you are not confused because the variable is different. That's irrelevant. The structure matters. So this is just 12. And 3 times 4 is 12 and 4 times 2 is 8. So the answer is 8 over here. Likewise, I'm going to try the other one as well. Same idea, guys, literally. I have to do u as 1 over 3x. So du will be 1 over 3 dx. So 3 du is dx. Bounds will change. When x is negative 3, u will become negative 3 over 3, which is negative 1. And when x is 3, u will become 1. So this is going to look like negative 1 to 1 f of u, and dx will become 3 du. So 3 du. So this will look like 3 times integration from negative 1 to 1 f of u du. And once again, f is an even function, so this can be written as 2 times integration from 0 to 1 of fu du. Unfortunately, I have 0 to 1 integration of fx, which is just 4 over here. So I'm just going to replace that thing by 4. So answer is 3 times 2 times 4, which is 24, right? This is 24, so that should be our final answer. And find finally negative 9 to 9 fx dx is f is odd. Big 0. The answer is big 0 because negative 9 to 9, that's just a formula that if negative a to a of fx dx, if f is odd, the answer is 0. All right. All right, guys, question number 28 is on the trapezoidal, Riemann sum, and all those guys. So, concert tickets for a Taylor Swift concert went on sale, alight, t equals 0, and was sold out within 7 hours. You can see that for some time we are given the number of people who are waiting in the line and the rate at which the number of people are changing per hour. You have to use a trapezoidal term with three subintervals to estimate this. Okay, so 0 to 4, clearly 3 subintervals will be the first interval is 0 to 2, then 2 to 3, and then 3 to 4 over here. The way trapezoidal sum works is the area of trapezium is half of the L1 or L0 plus L2, that's how we say it, L0 plus L2, because this is the like sum of two parallel lines, times the width, which is just the distance between 0 and 2, which is just obviously 2 units. Likewise, 1/2 next will be L2 plus L3 multiplied by the width, which is, this is 2 units, this is 1 unit, so 1 unit. And then 1/2 once again L3 plus L4 multiplied by 1 units. So this will be 1/2 L0 is 120, this is 156 multiplied by 2 plus 1/2, this is 156 plus 176, and this is 1/2 176 plus 124 over here. So this comes out as, the calc is active here, by the way, guys, the calc is active. So if I use calculator, I am going to get 592. So that should be our answer over here. Okay, then we have used the right-hand Riemann sum with 4 subintervals to estimate 0 to 7 of L prime t dt and explain what this value means in the context of the problem. So we do have L prime t over here, and this is a right-hand Riemann sum, guys. Right-hand Riemann sum would mean that I will start from 4 subintervals. So the points that I have to take, I start from the right side, and these are the 4 points that I'm looking for. So right-hand Riemann is basically, you know very well that it's area of rectangle, right? So the first width is going to be, the width are already written over here. I'll just add the last width, which is 3 units. So for this one, the first width is 2 units multiplied by f of, sorry, not f of 2, L prime of 2. That's what we are looking for because this is L prime. Then it will be 1 unit times L of L prime of 3, then we have 1 unit times L prime of 4, and then we have 3 units times L prime of 7. That's how it works. I hope you understand, because we have to take these 4 respective positions for right and Riemann sum. We have all the numbers over here, so I'm just gonna sub in 22 here, 28 over here, negative 32 over here, and negative 16 over here. And if I do all that, I'm gonna get negative 8. So they are interested in explain what this means in the context of the problem. Since we are integrating people per hour in a way using Riemann sum, so we will get people. So negative 8 people would mean that they started with 120 people, right? The line started with 120 people, and at the end of 7 hours, there are 8 less people. So we can say that at t equal to 7 hours, people waiting in line are 120 minus 8, which is 112. 112 people are waiting in the line. That's how it works. And finally, the last one is, if L prime is strictly decreasing and concave up in 0 to 3, would a right and Riemann over approximate or under approximate, or overestimate or underestimate this thing? So remember that Riemann has nothing to do with concavity and everything to do with increasing or decreasing. If the function is increasing in nature, then left and Riemann sum is an underestimation, you should know that, and right and Riemann sum will be an overestimation. So since this is an increasing function and we are looking for the right and Riemann sum, this is clearly an overestimation from 0 to 3 of L prime t dt. That's how it works here. Right, integrate the following. So now we are coming to the other integration techniques. For example, this one is inverse. And to be very precise, this is inverse tan. But the only thing is I'm not really comfortable with this. First off, I want to see x term or x square term first. So this is 1 over 9x squared plus 2 dx. Now I'm not comfortable with this 9 because the formula that I have is x squared plus a square kind of. So I'm just going to take this 9 as a factor. So I'm left with x squared plus 2 over 9 dx, and obviously 1 over 9 is thrown outside the integral. And this can now be written as 1 over x squared plus a square. So a square can be square root of 2 over 9 square, right? And the formula that we are looking for is integration of 1 over x squared plus a squared dx is 1 over a tan inverse x over a plus c. That's the formula. So clearly just be careful. There are too many moving pieces here. So 1 over a, and a is this one. A is the square root of 2 over 9. Tan inverse x over a is root of 2 over 9 plus c. That's what we are looking at. Of course, we can simplify this. So 1 over 9, this can be keep change flip, so it will become root of 9 over 2. And once again, this will be keep change flip, so root of 9 over 2x plus c. And what is square root of 9? Isn't that 3? So 3 over square root of 2, tan inverse 3 over square root of 2x plus c. And finally, 3 times 3 is 9. So 1 over 3 square root of 2 tan inverse 3x over square root of 2 plus c. That should be our final answer. I hope this one makes sense. Right. The next one that we have here is this one. So this is also a trick, but not as straightforward. Pretty interesting question. First, I'm going to split this up in two integrals. So this denominator root of 4 minus x squared is given to x and written as the first integral, plus 2 over root of 4 minus x squared is written as the second integral. This 2 can be thrown outside, so integration of 2 times integration of 2 square minus x square dx, and this is just x over square root of 4 minus x square dx. So this is basically two questions, right? And I'm not sure if you're able to recognize this, but this is a sine inverse x situation, because integration of 1 over square root of a square minus x square dx is sine inverse x over a plus c. It's not, guys, I have seen some of my students making this mistake, that they write 1 over a sine inverse x over a plus c. No, it's not. The 1 over a is with tan inverse, and excuse me, and secant inverse, not with sine. So for this one, I do have the integration ready. It's sine inverse x, which is x, over a. Remember that a is obviously 2 in this case, because 4 is written as 2 square and a square, so a is 2, plus of course c. The question is how to integrate this one. And that, my dear friends, is u sub. So I'm just going to do that separately over here. X over square. So I'm going to take u as 4 minus x square. So du will become negative 2x dx. So dividing both sides by negative 2, I have negative 1 over 2 du is x dx. And now if we look at it carefully, x dx is what? Negative 1 half du. And 4 minus x square is u, so square root of u over here. So it will be negative 1 over 2, 1 over root u can be written as u raised to negative 1 over 2 du, and this will become 2 sine inverse, it's just as it is, I'm just rewriting it. And how do you integrate this one? That's just add 1 to the power, so it will become 1 over 2, and divide by the power, and then everything else is as it is. 2 da, 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 da. This 2 jumps up, so it will become negative 1 over 2 times square root of u plus, oh my god, I'm tired of writing this again and again. Okay, finally these two are gone, and I'm just gonna put the u now. And what was our u? 4 minus x square, as we can see. So final answer is this plus this plus, most important guy, c plus c over here. So that should be our final answer, guys. I hope you understand this question and maybe like this question as well. Pretty decent one. Okay. The next one that we have is this. So this is based on the concept of completing the square. Yes, that is a part of AB. I'm not sure if your teacher has covered it, but yeah, this is a slightly tricky one where you have to convert this guy into a perfect square. So probably your knowledge of SAT is going to help you if you still have it. So the first step of converting, I can obviously do it separately. So first step of converting a quadratic into a perfect square is to make the leading term 1, leading coefficient 1. So that I'm going to make by taking 2 as a factor. So x square plus 2x plus 2 over here. And then the next step is you locate the coefficient of x, which is 2 in this case, divide 2 by 2, which is 1, and add the square of 1 and subtract the square of 1. So 1 square and minus 1 square. That's a procedure, right? That's a procedure. And once you do that, the first 3 terms are going to convert into the perfect square. So this will be x plus 1 whole square, and obviously minus 1 plus 2 is just plus 1 over here. So now our question becomes 1 over 2 times x plus 1 square plus 1 dx. 2 can be thrown outside, so 1 over 2 integration of 1 over x plus 1 square plus 1 square dx. And what does this look like? Tan inverse, because it's x square plus a square. Even though x is x plus something, that's totally fine. Tan will work. So the answer will be 1 over a, because a in this case is 1, tan inverse x plus 1 over 1 plus c. So that will be 1 over 2 tan inverse x plus 1 plus c. That's our final answer. All right, and finally, we have a question that is based on the long division technique.
How do I know this is a long division? Because this is clearly the degree of, both are polynomials on the top and bottom, but the degree of top is more than the bottom. Or even if it is equal, then also it is a long division. Once again, guys, if you don't remember long division, please make sure you review that once. Although I'll also try to explain it as much as I can, but this video is not focused on long division. It should be a part of the prerequisite that you should have. The first thing is, if there are any missing degrees, make sure to place the placeholders in the dividend. So it will be 0x square minus 27x plus 2. And we start dividing it. So x cube divided by x square is just x. So I have x here. And this will be multiply this x with this entire thing. So x cube minus 6x square plus 9x. We subtract, change the sign, gone. This will be 6x square. If we add these two and if we add these two, this will be, I think, what, 36, right? 36, 3, yeah, I think, yes. And 2 is dropped down, and then once again I divide 6x square by x square to get 6 and multiply 6 with these entire thing. So this will become 6x square minus 36x plus 54. Gone, gone, gone. So this, and this is also gone. So I'm just left with the remainder of 56. Okay. So the question is actually now dividend over divisor will be equal to the quotient, which is x plus 6, plus remainder, which is 56, over the divisor, which is x square minus 6x plus 9. And this entire thing is supposed to be integrated now. So we are yet to integrate this. And yes, you are right, this also converts into a perfect square scenario. So we have to do that. Obviously, integration of this is pretty straightforward. So let's convert this into a perfect square separately. Actually, you know what? It just feels like, oh, okay, no. Okay, it looked like that, but it's not that bad actually. If you think about it, this is just x minus 3 whole square. Right, it is indeed x minus 3 whole square. So that makes things pretty easy for us, because now this question is nothing but integration of x, then integration of 6, and then integration of 56 times x minus 3 raised to minus 2 dx. That's how it looks like. So this will become integration of x is x square over 2, integration of 6 is 6x, 56 is as it is, and integration of x minus 3 to the minus 2 is x minus 3 to the minus 1 over minus 1 plus c. So our final answer over here will be x square over 2 plus 6x minus 56 over x minus 3 plus c. So that should be our final answer. All right, for this first question, we are given a differential equation, and we need to find a particular solution of it with the given initial condition. And after finding that particular equation, they are saying that the equation of the line tangent to this particular graph is written as this. Then what is the value of b? So actually, in a way, we don't really need to find a particular solution, because this is as good as a tangent line equation, right? And for a tangent line equation, we already have a point. We need a slope. And slope is nothing but we can just substitute this point over here in this differential equation, right, to get the slope, because dy over dx is the slope. So dy over dx will be equal to 3 times negative 1 square, because the point is 3 comma negative 1, over cos of x is replaced by 3, so 3 pi. Negative 1 square is 1, 1 times 3 is 3, and cos of 3 pi is negative 1. Cos of 3 pi is same as cos of pi, which is negative 1. So this will be negative 3. So the equation of the tangent line will look like y minus y1 equal to m times x minus x1. So this will be y plus 1 is equal to negative 3x plus 9. And if we rearrange this, we are going to get y is equal to negative 3x plus 8. So they are asking in mx plus b, what is the value of b? Clearly, it is 8. So that is our final answer. Yeah, I hope this makes sense. All right. Next question is on slope field. So they are saying that the slope field for a given differential equation is shown below. There is a horizontal line with the equation y equal to c that satisfies the differential equation. So what is the value of c? Very straightforward question, guys. All we need to see is where is that line which is a horizontal, because y equal to c is obviously a horizontal line. And the way I see it, if you look at this carefully, all these points or the respective, the slope field is exactly horizontal, which is passing through 1. So this equation looks like y is equal to 1, and hence the value of c is just going to be 1, which is our answer. All right. Here we are given that there is a differential equation, and let h be the particular solution to this equation passing through this. So we have to find what is the limit as x approaches infinity of h of x. So obviously we need to find h of x first. So this looks like a separable differential equation, because I can divide both sides by 2y and I can multiply both sides by dx, so that the x families together and the y families together. That's always my aim, right? I integrate here. 1 over 2 comes out, and this looks like 1 over y dy. And this can be written as x to the minus 2 dx, yeah? And the integration is pretty straightforward. So half of 1 over y integration is ln absolute value of y, and this is equal to x to the minus 1 over minus 1 plus c. This can also be written as 1 over 2 ln absolute value of y is equal to, this negative is as it is, and x to the negative 1 is 1 over x plus c. Now we can use this point to find the value of c. So this will look like 1 over 2 ln of absolute value of 5 over e, because that's the y value, is equal to negative 1 over 2, that is the x value, plus c. So ln of 5 over e will be same as ln 5 minus ln e. Absolute value just disappears, guys, because this is a positive number, right? I don't really bother about that. Is equal to negative 1 half plus c. So this can be written as 1 half ln 5 minus 1 half ln e is equal to negative 1 half plus c. Ln e is just 1. 1 times negative 1 half is negative 1 half, and negative 1 half is gone from both the sides. So the value of c is just half ln 5. I'm just going to write c on the left side. So half ln 5. And this we are going to sub back in over here. And remember, we need to eventually isolate y as well. So we'll do that right now. So first off, the equation is now going to look like, in fact, let's actually substitute the constant. So negative 1 over x plus 1 half ln 5. Let's multiply 2 both the sides. So ln absolute value of y is equal to negative 2 over x plus ln 5. So absolute value of y will be equal to e raised to negative 2 over x plus ln 5, right? I hope you understand this. Since we are talking about the y value, so y can, so over here there is a usual confusion that when we are finding y, we will end up with a plus and minus, because we do away with the absolute value sign. But remember that the point that is given to us is, for a value of x we are getting a positive, sorry, for a value of x we are getting a positive y, which means that they are only interested in the positive branch of it. So y is actually positive e to the negative 2 over x plus 5. And now we have to put limit x approaching infinity. So we'll do that. Limit x approaching infinity to e to the negative 2 over x plus ln 5. Obviously, when I put infinity, 2 over infinity will become 0 over here. So we are left with e raised to ln 5. And using the properties of logs, e raised to ln 5 is just 5, which is our final answer. It was a slightly tricky one, but yeah, I hope this makes sense. Right. Over here we are given that let y equal to gx be a solution, particular solution to this differential equation with this initial condition, and gx is this, then find the value of a. So this is as good as solving this out, right? Solving this out completely and then comparing that what's going on over here. So once again, I think we are going to cross multiply so that y family will come together, 2y dy, and x family will come together, which is 3 sine pi x dx. Integrate, integrate. So 2 comes out, integration of y is y square over 2. 3 comes out, integration of sine is negative cosine pi x. But remember, since this is not just x, this is pi x, so we have to divide this by pi as well, right? This is the shortcut. If you are confused about this, just make a u substitution of u equal to pi x and then integrate this entire thing. You will end up with the same thing. But guys, this is a shortcut. If x has a coefficient, if just x, right, not x square or anything, if x has a coefficient, then you just integrate normally and you divide by that coefficient. That's how it plays out. Okay, plus c, constant of integral. These two are gone. So y square is equal to negative 3 over pi cosine of pi x plus c. That's what I have. Now g of 1/2 is given as 3, right? So we're going to use that y is replaced by 3 and x is replaced by 1/2. So cosine of pi times 1/2 plus c. Pi times 1/2 is pi over 2 and cos of pi over 2 is 0. So 9 is equal to 0 plus c, which means that c is 9. Okay, so if that happens, then what will be the equation? I think coming back to this one, y square is equal to negative 3 over pi cos of pi x plus 9. And if we take square root, then y will be square root of, let's see what is the format that they have given us. First comes a. So I think I have my answer already. First comes 9, then 9 minus 3 over pi cos of pi x. I'm not putting plus and minus because, well, they are telling me that it is a plus sign, so why bother? So a is clearly 9 and b is clearly negative 3 over pi. That's what they need from us. That's what they need from us, right? Yeah, a. So that's our answer. Okay. Which of the following could be the slope field for the differential equation? Okay, here in the slope field questions, there are a couple of well, strategies that you can use to eliminate options very easily. There are few points that always helps us. For example, x-axis, y-axis, and origin, right? So consider how x-axis behaves, how y-axis behaves, and how the origin is behaving, at least these three. Then if you're still struggling between a couple of options, if you don't have your answer yet, try the quadrants. Quadrants as in, I'll just explain in a minute. First off, x-axis. So on x-axis, I know that y is just 0, right? So if y is 0, then dy over dx is just equal to x, which means that if x is positive, dy over dx will also be positive, and if x is negative, dy over dx will also be negative. So how can b be the answer then? Because you can see that you see these lines. This is dy over dx being negative because its slope is negative, but here x is positive. So obviously option B is ruled out. Option A is fine from that point of view. Option C is fine, and option D is also gone because here you can see that on the x-axis the lines are all horizontal, which doesn't make any sense. The slope is not really 0, so D is also gone. Okay, for y-axis x should be 0, so if x is 0, then dy over dx is same as negative y, which means that if y is positive, dy over dx is negative. If y is negative, then dy over dx is positive. Which means that how can option A be the answer? Because A has y positive and y prime also positive. So A is clearly ruled out, and I'm just left with option C. That should be the answer. Now, the quadrant thing that I was telling you is, for example, here, if let's say x is negative, there are four quadrants, right? Positive, positive, that will not really help me. Negative, positive, yes, this will help me, which is quadrant 2. Negative, negative, this will also not help me. And positive, negative, this will help me. For example, if I put any point in quadrant 2, and since x is negative and y is positive, so negative minus another thing will give me a negative number. So in quadrant 2, all the entire dy over dx of the slope field will be negative. Likewise, in positive, negative, entire thing will be positive. So that ways, these are also some points how we can rule out the options. But to start with, just try these axes and the origin. Okay. For here, we are given that the number of weeds in a large garden is given by the function w that satisfies this differential equation. At t equal to 2, there are 20 weeds in the garden. Then find the value of d square w over dt square when w is 14. Okay, so we have to differentiate this once again. It may look easy, but there is a trap here. Let me tell you that trap. Let's differentiate this first off. So d square w over dt square is equal to 1 over 12 as it is. Derivative of negative 313 is 0 and 24, w is 24. If you think that this is your answer, no, you are sadly mistaken, because we are differentiating in terms of time. So when you differentiate w, you also have dw over dt over here, right? So don't be tricked by this. 1 over 12 times 24 is 2, so 2 times dw over dt, and we need to find that at t equal to 2 there are 20 weeds in the garden. So what is this when w is 14 over here? Okay, so we know that w is 14, and we need to find dw over dt, and dw over dt is just literally dependent on the w, right? So I don't think so this information is required uh, uh, to find this. So dw over dt will be 1 over 12 negative 313 plus w is 14, right? So we plug in this 14 over here. So what is 24 times 14, guys? 24 times 14 is 4 times 4 is 16, 6, 1, 4 2 are 8, 9, 4 1s 4, 2, so 6, 9, 10, 13, 3, 1, 3, 336. What is 336 minus 318? Isn't that just 18? So here we end up with 1 over 12 times 18, and 1 over 12 times 18 is 3 over 2 if we reduce by 6. So this is dy over dt, dw over dt when w is 14. So we just plug that in over here. So the answer will be 2 times 3 over 2, which is 3. That should be our final answer. All right. Consider this differential equation. On the axis provided, sketch the slope field at the 8 points indicated, and then find the particular solution with this initial condition. All right, we can do that. So on the x-axis, these 4 points are really easy because the y is equal to 0. And if y is 0, what is dy over dx? Isn't that just 0 square over x, which is just 0? So these 4 points are just horizontal bars over here like this. Okay, these 4 are gone. Now let's pick this point, which is 1 comma 1. At 1 comma 1, dy over dx will just be 1, right? Because it will be 1 square divided by 1, which is 1. And 1 is basically 45 degrees, right? When the slope is 1, it's equally inclined, so 45 degrees. So probably something like this. At this point, it is negative 1 comma 1. So dy over dx will be 1 square over negative 1, which is negative 1. So it will be equally inclined, but in the opposite direction. So like this. And the similar situation will be followed
over here as well, because even if the sign of y changes, it won't really impact anything because y is squared anyway. So -1 square over -1 is just -1. So it will still look like this, and this will be x is positive, y is -1, y is -1 once again, it's -1 square over 1, which is just 1. So this will also look like quadrant 1 slope. So these are how the 8 points will look like. Okay, we need to solve this. So let's, I think we need to cross multiply, right? Let's do that. So dy over y square will be equal to dx over x if I cross multiply. And let's rewrite this as y to the -2 times dy is equal to 1 over x dx. Integration of y to the -2 is y to the -1 over -1, and this is ln absolute value of x plus c. So this can be written as, let's multiply -1 both the sides. So y to the -1 is equal to negative ln absolute value of x minus c. So this will look like 1 over y is equal to negative ln absolute value of x minus c. Let's take reciprocal on both the sides because we have to isolate y after all. So y will look like 1 over negative ln absolute value of x minus c, and that's it. Now f1 is -1, so let's sub these in. Replace y with -1 and x by 1. So negative ln 1 minus c. So -1 is equal to 1 over 0 minus c. So -1 is equal to 1 over minus c, which means that 1 is equal to 1 over c, which means that c is 1. So if c is 1, and I just plug that back in over here, so I'll write the final answer as y is equal to 1 over negative natural log of absolute value of x minus, and c is just 1, so -1, which can also be written as, if we take negative as a factor, it is as simple as -1 over ln absolute value of x plus 1. So this is our final answer. Okay, the rate of change of the volume of water in a swimming pool is directly proportional to the cube root of the volume. If the volume is 27, when dV over dt is 5, then what is a differential equation that models the situation? Okay, this is the rate of change of volume. Okay, it's directly proportional. So dV over dt is the rate of change of volume, and they are saying this is directly proportional to the cube root of the volume. So cube root of the volume is like this. So if we do away with the proportionality, we will get a constant of proportionality, which is k. And obviously we need to find the value of k, which we can using this equation, right? This information, because dV over dt is 5 when volume is 27. So 27 to the 1 over 3. Cube root of 27 is 3, and divide both sides by 3. So you have the value of k as 5 over 3. So the value of k is 5 over 3. That's what we have. This we are going to substitute over here. So the equation that we have, the differential equation that we have, is dV over dt will be equal to 5 over 3, because that's the number that I have, times v to the 1 over 3. So this is dV over dt, and is this what they're asking? What is the differential equation? Yeah, this is the differential equation, right? That models the situation. That's our answer. All right, a population y grows according to the equation this, where k is a constant and t is in years. If the population doubles every 12 years, then what is the value of k? So this is a classic exponential equation, but of course I can prove this for you. dy, let's divide both sides by y. So dy over y is equal to k times dt. Integrate. Integration of 1 over y is ln absolute value of y,
is equal to k times t plus c. Guys, I know for a fact that this is going to be just y because we are talking about population here. So y is never going to be negative. So I can just safely drop the absolute value from here. And y will be equal to e raised to kt plus c. And I think I'm pretty sure that you guys must have seen this arrangement that we can rewrite this as e raised to kt times e raised to c. Your school teachers must have used it. And e raised to c is once again another constant which can be written out in the front. So c times e raised to kt, right? Just another constant. Now they are saying that the population doubles every 12 years. So doubles every 12 years means first we need to find that what is the initial population. Initial population happens when t is 0. So when t is 0, y is c. 12, the population doubles, right? So double means 2c. So if we sub in this situation over here, we are left with 2c is equal to c times yeah, y is 2c is equal to c times e raised to k times 12. C is gone, so 2 is equal to e raised to 12k. So ln 2 is equal to ln e to the 12k, which means that ln 2 will be equal to 12k times ln e. Ln e is just 1, so ln 2 is equal to 12k. So ln 2 divided by 12 is equal to k, right? So this is the value of k, which is ln 2 over 12. That's our final answer. Okay. Find the value of k, if any. For what value of k, if any, will this be a solution to this differential equation? So the way we solve such questions is, even if this was, let's say, hypothetically y prime. So what we do is we find y prime, we find y double prime, and we substitute it over here had this was y prime. But in this case, we just have to find y double prime, although obviously we need to find y prime first. Sub in here, put the y over here so that everything will be in terms of x. Things will cancel out and you will get the value of k. Let me show it to you. So y prime will be equal to k times derivative of cos 2x will be negative sine 2x times 2, and sine 4x will be 4 cosine 4x, which will be negative 2k sine 2x plus 12 cos 4x. So y double prime is negative 2k 2 cos 2x and negative 12 because cos is minus sine. 4 comes out and sine 4x. So this will be negative 4k cos 2x, negative 16 sine 4x. This is y double prime. And now I am going to plug in this y double prime over here and y over here. So this will look like negative 4k cos 2x minus 16 sine 4x. This is y double prime plus 16 times y, which is k cos 2x plus 3 sine 4x, right? I hope you guys are with me. I just subbed in y double prime here and 16 remains as it is, and I subbed in y. Obviously it's a long equation, but yeah, that's what I did. Well, let's hope I'm right. Oops. Yeah, cos 2x. Okay. Oh my goodness. Okay, let's open these things up. So negative 4k cos 2x minus 16 sine 4x plus 16k cos 2x plus 16 times 3 is 48 sine 4x is equal to negative 6 cos 2x. I think I've made a mistake here. 12 times 4 is 48. I don't know why I said 16. Oops. 12 times 4 is 48. So that correction will come over here as well. So this is 48, this is 48. Okay, that makes sense because that's a big relief. These two are gone. Right. Now, from the left side, I'm going to take cos 2x as a factor. So I'm left with negative 4k plus 16k over here. And on the right side, it is just negative 6 cos 2x. So cos 2x is gone. 16 minus 4 is 12. 12k is equal to minus 6. K is equal to negative 6 over 12, which is negative 1 over 2. Well, that should be the value of k. Okay. Over here, sketch a particular solution that goes through the indicated point. So this is about eyeballing it and see how best to draw it. F0 is equal to 2 means 0 comma 2. 0 comma 2 is over here. So I'm just going to trace the function as best as I can. If you just to confirm, there are some horizontal slope fields over here as well, right? So if I start drawing it from here, clearly the trajectory looks like this, and then it is following this orange guy, and then eventually it will flatten out over here. So that's how part A should look like. Part B is negative 2, negative 4, which is in quadrant 3, of course. Negative 2, negative 4 is right here. And negative 2, negative 4 means it is going something like this. This will also go eventually, it will flatten out about the x-axis, but this time something like this. So that's how we'll draw these situations. Okay. Once again, the same type but different slope field. This is f0 comma f0 equal to 2, once again y-axis. So y-axis 0 comma 2 is right here. Okay, this time it's a little different because although it looks like it is coming down, but look at that, this becomes horizontal, means it starts to take a turn, and then it follows this line because it is like a slant asymptote sort of situation. So this is part A. And for part B, f20 means 2 comma 0 means x-axis right here. Let me switch to red, like this one. Okay, so this one looks like almost something like this. So for example, if you see, we are tracing this one. So this is how it will be traced. And okay, let me redraw this. So this is something like this. I'm gonna trace here, 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 and eventually it is just approaching the same sort of like a slant asymptote, because this looks like a slant asymptote to me. So yeah, that's how I will draw the one that is passing through 2 comma 0. Right. Okay. Use separation of variables to find a particular solution of this differential equation. Okay, all right, let's do that. So let's isolate the families together. So du dividing by u both the sides, so u families together, and multiplying by v both the sides, so v sine v squared dv, that's on one side. Integrate, this we have to use a u sub. Obviously u is already taken, so it's fine. You can use the variable as t when you're substituting, and of course v square should be that substitution. So let's say v square is equal to t, so 2v dv will be equal to dt, so v dv will be equal to half dt. Okay, so v dv, right, is replaced with half dt, so half dt, and sine of v square is just sine of t, so we integrate this, and this is just 1 over u du. Okay, integration of 1 over u du is ln absolute value of u, and this is 1/2. Integration of sine is negative cosine t plus c, and let's sub in all the not all the, I mean let's sub in these the t again as v square, because the condition is given in terms of u and v. So it will be negative 1/2 cosine of v square plus c. and now I plug in 0 comma 1. So u of 0 is 1 means at v equal to 0 u is 1. So u is 1, v is 0. So it will be ln absolute value of 1 is equal to negative 1 half cosine of 0 plus c. Ln 1 is 0, so 0 is equal to negative 1 half cos 0 is 1 plus c. So 1 half is c, which means that c is 1 half. Okay. What do I have to do here? I think I can plug that back in here. So this is going to look like ln absolute value of u is equal to negative 1 half cosine of v square plus 1 half. So which is ln absolute value of u is equal to 1 half. 1 half can be taken as a factor. So negative cos v square plus 1. So it will look like absolute value of u is equal to e to the 1 half negative cos, or maybe 1 minus cos v square. Don't think that 1 minus cos v square is sine v square. That's not correct, because identity is 1 minus cos square v is sine square v. So don't think that. The question is whether it should be positive or negative. So clearly it should be positive, because u is a positive number when v is 0, because when we do away with the absolute value, you might be tempted to put plus and minus, but it should just be plus. So this should be our final answer with u isolated. Right. The rate of decay of radium is proportional to the amount present at any time. If 60 milligram of radium is present now and its half-life is 1690 years, then how much radium will be present 100 years from now? And this is your calculator active question. Okay. The rate of decay of radium, it means that, let's say the rate of decay, I don't know, maybe y. So dy over dt, rate of decay, is proportional to the amount that is present at any time. So y is present at any time. So I'm going to say that dy over dt is equal to ky. Okay. So of course dy over y will be equal to k times dt. I integrate. This is the same thing as we did earlier, guys. So this will become ln y is equal to kt plus c. This will become y is equal to e to the kt plus c. This can be written as y is equal to e to the kt times e to the c, and e to the c is another c. So c times e to the kt. And c is the initial value, which is already given in the question as 60 milligrams. So y is equal to 60 times e raised to kt. They are saying if the half-life is 1690, then how much radium is present after 100 years? Half-life means that the time it takes for the substance to become half of its initial value. In other words, when time is 1690 years, y will become 30. So 30 is equal to 60 times e raised to k times 1690. That's what they are trying to say. This information will help us to find the value of k. So these two are gone. Divide both sides by 6. So that's 1 half is equal to e raised to 1690k. Take natural log both the sides. So natural log of 1 half is natural log of e to the 1690k. So natural log of 1 half will be equal to 1690k. So the value of k comes out as 1 over 1690 natural log of 1 half. And now we need to find what's the equation that we end up with. So we have y is equal to 60 times e raised to kt, where k is this gross thing, 1 over 1690 natural log of 1 half times t. And all we have to do is replace this t with 100. So in other words, since the calculator is allowed, I'm just going to replace this with f of t, and we are looking for what is f of 100. So if I do this using Desmos, I'm going to plug in f of x is equal to 60 multiplied by e raised to 1 over 1690 times natural log of 1/2, and the x is also sitting on the top. Sorry, x is sitting probably somewhere over here, and we need to figure out what is the value of f of 100. So that's 57.59 milligrams. So our final answer is 57.59 milligrams. That's what we are going to box in. Okay, the next one we have, determine the differential equation being graphed by the slope field. So I think again I'm going to use the same strategy. I'm tempted to try y-axis first, because in the slope field, y-axis, as you can see, is all horizontal, means dy over dx is 0, and on y-axis x is 0, right? So if I put x equal to 0, which of these options are giving me dy over dx? Which of the following options are not giving me dy over dx is 0? Definitely not E, because ln 0 is undefined, so that's not right. And definitely not C, because this will just become dy over dx is equal to y, which is not always 0. Okay, so two options are gone. On the x-axis, we can see that it is always positive, right? You can see it is never going negative, even if x is negative. So if x is negative, okay, these two, this cannot be the answer. Why? Because if x is negative, clearly dy over dx will be negative, because the cube of a negative is a negative number. But is this negative? Of course not. So A is gone. Okay, what about this one? Here, if y is 0, in fact, when on x-axis, y is 0, right? But if y is 0, this will become undefined. But is this undefined? No. So this can also not be the answer. So by elimination, answer has to be option B. All right, determine the differential equation being graphed by the slope field. Once again, on the x-axis, just to confirm, there are horizontal slope fields. So on x-axis, it is giving me 0 over here. So I'm tempted to test that first. On x-axis, y is 0. So if I put y equal to 0, which one is just giving me 0 every time? Not this. Not this, because obviously there is no y here. If I put y as 0, this will become x, so not this. This will definitely give me 0, and not this as well. Isn't that, well, that's pretty straightforward. Because yeah, I mean, by that logic, everything has been ruled out, because yeah, I think the answer has to just be option D. That was pretty straightforward. Okay. This is an actual AP Calculus AB FRQ. So we are given that dy over dx is this, and y equal to fx be a particular solution for the differential equation for 1 less than x less than 5, which means that x is between 1 and 5, and such that the line y equal to -2 is tangent to the graph of f. So what is the x coordinate of the point of tangency, and determine whether f has a local max, local min, or neither at this particular point, and justify your answer. Okay, so y equal to -2 is a tangent here, and find the x coordinate of the point of tangency. No need to solve this, guys. They are just saying that y equal to -2 is a tangent to the graph. Now y equal to -2 is a horizontal line, right? Because y equal to -2 is basically like this. What is the slope of this line? Isn't that just 0? And slope is dy over dx. So this means that 3 minus x over y is 0, which means that 3 minus x is 0, which means that 3 is x, or x is 3. That's our answer to this question. What is the x coordinate of the point of tangency? So the point is 3 comma -2. And then determine whether f has a local min, max, or neither. I think we can use the double derivative test here, right? We can just double differentiate this using the quotient rule, or differentiate it again, which is basically the double derivative. So low square, low d high is -1, minus high d low is y prime. We already know that y prime is 0, so no need to worry about that. So this will become negative y, this is anyway 0, over y square. Negative y over y square is just negative 1 over y, and y is already negative 2, so negative 1 over negative 2 is positive 1/2. If the double derivative is positive, then using the second derivative test, I can conclude that this is a local minima over here. Yes, it works counterintuitive with second derivative test in case you do not remember it. So it should be local minima over here. Yes, in the next one, they are explicitly asking us to find what is gx, which is a particular solution when x is this and initial condition is this. So yes, now we have to make that effort. Okay, I think I'm going to cross multiply right off the bat. So y family is together and then x family is also together. Okay, let's integrate this both the sides. So integration of y is y square over 2. Integration of 3 is 3x. Integration of x is x square over 2 and then plus c. Let's sub in these numbers. In fact, let's isolate y. So multiply 2 both the sides. So 6x minus x square plus 2c. So y is equal to plus minus square root of 6x minus x square plus 2c. I can definitely tell that the since at x equal to 6, y is a negative number, so I have to take a negative solution in this particular case. So y will be equal to negative square root 6x minus x square plus 2c. And now I'm going to use that initial condition where replace y with minus 4 and x by 6. So 6 times 6 minus 6 square plus 2c minus 4 is equal to minus square root of 36 minus 36 plus 2c. Negative negative is gone from both the sides. So 4 is equal to square root of, these two are gone, 2c. So 16 is equal to 2c by squaring both the sides. So 8 is equal to c, or c is equal to 2. This we are going to, nope, we are going to sub in over here. So our final answer is y is equal to negative, or gx, because they are calling y as gx. So y is equal to gx is equal to negative square root 6x minus x square plus 2 times c, and c is 2. So 2 times 2 is 4. So that should be our final answer. Right, last question. We need to, on the axis provided, we need to draw the slope field at the 12 points. Oh my God. Okay. I'm going to start with x-axis first because y is just 0. Actually, you know what? I'm going to start with y-axis because x is 0 and I can just see that the dy over dx will be 0. Because x is 0 means, 0 times y minus 2, which is just 0. So that's easy. 1, 2, 3, 4. Okay, 4 points down. All right, now let's plug in 1 comma 0 here. 1 comma 0 means x is 1, y is 0. So at 1 comma 0, y prime will be negative 2, I think, because this is 1 and 0 minus 2 is just negative 2. Okay, what negative 1 comma 0 will make y prime as again negative 1 to the 4 is 1 and 0 minus 2 is again negative 2. So whatever that is, they will be identical over here. And in fact, change in the sign of x is irrelevant because x is raised to a 4. So it will automatically become positive. So no need to find both these points. Just find these and replicate it over here. At this point, 1 comma 1, we can clearly see that y prime will be 1 to the 4 times 1 minus 1, which is minus 1. At point 1 comma 2, it will be y prime is equal to 1 to the 4 times 2 minus 2, which is 0. So that's interesting. This will also be horizontal. This will also be horizontal. And 1 comma 3, yes, this time it will be positive. So this is positive, equally inclined like this, and it will replicate here. This is opposite side inclined, equally inclined, negative 1. So it is like this. and this will be evidently more inclined, right? So more inclined means maybe slightly like this. So we can, even with eyeballing, anyone can say that, okay, this guy is more inclined. I have inclined it less. More inclined means it should be over here. Really sorry. It should be over here. Yeah. Okay. Now it makes sense. It is more inclined than this one. So yeah, this should be our final answer. All right. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Determine all points in the xy plane for which the slope fields are negative. So slope field will be negative when dy over dx is less than 0. Dy over dx is x to the 4, y minus 2 should be less than 0. Well, x to the 4 can never be negative, right? X to the 4 can never be negative. We just have to make sure that x is not 0, because if x is 0, then this entire thing will be poofed, will become 0. So we just want to make sure that x is not equal to 0. And if x is not 0, we have to make sure that y minus 2 is negative. So y should be less than 2. So the points will be all the points which are satisfying the condition, points satisfying x not equal to 0 and y less than 2. All these points will give negative slope. This is the condition. You have to essentially write x not equal to 0. Otherwise, if x is equal to, writing just y less than 2 is half true. Because if x is 0, then even if y is less than 2, it won't make any difference, because that will make the entire thing 0, right? Okay. What is a particular solution? Now, finally, if f0 is 0. Okay, particular solution means separation of variables. So let me rewrite this question here. Then I will zoom in once again. So dy over dx is x to the 4 times y minus 2. All right, don't have enough space here, but I think we are going to make it work. Let's start from here. So let's divide both sides by y minus 2 and multiply both sides by dx, so that the x families together are y families together. Integration will be ln absolute value y minus 2 is equal to x to the 5 over 5 plus c, which means that absolute value of y minus 2 is e to the x to the 5 over 5 plus c, which is absolute value of y minus 2 is equal to e to the x to the 5 over 5 times e to the c, and e to the c is just another constant. So absolute value of y minus 2 is c times e to the x to the 5 over 5. Now f0 is 0, right? So let's plug in y as 0. So 0 minus 2 is equal to c times e to the 0. Absolute value of minus 2 is c times 1. So 2 is equal to c, or c is equal to 2. So let's plug in c is equal to 2 over here. So if we do that, this equation, absolute value of y minus 2 will be 2 times e raised to x to the 5 over 5, which means that as of now, I have y minus 2 is equal to plus minus 2 times e to the x to the x5 x to the 5 over 5, which means that y is equal to 2 plus minus 2 times e raised to x raised to 5 over 5. Now the question is that a plus sign or minus sign? It has to be minus, because remember 0 comma 0 is a point on the curve. If I take the plus sign, it will become 2 plus something, which will not really be 0. I need 2 minus something so that it eventually becomes 0. So the final answer will come with a negative sign. So 2 minus 2 times e raised to x to the 5 over 5. This should be our final answer. Unless otherwise stated, there is no calculators not allowed. So this one is no calc. Okay, particle moves along the x-axis with this velocity function. If the particle is at a position of 2 when t is 0, then what is the position when t is 1? So we know that the integration of velocity function is basically a displacement, and displacement is nothing but the change of position, right? So x of t2 minus x of t1 is equal to integration from t1 to t2
of the velocity function. Okay, t2 is 1 seconds. That's what we need to find. T1 is 0, so x of 0. And integration will be from 0 to 1 of the velocity function. Velocity function is 3t square plus 6t dt. All right. X of 0 is already given to us, guys. That's 2, right? That's the initial position. And x of 1 is what we need to find. So x of 1 minus 2 is equal to, what is the integration of 3t square? That's 3t cube over 3. And 6t square over 2 from 0 to 1. So x of 1 minus 2 will be equal to t cube plus t square from 0 to 1. If we place the upper bound will be 1 plus 1, which is 2, and minus the lower bound is just 0. So this will be x of 1 minus 2. So x of 1 will be adding 2 both the sides, which is 2 plus 2. So the answer is 4 units or 4 meters. I'm not sure if the unit is given, but yeah, unit is not given. It's fine. The answer is just 4. So that's our final answer. Okay. In this one, the particle moves, this is calc active, by the way. A particle moves along a line with this velocity function. So we need to find the displacement on 1 to 7. So we just learned the formula, right? The displacement is nothing but the velocity of the integration of the velocity function from 1 to 7, t square minus 7t plus 10 dt. I'm going to share Desmos, but let me write all the expressions first, and then I'll share Desmos together for all the questions. Next is find the total distance traveled. Now guys, distance traveled is the integration of speed, and speed is nothing but the absolute value of the velocity. So it's the same stuff, except that just put absolute value around t square minus 7t plus 10, and this is going to give you the distance. And finally, what is the average velocity? That's easy. Average velocity is nothing but the total displacement over total time. So total displacement I have from part A. Total displacement over total time is nothing but 7 minus 1. So whatever that is, you divide that by 6. So let me just share the Desmos now. All right, guys, so I'm going to plug in the function first. I'm just putting in terms of x, it doesn't really matter. X square minus 7x plus 10. Okay, I have no interest in seeing the figure, so the graph, so I'm just going to click on that. Now for, this is the velocity function, right? So I want a displacement, so I will type int, so it will automatically convert an integral symbol. Then this is 1, this is 7, and here I will just put fx dx. So that's the displacement. I can copy this entire thing and paste in the next line and select f of x, and then go here and then put the click on the absolute value symbol. So this becomes my distance, which is 15. And the average velocity is the displacement, which we can see is 6. 6 over the time. Time is also 7 minus 1, right? Which is also 6. So obviously that's just 1. Great. So coming back here, let's write our final answers. So displacement is coming as 6 units. Do we know the units here? Again, no. So 6 units over here, distance will be 15, and the average velocity is just 1 unit. So that's how we do this question. I hope this makes sense. Okay, this is also calc active, guys. At t equal to 0, water begins leaking from a tank at this particular weird rate in gallon per minute, where t is measured in minutes. Obviously, it makes sense. If it is gallon per minute, t is in minutes. How much water in gallons has leaked out of the tank after 5 minutes? So these kind of questions you will often see in the FRQ, guys, because in FRQ, one of the bit, they talk about, one of the part talks about such kind of stuff, which is called accumulation of functions. So here the total water that has leaked out is nothing but the rate at which the water is being leaked out, and that is supposed to be integrated all the way from t equal to 0, that's the starting point, and 5. So all I need to do is plug this in into calculator or Desmos and figure this out. So let me just share Desmos now. All right. So once again, I'm going to plug in my function fx as 5 times e raised to negative parentheses x minus 3 whole square divided by 2. So be very careful while plugging in the expression. And I am supposed to integrate this int from 0 all the way to 5 of f of x dx. And there you go. My answer is 12.23 gallons. Right, so I'm going to say that 12.23 gallons of water has leaked out in the first 5 minutes. Right, pretty straightforward. I hope that makes sense. Okay, average value now. This is also calc active. They're asking what is the average value of the function. So if you remember, the average value, or something that is also related to the MVT for integrals, is given by integration from a to b of fx dx over b minus a. That is the formula for the average value of a function. So literally all we have to do is plug in a as -1, b as 3 over here, and the function, that's a gross one, it is sine x over x square plus x plus 2 dx divided by 3 minus -1. So let's type this in Desmos. All right, guys, make sure your calculator is in radian mode. Default mode of Desmos is already in radians. You can see on the top right, you see this wrench option. It is already in radians, so I don't have to worry about that. So let's type in the function over here, which is sine of x over x square plus x plus 2. And then I go and integrate from -1 to 3 of f of x dx, and this entire thing I'll put parentheses here because I need to divide this entire thing by 3 minus -1. Obviously that's 4, but I'm just going to put it like this so that you understand. So the answer is coming as 0.0317. And we can see that 0.0317 is nothing but 0.032. So that's the final answer. Right? Pretty straightforward. Okay. This is no calc, guys. We need to find the average value of this function on the interval 2 to 4 and find the value of c using mean value theorem for integrals. Okay, let's find the average value first. The average value is given by integration from 2 to 4 of fx dx over 4 minus 2, right? The same formula that I used earlier. So integration of 2x is just 2 times x square over 2, because the integration of x is x square over 2. And then the integration of 1 is just x. The bounds are from 2 to 4 over 4 minus 2 is just 2. Okay, so 2 and 2 is gone. So if I put the upper bound here, it will be 4 square plus 4, right? 4 square plus 4. Minus, if I put the lower bound, it will be 2 square plus 2 over 2. So this will be 16 plus 4 minus 4 plus 2 over 2. 16 plus 4 is 20. 4 plus 2 is 6 over 2. 14 over 2 is 7. So this is the average value. Now, to find the value of c, all we have to do is equate the function's value at c to the average value. That's what MVT for integral looks like. So f of c is just 2c plus 1, and the average value is 7. So this is 7 over here. So 2c is equal to 6. So c will be equal to 3 over here. So that's how we find the value of c. Right? Pretty straightforward. Okay. Okay, this is calc active, guys. Find the area of the region in the first quadrant enclosed by the graphs y equal to cos x, y equal to x, and the y-axis. You know what, guys? I'm going to do this because if they really need the value, they will allow calculator. But what if they just need the integral expression? Because you must have seen
this in fact, old AP calculus style questions. They sometimes just ask the expression for the integral and when the calculator is not allowed. So I'm just going to show this one a little bit approach that how you will do it without graphing all of these on the calculator, and then of course we can go to calculator and solve it out. So the idea is first obviously to know the parent functions. Y equal to cos x, we know it's just a straight line, you know, something like that. And y equal to cosine of x will look like something like this, because this just keeps going forever, right? That's the cosine function. It's just a wave, it just keeps going forever. And the y-axis is obviously this one. So this is the area that we are looking for. This is the area, right? Although in order to find this point of intersection, I need a calculator because I cannot really find the intersection of cos x and y equal to x just manually. But let's suppose that this point is it's, let's say, given as a, and I need to write the expression for the area. So area expression, if you remember, is given by either top minus bottom function or right minus left function. Here top minus bottom obviously makes sense. So the expression of area will be top function, which is cos x, minus bottom function, which is x, and this is supposed to be integrated from the initial value is 0 all the way to a. So this is how we will write the expression. Now let's go to Desmos and solve this out. Again, please make sure that your calculator is in radian mode, which it is already. So let's say f of x is cosine of x, and g of x is of course just x, and we are looking obviously for this area, and we now have this point of intersection as well. So all I have to do is integrate from 0 to that gross point. You can also click on this option, because if you click on this one, the point will come over here. So you can easily copy this out, right? We just need the x coordinates. So I'm just going to select Control C, Control V, and then this expression will just be in parentheses. I have f of x, which is the upper one, minus g of x dx. So that's my area, which is 0.4 units. I'm just going to write this out over here, that this will come out as 0.4 units square, actually, square units, whatever that is. So 0.4, that is the area bounded between these two guys, or three guys. Hope this makes sense. Okay, this is no calc, guys. This is okay. Now we are moving to solids. Find the volume of the solid formed by revolving the region bounded by the graph this, and y equal to 0 and the x-axis. Okay, so y equal to 0 is nothing but the x-axis, and it is also rotated about the x-axis. What is this, guys? Yes, this is a parabola opening downwards because the leading coefficient is negative, or the coefficient of x squared is negative. What are the roots of this? We can easily find that out. 4x minus x squared equated to 0. X times 4 minus x equated to 0. So x equated to 0, x is equal to 0, and 4 is equal to x, right? Because if I equate this to 0, I get 4 equal to x, or x is equal to 4. Okay, this means that the parabola is going to look something like this. The roots are 0 and 4, and it opens downwards, so it's something like this. The area is bounded between this curve and the y equal to 0, which is x-axis. So this is the area, and it is rotated about the x-axis, so this around like this. So clearly this is a disk method, guys, because there is no void that is being created when you rotate anything. Usually in the washer method, there are two functions rotated about a line or something. But here I don't see any such situation, and the disk that is being formed, as you can see, is clearly this one. So this is a pretty straightforward question, guys. The answer will be pi integration from, what are the bounds of integral? Obviously from 0 to 4. So 0 to 4, and this radius, because we do pi r square dx, right? and this radius is nothing but the function's height, and function's height is nothing but the y coordinate, and y coordinate is nothing but this. So it will be 4x minus x square dx. That will be our answer. So pi remains as it is. We won't multiply pi out, but let's open this up. It will be 16x. I'm just using a minus b whole square identity. So a square plus b square minus 2ab. And this is to be integrated from 0 to 4. So it will be pi. Let's write x to the 4 first, and let's write 8x cubed next, and then 16x square at the end, and this is to be integrated from 0 to 4. All right, this is just a matter of integration now. This is going to be a little gross, although x to the 5 over 5 minus 8x to the 4 over 4 plus 16x cubed over 3 integrate from 0 to 4. I don't have to really put the lower bound. I mean, as in, it doesn't matter, because if I put 0, everything will become 0. And for the upper bound, you don't really have to simplify this out. Just 4 to the 5 over 5. Obviously, 4 times 2 is 8. Whatever you can, feel free. But the gross numbers, you can leave it as it is. Even I think, I hope you guys know that if, let's say, this is an actual AP Calc question, FRQ, then they don't really expect you to solve this entire thing out, because the numbers are pretty big, right? So it's totally fine that if you leave it like that, you will get full points. But yeah, if you solve this out and then you mess up the calculation, then they will take off points. So yeah, just better not to simplify the gross numbers. Right, I hope this one makes sense. Okay, the next one, this is obviously no calc, because we have to pick the correct option here, integral option. So a solid is generated when this particular region in the first quadrant is rotated about x equal to 1. Okay, interesting. X equal to 1. The region is enclosed by this graph, x equal to 1, x-axis and the y-axis, and is rotated about the x-axis. Okay. Now its volume is evaluated by which of the following integrals. So first things first, I need the graph. X-axis is obviously here. Y-axis is over here. And x equal to 1 is somewhere over here. X equal to 1. Okay. This one, what does it look like? So we don't really have to be worried about the shape. Just some attributes will work. For example, does this have any y-intercept? Yes, because when I put x as 0, I will get y value as 0 plus 1 cube, which is just 1. So 1 point is right here. Does it have any x-intercept? And remember, we are only worried about quadrant 1. So we are not bothered about what happens when x is negative, right? Although it will be symmetric about the y-axis, because this is an even function. But again, no need to bother about all that. When you put x as 1, what happens when x is 1? And obviously this keeps increasing, right? Because if you increase the value of x from here, this will also keep increasing. So it's something like this. Something like this. I'm not saying it's a parabola. It's something like this. So it will go like this. I will stop here, and at x equal to 1, 1 plus 1 is 2, 2 cube is 8. So this point is 1 comma 8, and the area is obviously this guy, which is between the x equal to 1, x equal to 0, y equal to 0, and the function. Okay, we need to rotate about x-axis. Excellent. So this is also a disk method, if I'm not wrong, and this is going to be our disk. So the area is going to be pi, and the bounds will obviously be from 0 to 1. So 1 to 8, 1 to 8, these are just gone. 2 pi doesn't really make any sense. It should be only pi outside, and it should just be the function's square. Now they are tricking by giving us this option. But remember, it is pi integration 0 to 1 fx square. So remember, fx already has a cube, and when I square a cube, 3 times 2 is 6. So there you go. We have a 6 over here. So the best choice is option D over here. Right, I hope this one makes sense. It's a pretty decent question. Okay, This is also no calc, guys, because mind it, they are asking only to write the integral expression and not really not really to solve it out. Okay, the region bounded by this curve and the x-axis is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is an equilateral triangle. So right, but do not so. Okay, equilateral triangle. I hope you guys remember the formula. There are a bunch of standard formulas over here. One is for a square, one is for rectangle, then isosceles right triangle, equilateral triangle. Don't worry, semicircle. Some schools although test semicircles, but it is not an AP, right? So I'm not going to cover the semicircle portion of it because that's again not covered in AP. For the equilateral triangle, if it is perpendicular to the x-axis, the formula is given by integration from a to b root 3 over 4 functions square dx. So we need to find first what are the values of a and b. For that, we need to find the area that is being bounded. 2x minus x squared, don't you think we saw something similar, which was 4x minus x squared? This also opens downwards and the roots are given by 2x minus x squared is equated to 0. So x times 2 minus x is equated to 0, which means that x is equal to 0 and 2 is equal to x. So this is 0. This is 2 over here and it opens downwards. So this is how it opens. And it is bounded by the x-axis. So there you go. This is our region where we are making various equilateral triangles. So the expression is pretty straightforward then. It is from 0 to 2 root 3 over 4 functions square dx, where function is 2x minus x squared. So this is going to be our so-called volume of this particular region, expression for the volume of this particular region. All right. Okay. This is calc active, guys. We need to, okay, we are given the figure as well. The base of a loudspeaker is determined by these two curves. This is obviously the +1 and this is obviously the -1. For 1 to 4, okay, fair enough, it is graphed between 1 and 4. For this loudspeaker, the cross-section perpendicular to the x-axis are squares. Fair enough. What is the volume of the speaker? And okay, so the cross sections are like this, guys. This is the I hope you are able to visualize. The squares are being made in a 3D sense, so it is going like out of the page, like something like this. So this is how the squares are being made. My only point is the side length of the square. That's what I'm interested in, because the formula for the area for the volume is not really a big deal. It's just 1 to 4 because that's given in the question, and then it's just side square dx. But in this case, the side is the distance between the red and blue functions, which is the upper y value minus this y value and this y value. In other words, the upper function minus lower function, right? So 1 to 4, upper function is x squared over 10 minus the lower function is negative x squared over 10 and then whole square dx, right? I hope you understand what I did here. So this comes out as, either you can just type this in decimals now, but if they were asking for expression, x squared over 10, double negative becomes positive. So x squared over 10 plus x squared over 10, which is just twice of x squared over 10, which is just x squared over 5 whole square dx. And this will just become 1 to 4 x to the 4 over 25 dx. And yes, now you can plug that in decimals. I feel like, yeah, let me just plug that thing in decimals now. So it's 1 over 25 and then integral 1 to 4, sorry, 1 to 4, that's not 4, x to the 4 dx. So the answer is 8.184. Okay, so 8.184, that's the answer. Okay, all right. Next one, this is an actual FRQ from 2010. In the figure above, I mean to say below, R is the shaded region in the first quadrant bounded by this function, the horizontal line y equal to 6 and the vertical line x equal to 2. Calculator is active. So we need to find the area of R. Okay, so that's, I think, a pretty straightforward question. The area is just the upper function minus the lower function. Upper function is y equal to 6. Lower function is this ln function. And the bounds are from 0 to 2, the x bounds. So the area will be 0 to 2. Upper function is 6 minus the lower function is 4 ln 3 minus x and then dx of this thing. So let's plug that in. So I'm going to type in 6 minus fx and then parentheses close dx, and this is going integral from 0 to 2. And over here I can type in function separately, which is 4 ln 3 minus x. So that comes out as 6.82. That should be our area. Okay, so 6.82. Now they are saying what is the volume of the solid generated when R is revolved around about the horizontal line y equal to 8. Okay, we have to be very careful here. Y equal to 8 is here. Now, if I'm going to rotate this region about y equal to 8, it's going to form a washer because there is a bigger radius that is being rotated about y equal to 8, and there is a smaller radius that is also rotated about y equal to 8. So you see this portion when rotated will create a void because this is not our area of interest. The area is only the solid portion. So it will look like the bigger radius R1 minus lower radius R2's volume. Now the question is, what is R2 and R1? R2 is pretty straightforward because this is y equal to 8 and this is y equal to 6. So the distance between these two is 2 units. So R2 is 2. R1, okay, be careful here. What is this entire thing? It's 8, right? 8 units because y is equal to 8 here. And what is this? Isn't this function's y coordinate? Because function's y coordinate is nothing but its height from the x-axis. So this is function's y coordinate, and function's y coordinate is already known to us. So R1 is nothing but 8 units minus the function's y coordinate, and function's y coordinate is 4 ln 3 minus x. So this was the main challenge to figure out R2 and R1. The expression is not a problem. The volume is given by pi integration, obviously from 0 to 2. R2 square, which is the, sorry, R1 square, R1 is the bigger radius, which is 8 minus 4 ln 3 minus x square minus R2 square, smaller radius, 2 square over here, and then dx. So this is the washer method, just to be clear, and we can just type this in decimals and we can get the answer. Okay, so the function is already here. So integration from 0 to 2. This is, and there's a pi as well outside. So pi 0 to 2, and then parentheses. There are a couple of parentheses. So another parentheses, 8 minus the function fx. So function fx is already fx, and this entire thing is being squared, and minus 2 square, obviously 4, and then dx. So I hope it makes sense. The inside radius is this one square, I mean bigger radius is this one square, minus smaller radius is this one square, dx 0 to 2, and pi is also on the outside. So 168.18. So we're going to say 168.1, 18, right? 18 units. Yeah, that's the volume. And we have another part. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square, and then find the volume of this solid. So that's also pretty straightforward. If this is the region where we are forming a square, then we need to find what is this portion, right? This portion only. Just be careful this time. Only this portion. So what is this portion, guys? From here to here, this is y equal to 6. So obviously this is 6 units. and this is already y units that I have. So the side of the square to find the area, to find the volume is going to be 6 units, entire 6 units minus the y coordinate. 6 unit, the y coordinate is 4 ln 3 minus x, so that's going to be the side, and the volume is now going to be integration from 0 to 2. There is no pi here, it's just side square dx, where side square is 6 minus 4, that thing. So 6 minus 4 ln 3 minus x whole square dx. Let's just type this in decimals. Right, fx I already have, so integration from 0 to 2, and then 6 minus fx, and this entire thing is being squared, and then dx. So it's 26.27. 26.27. That will be the volume of this solid. All right, this was the last part, I think, here. I hope this one makes sense. It was a pretty decent question. Okay, this is calc actor. Let R be the shaded region bounded by square root of x and e to the minus 2x and the vertical line x equal to 4. Yes, I can see that x equal to 4 is here. Root x is obviously an increasing function like this, and the other one is e to the minus 2x exponential decay. Let R as the base of the solid. For the solid, each cross-section perpendicular to the x-axis is a rectangle whose height is 4 times the length of its base. So what is the volume of the solid? Okay, so the first off, we need to find what this point of intersection is using calculator. Let's call it A. So the expression for the volume will be integration from A to 4, and then the side of the or the length of the so-called rectangle, which is, let's say, L, and the width or the height, which is W, and then dx. I'm saying it as height because this is like a 3D image, right? The rectangles are coming out of the page. Now it's given that height is already 4 times the length. So this will look like integration from A to 4. Height is 4L dx. 4 comes out, integration from A to 4 L square dx. Now what is the length? Length is obviously this upper function's height minus the lower function's height, right? That's what is going to be the L. So upper function is root x, lower function is e to the minus 2x. So that's going to look like 4 times integration of A to 4 and then square root of x minus e to the minus 2x square dx. Now all I have to do is go to decimals, find the point of intersection A, and then type everything in over here. So let's do that. Over here, we are going to erase the function because I have a new function now, which is square root of x. The square root function you can find on the bottom left panel, where there you go, square root of x. Let's drop this again. The other function g of x is given by e to the minus 2x, and yeah, I need to find the point of intersection. Well, they are coming of the same color. You can just hold the left click for a couple of seconds and then this dialog will open and you can change the color. Okay, anyway, so the point is this. Let's click on this option so that I can get the point here and I can control C this thing. And then the answer will be integration from 0, sorry, the lower bound is the intersection, which is control V. And then the other point is 4, as seen from the question. And then I have, sorry, there's a 4 outside as well in the expression that we wrote earlier. So 4, integration from this, and then parentheses, and then f of x minus g of x, and then we have a whole square, and then we have a dx over here. So this is our answer, 30.24. All right, so 30.24, this is going to be our volume of this particular solid. Yeah. Okay, this is no calc because they are only talking about the integral expression. Let T be the region enclosed by this particular graph and the line x equal to 6 and the x-axis over here. Write but do not solve the integral expression for the volume generated about the vertical line x equal to 6. Okay, Now the line is vertical, guys. So first you have to be very careful about this. If it's a vertical line, then this is always a dy function, as in the bounds will always be of y, right? That's the first thing. Okay. Now if this is rotated, then we are going to first write the expression that it is pi integration, and this is the dy orientation. So the bounds will always be of will obviously be of y, which is from -3 to 0. So that's the first thing. Then this is a disk method, but the radius is not as straightforward. The radius, for example, is only this portion, right? How can I find this portion? Now, this entire thing, what is this entire thing? This is 6. So obviously this entire thing is x equal to 6. And what is this entire thing? Isn't that just the x coordinate of the function? So x. So what is the radius? Or let's call it r. So r will be 6 minus x. But do I know x? No. I need to get the value of x from here. So y is equal to negative of root of x plus 3. I'm going to square both the sides. So y square is equal to x plus 3. So y square minus 3 is equal to x. So this I'm going to sub in over here. So r will be equal to 6 minus y square minus 3. So this will come out as 9 minus y square. That's the r value. This we can sub in over here, which is 9 minus y square whole square dy. So this is the expression for the volume of this particular question. So this was a slightly challenging one, but yeah, I hope the solution makes sense. Okay, the last question. This is calc active, yeah. Wild boars enter a community in Georgia at a rate modeled by this particular function, and they leave at this particular rate. Both E and T are measured in boars per year, and T is measured in years since 2010, and 2010 is considered when T is equal to 0. How many boars enter the community over the 6-year period from 2010 to 2016? Give your answer to the nearest whole number. So isn't that just a pretty straightforward question where they are just asking how many total enters? So we have to integrate the rate at which they are entering and integrate that from 0 to 6, because 2010 is considered t equal to 0. So 2016 will be t equal to 6 over here. So let's open Desmos. So let's enter the function that is for the entry. That's denoted by fx is equal to 200 plus 40. I don't have to worry about the radian because I mean it's already in radian mode, so I don't have to worry about that. And then gx is the exit. Let's call it 30 plus 1.7 x squared. We are looking for the integration from 0 to 6 of fx dx. So to the nearest integer, this comes out as 1353. Okay, so I'm going to say that integration from 0 to 6 of e of t dt to the nearest integer is 1353. The unit as well, I think it makes sense. So BOARS, boars. Okay. What is the average number of boars that leave the community per year in the 6-year period? So average number that leave will be the total number that left, which is the integration of L of t d of t from 0 to 6. And then average will be you divide by 6 minus 0, or just 6. So let's type this in. So here integration from, or let's type in 1 over 6 plus 1 over 6 first. 1 over 6 integration from 0 to 6. Then I have g, right? G is the function for the exit. So g of x and then d of x, which is coming as, all right, so that's coming as 50.4 over here if we type this in. So this is 50.4 over here. And the unit is, of course, boars per year, because this is an average value. Okay, next is at what time between 0 and 8 the greatest number of boars in the community. So the greatest number of boars in the community will be when so this will be a good way to think about greatest number. When is this greatest is, we first have to find the number of boars at any time.
So the number of Bohrs at any time will be obviously the total that have entered. So let's say the total that have entered is represented by, I don't know, let's call it M of t minus the total exit. So at any point, this will be the number of Bohrs in the community, right? Now, if I want this to be maximum, obviously I want the derivative to be equal to 0 and, apply the candidates test and all of that. And what will be the derivative of this? The derivative of this will be the derivative of the derivative of the entry. And isn't that already given? The derivative of the entry is E of t, because E of t is the rate at which the Bohrs enter. So this will be nothing but E of t, and this will be nothing but L of t, because this is exit, and this should be equated to 0 to find the critical points, and then apply the candidates test and find the greatest number, right? For candidates test, of course, I will type this in Desmos and find out what the critical numbers are when they are equal to 0. But I also have to figure that out at the end points. So end points are 0 and 8. So I also have to make sure that I get the end points value as well. And the greatest number will, of course, be nothing but the integration of integration from this particular 0 to that particular time. In other words, what I want to say is 0 actually doesn't really make any sense, but I'll just come to that in a minute. What I want to say is the total number will be the entry, which is E, minus exit rate, which is L, and this is supposed to be integrated from 0 to some time t, and these t we are going to write here. Now obviously 0 doesn't make sense because 0 to 0 is just 0. It's not like they are starting with some number, right? Usually in the question, if they start with a particular number, they will tell you that, but they don't mention, so it starts from 0. So at 0 there is nothing. Now we are going to find the critical points and also figure out what this is. So let's go to Desmos. All right. So first we need to find where these two intersect between 0 and 8. So let me just restrict the domain from 0 to 8 over here for this one, as well as for this one. Let's zoom out. There you go. So it looks like they are not really intersecting anywhere. Actually, that's good for us. That's actually less work because there is no critical point. So all I have to do is figure out at the point 8. So I'm just going to integrate this thing from 0 all the way to 8, and then parentheses, and then dx over here. So this will be the greatest number of Bohrs in the community, which is 1184.46. So this will be 1184.46, and there are no other critical point, no critical point actually, which is just first and last one. Okay. Was the rate of change in the number of Bohrs in the community increasing or decreasing at t equal to 5? So rate of change increasing or decreasing means they are asking the derivative of the derivative. So the derivative for first derivative we already have, right? B prime is equal to E prime t minus L prime t. So they are asking what is the rate of change of this. So another derivative. So B double prime will be E double prime t minus L. Sorry, this is not E prime. This is just Et minus Lt. And when we take the derivative of this, it will be the first derivative minus this. So in Desmos, we need to figure out what is the value of E prime 5 minus L prime 5. If it comes out as positive, then we'll say increasing. Negative, then it's decreasing. Let's go to Desmos. All right, so I need to find what is F prime 5 minus G prime 5. And you can see that this is coming as negative. So obviously that's decreasing. So this is coming as negative 35 around. So negative 35 means the rate of change is actually decreasing over here. That's the answer.